right. Good morning or good afternoon, I guess, depending on where you're coming to us from. Welcome to the Generative AI Leader event. I'm going to be your instructor for the next couple of days. My name is Patrick Haggerty. Um, most of my background is in the application development world. Um, I've been writing code off and on since maybe 1980. I guess I got paid to start writing code in the early 1990s. Um, I got into Google Cloud about 6, 7, 8 years ago, something like that. One of my clients wanted me to help them develop an application, and they wanted it to run in Google Cloud. And I knew a little bit about the cloud at that point. I hadn't spent lots of time, but I had done a few things. And it was really my first time getting into Google Cloud. And I thought, well, this Google Cloud stuff makes a lot of sense. Fast forward to April of 2023. It was April of 2023 when I was contacted by Google. In addition to teaching for Google, I also get to write courses. I build marketing events. I build labs. I do a couple of things for Google like that on the content creation side. And April of 2023, they reached out to me and they said, we'd like you to help us build a class on generative AI. And in April of 2023, I remember saying, I don't know enough about generative AI to build a class. And Google said, oh, that's okay. We got a lot of geeks at Google. They know all about generative AI. If you want help, with the content, we'll hook you up with these geeks at Google, and they'll tell you about generative AI, which they did. I heard more about generative AI and how it's built than I ever wanted to know. Now, most of the technologies I work with, most of the things we deal with in our daily lives are more than 3 or 4 years old, right? So the shift generative AI has gone through from something that was absolutely unknown. Now, I don't know when you think about the birth of generative AI. Technically, the birth of generative AI happened in 2017 because Google wrote a white paper in 2017, which cracked some very hard problems in AI, and it opened the door to generative AI. So you could say that Google invented generative AI in 2017. Yeah, that's technically correct. But the first time I actually heard about generative AI was ChatGPT, right? ChatGPT was born in November 30th of 2022. So, ChatGPT had a 4-year anniversary, or I guess this year they're gonna have a 4-year anniversary. No, yeah, that's right. So 2022 was when ChatGPT came out at the very end of the year. And, Google brought out several, Google generative AI technologies just after that. So for most of us, the first time we ever heard about generative AI or touched it or anything else was maybe the beginning of 2023, right? So this is really a new technology. Um, Fortunately or unfortunately, I think this is going to be kind of an evolve or die technology, right? There are going to be the people who evolve to leverage generative AI and to make themselves more effective. And they're going to be the people who resist that and say, nah, I don't want to use this generative AI stuff. It's different. It's crazy. It gave me a wrong answer once. Unfortunately, I think at some point that's going to be a really bad decision. I spent some years in the military. And in the military, they talk about a force multiplier. I have maybe a combat force, and I come in and I give them a weapon system or I give them a technology or something, and it makes them a more, effective combat force. Well, generative AI for a lot of people in a lot of kind of jobs is going to be a force multiplier, right? I am tremendously more productive today in my job with generative AI than I was without it, right? I'm good at my job. I'm good at content creation. I'm good at coding, but when I have to do that today, I would feel hampered if you said, I want you to build this new lab and write all this code, but you can't use generative AI anymore. It would feel like I had lost my best friend, helper. So as leaders, we have to kind of understand a little bit about what all this hoopla is, right? And that's kind of the goal of this event, right? This event is to help us sort of discover the business value and impact of generative AI. I just said it's an evolve or die technology. The implication is if we don't adopt generative AI, we could die. Well, I don't know about die, but we could certainly get left behind. So, why is that true, right? What are some of the core concepts that we're going to be dealing with in this course? What are some of the core layers of kind of this generative AI landscape that we're talking about? Um, what are some of the components in generative AI? And how can we take these components and think about putting them together in solutions? And, what is kind of, scaling solutions, generative AI implementation? This is all stuff that we want to talk about. Now, I put together a document over here. You can find this document at tinyurl.com/Gale0129. That should just redirect you to this document right here. It is a Google Doc. Some of you, if you are on an organizational machine, may be blocked from getting the Google Doc. They will also email you a PDF copy of this after the event. So if you have trouble getting into this document now, if you can't get into Google Docs, one thing you could do is you could get into it on something like your phone, or a personal device. As I said, after this class, they will also set up a PDF version of this. Anyway, you'll see that linked course content, tinyurl.com/Google-Gale. That is the course content I'm going through. That is these PDFs that I'm starting with over here. So for now, if nothing else, even if you can't get to this document right here, use this URL here, tinyurl.com/Google-Gale, and you can download a zip file of the PDFs I'm lecturing through. So if you would like a copy of your own, PDFs that you can follow along with, you can grab that. A couple other things I mentioned in this document. We have an office hours that's going to happen next Friday, February 6th at noon Pacific time. In the office hours, I'm mostly going to be talking about kind of test taking strategy. This class, honestly, is mostly about content that's on the generative AI leader certification. It's about content you would need as a generative AI leader, but they don't really talk about like test strategy too much. In the office hours, I'm going to be mostly talking about test strategy. Most of those office hours, I'm going to be going through actual Gale test questions from the certification people, written by the same people who write the certification. And I'm going to be talking about, what does the actual exam look like and some of the details. I won't do too much of that today. We're also going to add some replay links in here after this event. If you want to go back and watch some of the sections of the event, I think they have them up for 2 weeks. Okay? I think they're up for 2 weeks after the event, if I remember. But they will have the videos up for a period of time after this event where you can go back and watch. I have a link to our general help email address. A week from now and you haven't seen your voucher, or you have a question about something else, you're welcome to shoot an email there. The after class email that you will receive from Google containing your voucher will come from that email address. Sometimes people find that goes to their spam. So after this event, you are going to get an email. And in the email, there's going to be some links to those replay links. There's going to be a link to a PDF version of this file. There's also going to be your exam voucher code. So you want to take a free cert exam, you want that voucher code, and that'll be in that email. The exam voucher codes we are giving out are good through February 21st. So you need to set up the exam sometime between now and February 21st, which is actually a pretty good window of time. I usually tell people, if they're going to do a certification like this, to set up the exam 2 or 3 weeks after the certification course. So 2 or 3 weeks from today is about the perfect time to take the exam. Okay, well, if you're going to do that, if you're going to take the exam in 2 or 3 weeks, this is perfect. That's plenty of time. But the vouchers are only going to be good through February 21st, so keep that in mind. Google is actually switching like the way they're doing certifications before the 21st and after the 21st. They're using 2 different systems. So the vouchers are only going to work with the system they're in now. They're not going to work with the newer system. My contact details are in here. If you would like to reach out to me after this event and shoot me an email or WhatsApp me or something, I got my contact details in there. I have some helpful links on the exam and registering for the exam and the exam guide. And then I might add some links to this as our class goes on today. Okay. So you can find all this in this document. Again, this document is tiny URL Gale 0129. So today's date, at least for us over here in the US. To my Paul, my helper in the UK, he probably thinks that date looks weird. But anyway, tinyurl.com/Google-Gale is the course materials. All right. In the chat window there in YouTube, I just mentioned Paul. Paul is one of the technical people in the chat window who's going to be answering technical questions. And we have, I don't know who all. We have a whole slew of people who, Candace, Donna, maybe May, I don't know all the other people that we have in there that are answering questions about how the process works. But suffice it to say, we have a number of people, technical and non-technical, in the chat window there to help answer your questions. I'm lecturing. I'm focused on that. Don't suffer in silence. If you have a question as I'm going through, your resource to get that question answered is go to that chat window, ask a question. We've got people out there that are going to help you out. Okay. So the generative AI leader certification. The generative AI leader certification, if you're looking at my document, you see I have a link here to like the Gale certification homepage. If you go to the Gale certification homepage link, which is the same link as that bottom one on the bottom of the page, this is sort of your central page where they will tell you about the generative AI leader cert. Okay. The generative AI leader certification is a 90-minute certification, and you've got 50 or 60 questions in 90 minutes. Okay. For what it's worth, your goal should be, one question per minute. Your goal should be about one question a minute. When you are on the certification, there's like a timer up here, and there's a button down here that says mark for review. There's also a button that's like next and back. So when you're going through, what I would do is about every 5 questions, look at the timer. I don't want you to watch the timer. That just stresses you out, right? But about every 5 questions, you should check the timer. And how's your progress going? If you're 5 questions in and the timer says you're 5 minutes into your exam, you're doing pretty well, right? If you're getting behind, in life, it's good not to let a problem go until you figure it out. On certification exams, it's not good to burn time on a question, right? So target about 1 minute a question. In 90 minutes, if you have 50, 60 questions, what that says is you go through and you hit a question and you figure the answer out, you answer it, you move on. You hit a question, you're not really sure you got that one right. Okay. If you're not really sure you got that one right, then you hit that button down there at the bottom, mark for review. And you say, okay, mark for this one for review. I'm going to go back and look at this one later on. You go through the entire exam. It's taken you 50, 60 minutes, which means you should have 30 or 40 minutes left. When you get to the very end of the exam, it will show you all the questions that you have marked for review. So now the theory is, you've been through the entire exam. You've answered all the ones you're sure about. You have some amount of time left on the timer. Now you can go back and spend that extra time on the questions you weren't sure of. You can go play second guess yourself, right? So that's sort of the most basic test taking advice. This is a multiple choice exam. You have a question, you have 4 answers, you got to get one of them figured out. Every answer you can get rid of from the list, you are improving your odds of answering that question. Keep your timeline, make it through the exam, take that extra time to go back for the questions that you marked for review. What you need to know to pass this exam is actually listed in detail on the exam guide. Okay. If you're looking at my links page, I have a link to the exam guide. It's also on that main Gale page. If you go to the exam guide, it pulls up a PDF. And in the PDF, it'll say, well, 30% of the exam, they're asking you these kinds of questions here. And then 35% of the exam, they're asking you these topics here. This is a leader certification, right? This is a leader certification. To be a generative AI leader, I'm not expecting you to be a developer like me, right? I'm expecting you to be a leader. I'm expecting you to be able to manage a team of maybe developers like me. Or maybe you manage a team of other people who manage teams of developers like me. I'm expecting you to be able to communicate intelligently about generative AI. You should understand when I talk about things like, I think we should fine tune that. I think we're going to use some grounding here. I want you to understand what that means. I don't want you to just give me that glazed eyed look where you don't have any idea what I'm talking about, right? If you're going to be a leader in this world that is radically shifting towards generative AI, I mean, come on. I saw a little funny the other day. It said, who are we? Managers. What do we want? Generative AI. Generative AI that does what? We have no idea. This is where we are right now. People hear about generative AI. You can't go to some leadership conference where they are not talking about generative AI. Just like I can't go to a cloud conference where they're not talking about generative AI, right? Generative AI is such a huge thing these days. You need to understand what that means to your organization. What things in generative AI should you be embracing? What should scare you? What should you be doing if you're an upper level manager? What should you be doing if you're a mid-level manager? What should you be doing if you're a worker down in the trenches? How is generative AI going to impact you? The goal of the generative AI leader certification from Google is to test if you understand core concepts and terminology around generative AI. And since it is a Google certification, do you understand Google product names, right? That help you with this stuff. Honestly, that's really the main things. That's really the main things that you're going to be tested on in the certification. Do you understand core generative AI terminology and concepts? Do you understand product names? If you look at this Gale document, right, and you scroll through this document and they're talking about things like pre-trained models, and they're talking about things like gems, and they're talking about things like Notebook LM, and they're talking about things like Vertex AI search and Google search and conversational agents and RAG APIs, and what is RAG in general. And this is all product name, technical term, product name, technical term, technical term. That's the, bias, fairness, hallucinations. This is what you need to understand. This course in 2 days is going to fire hose this content at you. There's a lot of stuff I'm going to cover in 2 days, and I don't talk slow. So you're going to hear a lot of terminology. You're going to hear a lot of product names, and I don't expect them all to stick. I don't expect you to remember them all. But if you want to successfully pass this certification between now and when you schedule the exam, and as I said, I would wait till I got that certification voucher code, because you can't register without the voucher. And again, you got to register sometime between now and the 21st. So start looking at your calendar now. When do you want to take this certification exam? Saturday morning is the wrong answer. I think you need to give yourself time to review. Lots of product names, lots of terminology, lots of technical terms, right? So give yourself at least a couple of weeks, and in your spare time, you're leafing through the pages of this slide decks that I gave you. And every single slide you get to, is there a product name or a technical term on the slide that I don't know what it means? And then same thing, can you just read through all these bullets? And if they come up with something like prompt engineering, could you give me a 1 or 2 sentence description of what that is? Do you understand it? If the answer is no, then you need to put that on the things to memorize or things to learn. I hate certification exams. I really do. I don't do well on certs. I don't like them. I don't enjoy them. I miss my Google search and my Google Gemini, because you can't have them on your exam, obviously. I don't like certification exams. When I have to take a certification exam, I have to put in the time to study for it. I know that. I also grab my iPad And in my iPad, I create a note that's titled "Stupid Stuff to Memorize," because I swear, every time I start prepping for a cert, there's certain keywords, there's certain product names, there's certain terminology that for some reason my brain is not absorbing. And so I put it in my stupid stuff to memorize notes. And every day between now and the certification, I start my study by going through my stupid stuff to memorize to see, are there things that, do I know all this stuff? Am I remembering this stuff? So you have to have a certain amount of knowledge in your head. You don't have access to Google search. This is certain things you have to have memorized, right? So now to 2 or 3 weeks from now, that is your opportunity to go back and any terminology they mentioned in this course, any product names they mentioned in this course, you should know them. You're going to get asked about them. This, I think, does a very nice job of teaching you that stuff. The first time I went to teach this cert prep class, I went and took the exam, right? I went through the course. I went to the exam. I can tell you they do a fair job of preparing you for the cert. They have the right terminology. They have the right product names, etc. Now, they have a number of these short videos throughout this course. I'm not going to take the time to watch them. You'll have these PDFs. If you want to go back, all these videos are like 2, 3, 4 minute videos. You're welcome to go back and watch these videos on your own. Okay. So generative AI is a part of the AI world. The AI world is mostly, I'm trying to build machines that are more human, if you will, right? That's kind of the overall goal. Mostly, I'm trying to build machines that can talk like a human, sound like a human, and can, to a certain degree, reason kind of like a human. Generative AI is a subset of the AI world that's focused on creating content. That's true, but it's also not the whole story. You know, the name generative AI, I don't have a better name, but the name generative AI is what you hear it called everywhere. And sure, generative AI can do all kinds of stuff. But to me, it's not just that it can generate content. To me, what's interesting about generative AI is I can have a conversation with it, right? The easiest way to imagine your generative AI partner is you have a person that you can chat anytime you want to, right? They're always there. They're always annoyingly happy. And they have access to like everything Google search has access to, right? That's what's kind of amazing about generative AI. The other thing that's really amazing about generative AI, honestly, is generative AI, it can consume content. So it can read text, it can watch videos, it can listen to music, it can look at images. It understands what it sees and understands what it sees in a very human way. It understands what it sees in a lot of similar ways to the way you would understand what you see. And then what it can do is it can generate or handle tasks, talk to you, right? Then what it can do is when they say generate, it's not just I ask it one question, it does one thing, we're done. It can talk to you. You can have a conversation with it, right? And when I say it consumes content, what is your content, right? Are you a media company and you have hours and hours and hours and hours of video? And you would like something to watch the video and help you answer questions because you need to find certain segments of video. And, the way they do that now is they have a human watch the video and the human like identifies where the scene changes are and the human like writes descriptions and stuff like that. Yeah, but if the human doesn't put some little detail in the description, you can't find it in the video. Generative AI can watch the video with fresh eyes, if you will, and you can find pretty much anything you want. Do you want to write I had a meeting yesterday. I'm going to be developing a lab for Google using F1 race data, which sounds fun. And so they were talking, I have this meeting with these F1 people, and they were talking about how all the F1 regulations just changed. Okay. Do you have a bunch of PDFs that contain all the regulations, all the new regulations for F1 racing? Would you like me to build you a chatbot that can consume content, that can read all the F1 regulations? It can understand those regulations, and then you could ask it questions about them, right? Hey, we're thinking about doing this. Will this comply with the regulations? So when we say it can consume data and it understands and it generates, it's not just that I can go somewhere like Gemini. And here I am in Gemini, and this is a chatbot. And I'm coming to the chatbot and I'm like asking it a general purpose question. It's not just that. I can feed it a particular set of information. How about instead of F1 regulations, we're going to feed it your organizational policy documents? And your question is, I have a question about policy documents. I have a question about vacation policy at company X. Well, if I get it to read all the company X policy documents, then it understands those policy documents probably much better than any of us will. And it can now answer questions or handle tasks related to policy documents. So generative AI is not just interesting because great, it can create kind of stuff. Can it paint a painting of a dog? Yes, it can paint a painting of a dog. But is that going to be business useful? For a lot of us, the answer is probably no. But the ability to read a big pile of regulations or read a big pile of policies and understand them and then answer questions about them and have that done in minutes, that's something that's amazingly useful in the work world, right? So when you talk about generative AI, it does help you with new content, but it also has, this ability to look at content and you can control what it looks at. And then it can generate or answer questions or whatever else you want to do from that content. So what kind of things can it do? Well, it can certainly create things. It is creative and it's not creative. Generative AI, honestly, is like a really, really fancy parrot, right? If it's something that generative AI has seen before, it can sort of derive from that and sort of combine it new ways. If I go to generative AI and I say, I want to build a LinkedIn post. I did that this morning, by the way. I went to generative AI and there was an interesting article I just read and I wanted to build in a LinkedIn post about it. And so I handed generative AI the article and I said, I want to build a LinkedIn post about this. Can you help me? Do you think generative AI has read like probably all the posts on LinkedIn? Yes. Along with lots of other social media websites. So the minute I say LinkedIn post in generative AI's head, it's saying, hey, do I know anything about LinkedIn? Oh yeah. I've read millions of LinkedIn posts. Okay. So yeah, Patrick's asking me to create a new LinkedIn post. Do we know what LinkedIn posts look like? Of course, we've read millions of them. Let's look at all these millions of posts. What kind of things seem to work well in a post? Right? Do you have hashtags at the end? Do you try to make it sound exciting? Do you have little emoji and so it has seen a zillion LinkedIn posts. So when you say, I want help creating a LinkedIn post, it knows how to do that. If you say, I want you to help me create a romance novel set on the International Space Station. Generative AI is going to say, do I know anything about romance novels? Yes. Do I know anything about the International Space Station? Yes. Do I know anything about romance set on the International Space Station? I imagine the answer is no. I've never heard of a book that was a romance set on the International Space Station. So, that's not something it really knows. But can it kind of put the two together? If it sort of understands romance novels in general and the space station, could it come up with ideas? Yes. What I'm telling you is you have more true creativity in your pinky than generative AI has in everything it can do. Generative AI is really good at things it's seen before. And when you ask it to be creative, just like I said, even if it's never read a book set on the International Space Station, if it understands how romance novels work and it understands how the International Space Station works, could it come up with some ideas at least? Absolutely. If I were a romance author and I was writing a book of a romance on the International Space Station, generative AI could offer me all kinds of advice. Right. It could offer me ideas. But again, all of its ideas are kind of regurgitated. All of its ideas are based on things it knows. It doesn't really have that true creative ability to go to something it doesn't know. Right. And that's something you have to remember. In the generative AI partnership, you should be the creative genius. In the generative AI partnership, you should be the decision maker. You have intuition that you can rely on that generative AI doesn't have any way of understanding, right? You have to be the boss. you have to be the team lead. You have to manage, right? Generative AI can do something that you can't do. And that is it has access, especially when you pair it with Google, to just unimaginable information, right? So, for example, if you were writing a story on the International Space Station, I did one time. My hobby is writing fiction. So I was writing a story on the International Space Station one time, and one of my astronauts needed to get out of the International Space Station quickly. And so I was thinking, I'm like, how long does it actually take an astronaut to get out of the ISS? Okay, it took me hours and hours and hours to research that for what it's worth, because this was in the days before generative AI. And the answer is a long time. It takes them hours. They have to go through decompression, or they can get the bends, and it takes hours and hours and hours to get out. So this idea that I'm just going to throw my spacesuit on and jump out of the space station, that is pure fiction, right? Now, these days, if I were writing that same story and I wanted to research, what kind of gear do they have? How do you put on a spacesuit? How do you get out? I could go to Gemini and I would have the answers like that, right? So when you say creative, create articles, write emails, write social media posts, create images and videos and audios. Generative AI can do all this stuff, but you need to guide the process. It's not going to be as good at you as at true creativity, but man, can it give you ideas. Summarization. What's the secret to summarization? Read, understand, generate. Summarization is like a core ability of generative AI, because anything you feed it, it can read and understand. And then, the art of summarization is you have to read and understand, right? Discovering things in the data that you may be missing. Well, absolutely, right? Can it help you spot certain types of patterns? The generative AI, I could point it at just tremendous piles of things like documentation, and it can find things in that documentation that you just never have the time to find because there's just so much to it. And automation, you say automation to me, and the first thing I think is I'm going to write a script. I don't think initially generative AI. But remember what I said. Generative AI is all about, consuming information, understanding what it sees, and generate. So do you have some sort of automation that revolves around that? Um, if your automation revolves around that, hey, we're shooting these videos and people are providing us feedback on our product, right? So we have hours and hours and hours and hours of feedback, and we want to convert that into actionable information. Oh, well, yeah, that's something that generative AI can do. Because in order to do that, you really need someone to watch the videos, understand what they're seeing, and generate reports. Guess what? Generative AI can knock that out in no time. A lot of your big models now, like Gemini, are multimodal. Multimodal means when you're in the middle of doing something, you can hand generative AI, a picture of something. You can hand generative AI a picture of something, and, it can see what's in the picture of what you hand it, and you can work from there, right? So, here I'm in the middle of getting Gemini to help me do something, and it's using a wizard in Google Cloud. And so while I'm going through this wizard in Google Cloud, I'm showing Gemini pictures of where I am. I'm asking in this step for Gemini to help me write this goal statement right here. Okay, so I'm in the middle of a wizard, right? I'm in the middle of a wizard in Google Cloud. I want help writing this goal statement. And so I'm kind of showing the picture to Gemini, because I'm sort of telling Gemini that's what I'm doing. I'm creating the playbook for this agent. I'd like you to help them draft the goal or description statement. I'm telling it what I want it to do. I've already kind of set it up. I've given it our overall task, what we're working on, but I'm showing this picture. So I'm kind of saying to Gemini, I'm right here filling this box in. Could you help me fill that box in? That's multimodal, where you can actually give Gemini, the image or the video together with the text, and you can use them at the same time, right? So that's kind of cool, because I'm being able to kind of combine them. Give me 1 second. I'm sort of being able to combine them, and all at the same time, different modalities, text and images. That's what I was doing. A marketing team wants to use AI to generate a series of social media posts with accompanying images. Ooh, I do this all the time. I have to create technical content, right? And when I'm creating technical content, The other day, I was doing a proposal for Google for a new event they were hiring me to write, and I needed an infographic. I needed an infographic to go along with the proposal, right? And so I went to Gemini and I'm like, Gemini, I need to create an infographic to go along with this proposal. And then I said, don't create the infographic yet. Let's have a conversation first. And so we had kind of a conversation about what would make a good infographic for this. What kind of things should be in this? What should we leave out? Kind of what. And finally, then I'm like, that's fantastic. I love that idea. Build it. And Gemini knocked this out. I have no artistic ability whatsoever. Both my parents are artists. I like got none of those genes, none. I can't do stick figures. So the ability to create, a nice infographic for the middle of a proposal, or the ability to create a nice image for a book or something, right? I'm just finishing building a technical book on Google Cloud stuff and same kind of stuff. In my book, I needed images to illustrate certain things. Okay, so if I need an image to illustrate something in the middle of a book or in the middle of a slide deck, I don't really have those skills. Guess what? Gemini does. Text and PDF file. Legal team wants to use AI to summarize a lengthy. Oh, absolutely. You got a big PDF file that's hundreds or, thousands of pages long, and you want somebody that can read and understand it. That's like a core skill in Gemini, right? It can do that. It can look at images. It can look at, video, whatever you want. Here's my kind of customer sentiment in video, so we're recording feedback and we want to make that actionable. Or maybe what we have is we have sensor data and we're collecting data from sensors and we're trying to look for certain things in the sensor data, right? Product name. Now, in the Google Cloud world, they have kind of a subsection of products in Google Cloud that's titled Vertex AI. Oh my gosh. My puppy dog here. I think he just heard something and he's oh my gosh. Anyway, so Vertex AI is really a collection of products that are designed to help you do different things with AI. Some of these collections of products are for generative AI. From kind of up here down to maybe here, this whole left-hand menu is all about generative AI. But then it gets into more general purpose stuff. Jupyter notebooks. If you are maybe a data scientist or an AI developer, you might need Jupyter notebooks. Speaking of AI developer, all this stuff down here is all about, I need to build a custom AI model to do something, and then I want to store it somewhere and I want to actually make it run. So Vertex AI is like this whole part of Google Cloud that's dedicated to different sorts of AI topics, right? Or different sorts of AI needs, I guess we should say. Okay. This course has a number of short quizzes like this. What's good about these quizzes is they are asking you important questions, testing important knowledge. So the knowledge that they're testing with these little quizzes is very useful, and it's stuff you should know. But to think that these questions are written like exam questions is a mistake. That is not true. The problem is these questions are not trying to mess with your head. These questions are asking you straightforward questions with straightforward answers. The certification exam from Google is not straightforward at all. The certification exam for Google, they are actively trying to trick you sometimes in the way they word questions and in the way they word answers. So quizzes are good. They're asking important things. Which of the following defines generative AI? Knowing the definition of generative AI is going to make sense on the exam. It's a type of artificial intelligence that analyzes existing data to identify patterns and make predictions. We're going to learn that's probably more classic AI. It's a type of artificial intelligence that can create new content, including images, text, and music. I think we probably have a winner. Now, one thing I'll say about any quiz is don't ever stop when you think you found the answer. There are lots of questions in the real Google certification exam where there are two right answers. Okay. And then the problem is going to be, why is this answer more right or better than this other answer? There's going to be the obviously wrong answers, but there's going to sometimes be where there's two possible answers and both of them are possible. But there's going to be something better about one answer over the other, right? So if you find a right answer, and I think that's pretty right, note it, but don't stop there. It's type of artificial intelligence that focuses on automating repetitive tasks and improving efficiency. It's not really corely about automating. Okay. Like I said, it might be okay with automation around read, understand, generate. But if it's different automation, automation is not one of its core abilities. It's a specific application like a chatbot that uses AI technology. No, no, no. Yeah. So the only one that's really going to make sense here for us is that letter B. A CEO is hesitant to invest in generative AI because they believe it's just a technology for building chatbots. Which of the following examples demonstrates that generative AI can offer business much more? Uh, yeah, this is a mistake, and I've heard people say this. Chatbots are probably one of the easiest examples of generative AI. So, I've already given examples where I got a big pile of policy documents and I want to build a chatbot for policy documents or F1 documents, but it's not necessarily that. Think about read and understand. I worked for a bank, and what they wanted to do is they had one email address, info@bank.com. And when the email comes into info@bank.com, they needed something that could read the email and forward it to the right department. Okay, that's no kind of chatbot, but something Gemini would be really good at? If you told Gemini, here are our 5 departments, and you maybe gave a brief description of each of the 5 departments, and then you said, okay, Gemini, here's an email. Which department should it go to? Gemini would be fantastic at that because it would understand the departments. It'd probably understand the departments just based on the department name, but a little description would be nice. And it understands how to read an email and handling that routing. There's nothing chatbotty about that. But again, what is its strength? I don't care what industry you're in. I don't care what job you have. I don't care what you do for a living. If you want to know about how generative AI can help you, always go back to that core strength. I can feed it any kind of data. It understands it much like a person would. And then how is it understanding that is going to help me? Can it help me summarize? Can it help me, create things that are similar? Can it help me reword it? Can it help me, all this stuff? Okay, so counting the number. Okay, which of the following examples demonstrates that generative AI can offer their business much more? Counting the number of website visitors and their locations. I don't think we need any kind of generative AI that does that. So I'm going to say no. Scheduling meetings and managing calendars to help employees improve their time management. It could do that, but I'm not sure that's a possible answer, but I'm not sure that that's really the best answer or the one that they're looking for. How's that? There's only one opinion that matters on the certification exam, and that's Google's opinion, right? So one thing I have to say that's a little odd about certification exams is, it's not just that you understand what's best. It's that you really need to understand what Google thinks is best, right? There are times that Google and I may have a different opinion on how to handle something, but I know what Google's line recommendations are, right? And on the certification exam, the only opinion that matters is Google's, right? Creating photorealistic images of new product prototypes based on their text descriptions. Okay, that is clearly generative AI. I'm thinking that's a slightly better example. Yes, generative AI could help with scheduling meetings and managing calendars, but that's not something that's like uniquely generative AI. The generating photorealistic images, I think that's uniquely generative AI. Providing generic responses. Okay, can you already tell that this is not the right answer? Providing generic responses to all customer inquiries. Thank you for contacting the bank. One of our customer service reps will get back to you. No, that's not what it's for, right? So probably the one that's going to make the most sense is the photorealistic images. Which of the following describes a multimodal Gen AI application? Multimodal. It needs to work with different kinds of data. Some text, an image, Using Gemini and Gmail to write an email. Nothing multimodal about that. Using Imagine to create an image for a website. Now see, so Imagine knows how to create images. Okay. Using Notebook LM Business to summarize a financial report. Using generative AI to analyze customer sentiment in video testimonies and survey data. Now, I have to say, it's a little unfair for you because we haven't talked about Imagine and Notebook LM yet, right? So if you don't know what Imagine and Notebook LM are, you might be thinking, well, Imagine can create images. That's actually true. Yeah, but that's not really multimodal, right? It's kind of like Using Gemini to write an email, there's nothing multimodal about that. Using Imagine to create an image, it's still kind of only a single modality, build an image, right? Using Notebook LM Business to summarize financial reports. Now, if they had said something like to summarize financial reports containing a combination of images and text, that might have been what they wanted us to do. Using generative AI to analyze customer sentiment in video testimonies and survey data. So, in other words, text and video, that's multimodal. Okay. If you're wondering our schedule, we are operating on Pacific time, California time. So we're operating on West Coast time. We kicked off 9 a.m. West Coast. We're going to take a morning break, probably about 30 minutes. So at about 10:15. We're going to do an hour for lunch, 12 to 1, and we'll have an afternoon break, 2:15, 2:30, something like that. Our official end of day is 5 p.m. Pacific. If you're over on the East Coast or Central time like me, so it'll be a little later for you. Anyway, so that's kind of what our time schedule for the day is going to look like. If you were not here when I displayed this document right here, I have a document that I have a zip file that contains the PDF I'm lecturing from. So that tinyurl.com/Google Gale. If you want to download a zip file of the PDFs that I'm lecturing from, so you can follow along with me, that's it. tinyurl.com/Google Gale. I have some helper links in here you can also find using that QR code, which just redirects you to this document. And so does this. That tinyurl.com/Gale0129, today's date, that will redirect you to this document. And it's just because I have some other links in here for you, right? If you can't get to this document because it's a Google Doc, don't bother requesting access because you should already have access unless your company is explicitly blocking me, right? So if you're not getting access to this, they're going to send you a PDF version after this event. So you'll get a PDF version after the event. But again, the tiny URL Gale0129 goes to this document. More importantly, probably for right now, tinyurl.com Google-Gale, that is the PDFs I'm lecturing. So you want a copy of the PDFs, you can get them from there. Okay. In the AI world, you have kind of a couple of major families. And we're going to talk about this in a little bit more detail coming up. But there's kind of the traditional AI family, and then there's the new sort of generative foundational family. The traditional AI family was mostly built around single purpose models that are designed to do one thing by picking up patterns in data. Here's 10 years of credit card transactions. Here's all the columns of information I know about every single credit card transaction. And here's a column that tells you, was this transaction fraud or not? And I want to build a traditional AI model that is really good at one single narrow thing, and that is detecting possibly fraudulent credit card transactions. Because when you go to swipe your credit card, I want to be able to do a quick check and say, do I think this credit card transaction looks like it's going to be fraud or not? Okay, that's a traditional model. I'm driving in my car, and my car, if I get too close to the edge of the lane, it like bumps me back in the middle of the lane. I'm driving in my car, and it's automatically doing high beams, low beams. I'm taking my phone camera, and I'm about to take a picture of the family, and it's putting little green boxes around everybody's faces. I've got my video, and I'm shooting video, and it's stabilizing the video for me as I'm shooting it. Those are all traditional AI models. They're all around us. Hey, Google, what's the high temperature going to be today?
It's currently 52 degrees and cloudy. This afternoon in Moss Point, the high temperature will only reach about 55 degrees with sunny skies.
It's going to be 55 today at my house. Okay, it's what Google just told me. Speech to text, text to speech. These are all traditional AI models, and they're kind of built to do one main thing. Foundational models tend to be broader in scope, right? Foundational models we'll talk a little bit about later on, but foundational models are neural networks. Deep learning is technical terms. I don't think you have to know that on the exam, but that's what they are. Foundational models, they are built on massive amounts of diverse data. Google has a model that can look at a document and extract all the form data in that document. Here's a form a person filled out. Yes, but Google has kind of two ways of doing that. There's document AI, and document AI is the traditional model, and that's all it can do. You give it a document, it can look at the document, and it can extract the data from the document. Please find the user's first name and pull it out. Please find the user's last name and pull it out. Please find the user's address and pull it out. That's what document AI does. It's a traditional model, and it was built to do that one and only one thing. But you know another thing I could do? I could take a document and I could bring it over to Gemini, and I could just drop the document into the text box on Gemini, and I could say, Gemini, could you go find the user's first, last name, and email address? And it could also do it, because Gemini is built to do massive numbers of things, right? So you kind of have part of the AI world where what they're doing is they're building these very small, very specific single purpose models. At the same time, you have people like Google and OpenAI and Anthropic Claude and X. You have these massive companies that are building these massive models. And their goal is, couldn't we have one model that almost does anything? Right? Instead of having these teeny tiny models that kind of do one trick, couldn't we have these big massive models that do anything? Okay, so you have people that are kind of scrambling to do both right now. Why? A lot of the traditional models, if you can get them working well, they're much cheaper than something like Gemini. So they might do one thing, but if they do that one thing really well, they also might do that one thing very inexpensively. These massive models are just broadly capable, but they may be more expensive than some of the smaller, one trick models. So we're kind of approaching the same problems from two different directions. Foundational models tend to do a wide range of tasks. They tend to develop a very deep understanding of the data. The amount of data they process tends to be massive. So foundational models are these very broadly focused, general purpose kind of models. They're trained on massive amounts of diverse data. I need you to look at all this text, but I also might need you to look at images. I might need you to look at all kinds of stuff. They tend to be flexible. So instead of just doing a single thing, they tend to be very flexible. They tend to be very adaptable. And that's kind of what's nice about them. They might be a little bit more expensive, but they're very capable. For example, I just ran into a use case where the forms that we were trying to read with Document AI, they were handwritten. So people were filling the forms out by hand. And Document AI was not giving us the quality we wanted. It was not reading the handwriting as well as I'd hoped. So you know what we did? We switched to Gemini. Gemini could read everybody's handwriting, even mine. I was surprised. Okay, so Gemini did a much better job of processing those forms. So in that case, I have two competitor products. One's a little bit more expensive, but it was doing the job we needed. Document AI is supposed to do handwriting, but it's really good if it's like typed, but the handwriting support may not be as good as something like Gemini. So is it worth the more money in Gemini? That's kind of the discussion you might get into at some point. Product name. Gemini is the brains behind the Gemini website. Okay. If you imagine this Gemini website, you have a nice user interface, you have access to Google search, and then you have kind of the brains of the operation, the Gemini model, right? So the Gemini model is sort of the thinking part, the reasoning engine in the Gemini website and in any other Google product pretty much. Imagine is Google's mainline image creator. Chirp is a speech to text, text to speech kind of tool. Chirp can do speech recognition, but Chirp can also come up with custom voices. As a matter of fact, you can record a disclaimer and Chirp can duplicate your voice. It's kind of creepy. But yeah, Chirp's pretty amazing on the speech to text, text to speech stuff. All right. Prompting is how you interact with the model. You're sitting here looking at a text box. When Google contacted me in April of 2023, I told you I didn't know much about generative AI. I had played with it once or twice, but I remember coming to a prompt like this, and I remember I wasn't really sure how to approach Gemini. You know, do I approach it like Google search? If I wanted some information, should I come in here with keywords? No, you should not come in with keywords. Gemini was trained on books of data. Gemini was trained on websites of data. In other words, Gemini was trained on text, which was mostly complete sentences with punctuation. I got a text message from a teenager the other day, and I looked at this text message. There were no capital letters. There was no punctuation of any kind. Instead of YOU, there was like the single letter U. And I swear, I look at this text message from this teenager, and my first thought was, this would make a terrible prompt. This is how you know I'm teaching too much generative AI these days, right? But I thought to myself, this would make a terrible prompt, right? So when you're prompting, what you need to do is you need to kind of approach your question or your request. You need to approach the prompt as, how would I ask another person to do it? That's by far the easiest way to think of this. You do not talk to another person in keywords, right? You talk to another person in more or less complete sentences with more or less, punctuation and stuff like that. So when I'm talking to Gemini, in my brain, I imagine I've hired this person, Gemini. It's a she, I decided. And I'm going to go to, Gemini, and I'm going to ask her to do something for me. If I went to an employee and I asked an employee to do something for me, how would I do that? Okay, well, I'm polite. I'm painfully detailed sometimes. I try to think of what would I expect them to know and what would I expect to need to tell them to do, how to do. Gemini, she might be really smart and have lots of data in her head, but Gemini doesn't know my business. Gemini doesn't know my job. Gemini doesn't know anything about me. Gemini doesn't know anything about what I'm trying to accomplish. So if I had a new hire or an intern, Gemini, what things would I need to tell her before she could accomplish this task? Right? That's some stuff that you got to start thinking. Google has a hand guide for prompting in Google Workspace. Now, anytime I want to share a link with you guys, I'm just going to add it to the bottom of this links document here is what I'm going to do. Okay, so, so here's this link to the prompting guide, and this is really the Google Workspace prompting guide. The Google Workspace is, like Google Docs. So this is a Google Doc. It's a word processor. And, there's Google Sheets, which is like Excel, So this is a prompting guide for Google Workspace. Now, I'm not teaching you about Google Workspace right now. Why am I talking about this? Because in Google Workspace, in this prompting guide, they have this kind of interesting little set of tips here. And they say in them, if you are about to do a prompt, then this is some good things you should put in your prompt. You should give the model a persona. Yeah, technically that's called role prompting. Give the model a job or role in your partnership. I told you, I've got this lady out here, Gemini, that's working with me. She and I are working in a team. We're partnered up. Okay. I'm good at big picture. I'm good at thinking. I'm the boss. I'm guiding the process. I'm more creative. I'm more intuitive than Gemini is. But she has access to massively more data than I do and basically can get it instantaneously. She can process images. She can process documents. She can do all this virtually instantaneously. So in my head, I'm thinking about this partnership. And like any partnership, when I first started working with Gemini here, I didn't really know what I should do and what Gemini should do. These days, I'm pretty good at knowing our teamwork, right? But you have to do the same thing. If you are using Google search right now, use it less. Don't do Google search for everything. Pull up the Gemini website and say, instead of Google search, how can I ask Gemini to get that same data for me? I'm not saying that Google search wouldn't work. I am really good at Google search. I can find anything I want in Google search. Okay. But I could find anything I want on Google search, but I wanted myself to get better at prompting. And when I ask Gemini a question and Gemini gives me a wrong answer, because that happens, I then ask myself, um, what could I have done to get a better result? Could I have worded that question differently? Because again, if I'm using the analogy that Gemini is like another person, then, what are they good at? What are they not good at? You know how sometimes you'll say something to one person and you'll say the exact same thing to another person and you'll get totally different results? Same thing's going to be true with Gemini. Sometimes you say something and it's like, why did Gemini do that? Let me think about that. So, what I'm telling you is you have to be proactive to make your prompting better. If you're thinking to yourself, I'm just never going to use this Gemini thing, I think it's going to burn you at some point. So, instead, think to yourself, how can I get better at Gemini quickly? And this is one of the ways. You know, if you look through my history, if you look through my history in Gemini, there's all kinds of different stuff. Retro sci-fi movie recommendations. Obviously, that was not work related. So to have and have not. Here's some interesting questions about trains. My wife and I just adopted these two kids, one's 7, one's 8. And so over last weekend, we broke out this old model train that has been in the attic for decades. And so right now my living room has train cars all over the living room. Right. So I had some questions about one of the train cars here, So anyway, I don't just use Gemini for work because I wanted to get better at Gemini. Role prompt is where you give Gemini a job to do. Right. Hey, Gemini. Um, hey, Gemini. Gemini, I'm going to be studying for the Google Generative AI Leader Certification, and I would like you to help me prepare. Okay, that is a role prompt, right? I'm basically saying, Gemini, in this conversation, your job is to help me prepare for this. Just like sometimes I'll say, hey, Gemini, I just got hired by Google to write a lab on McLaren F1 race data. And what are some good ideas on how we can leverage this data? Okay. So again, the role is give the model a job or a role. Gemini is painfully happy. If it's 2:00 in the morning and you're irritated, let me tell you, sometimes you just want to hit Gemini over the head, right? That's an excellent question. The Google Cloud Generative AI Leader Certification is unique because it's a business technical bridge. Yeah. So anyway, they're telling me, oh, look at this. Hey, you see, it went to that's from that exam guide. It's breaking it down for me. It's telling me some core things I've got to know. It's already trying to be helpful. Okay. Context, details, or instructions Gemini needs before helping with the task. The minute I say, this is what we're doing, you notice Gemini is already trying to be helpful. I haven't really told Gemini, though, what I wanted Gemini to do for me. Okay. Now, you can have a conversation like I'm having, but you also can put more data in a single prompt, right? So I chose to do it with a conversation. This is kind of what we're going to do. And Gemini is already starting to give me some ideas. And that's one of the things I kind of like is Gemini's giving me some ideas. I'm like, that's actually a pretty good idea. We should do this next. But the context would be any details. This is where I'm going to go to Gemini and I'm going to say, I had a meeting with McLaren yesterday, and I'm going to get to take this F1 race data from McLaren and build a lab for Google Next in Vegas in April, right? So I have the data as of yesterday. I don't know much about the data. I also really don't know right now what exactly would be fun to do in a lab. I'm supposed to do a lab. It's going to be probably 2 hours long, and it's supposed to be to make people excited about Google Cloud products, right? So I have the data I have to use, but I also need to make people excited. It's kind of a marketing thing about Google Cloud products. See, that's all context data. This is where I'm going to say to Google, okay, Google, I'm sorry, Gemini. Okay, Gemini, This is what I'm doing. I'm creating a marketing lab. It is designed to get people excited and interested in particular Google Cloud products. Next week, Google's going to tell me what products I'm supposed to make people excited about, right? So I'll say these are the products that we're supposed to be showcasing in this lab. Here's the data that we're going to be using in this lab. So with this data and this particular goal of making people excited, what I want you to do, the task is what I want you to do, right? That's the goal. The context is just background information, right? What does Gemini know? Like I said, Gemini's excited. Gemini's this brand new college grad. Okay. And this brand new college grad is so excited and happy to be in this job, but knows nothing about the job, right? Brand new college grads don't know how to do the job you hired them to do, right? You have to kind of train them and give them extra data and give them extra information. Gemini doesn't have any of that. So this is your chance to tell Gemini some things that Gemini needs to know. Format would be specifics on their output. That's the format. That's specifics on the output. This morning, I got some help from the generative model of creating a LinkedIn post. It gave me this nice, pretty LinkedIn post with like bolds and stuff. But how you make something bold in a LinkedIn post is not really obvious, right? So when I copied the post and I pasted it in LinkedIn, all the formatting disappeared. So I had to go back to Gemini and say, hey, Gemini, I need to put this, I want this to go in LinkedIn. And so it needs to be formatted a way that LinkedIn would understand. So the bold is still a bold. And Gemini redesigned it and suddenly it worked, right? So that's the specifics on the output. Do you want something, the other day, Gemini gave me something and I tried to copy paste it into an Excel document and it didn't copyright. And so I went back to Gemini and I said, hey, I'm going to copy this and paste it into an Excel document. And I want all those things to fill a column in the Excel document. It reformatted it. I did copy paste, it worked fine, right? So that's the format, specifics on the output. So when you are trying to do questions and you're trying to request that an image, or you're trying to request a summary, or you want sample code or anything else, some other things you might want to think about is, are you going to kind of let Gemini know why we're doing this? Are you going to kind of give Gemini some background information so you get better results? That's my goal. I'm not doing this because it's fun. I'm doing this because I want better results. I found when I didn't do some of this stuff, I could get to the right answer eventually, but it's kind of like I had to go through several iterations because Gemini was doing things wrong. And the number one reason Gemini was doing things wrong is because it was missing important information. It didn't know what I was trying to do. It can't read between the lines past a certain point. So if you can give it background information it needs, again, if that were an intern or a new hire and they've never been to work before in your organization, what kind of things would you need to tell them before they create that thing? That's stuff that you have to really work on. Okay. Now, Google built the majority of Google Cloud for Google, not for you or me. Google has been around since 1998. And if you think about what Google does for a living, well, Google search. In Google search, let's see, I want to grab a copy of every web page in the world, let's say on average about twice a day, which is what they say. So about twice a day, I'm gonna have to grab a copy of every web page in the world, and I'm gonna have to pull that text in, and I'm gonna have to use it to update an index. And then I want people to be able to search all of the web pages in the world really fast. And to make money, I also want to do targeted advertising. That's all data processing. Then they come out with products like Gmail, and they come out with products like YouTube, and Google has, I think, 9 products with over 1 billion subscribers each. But if you look here, spell check, translate, search, smart compose, all of these products, they relate to data because that's something that Google knows a lot about, and that's something Google works with a lot. Google deep learning and speech, they acquired DeepMind. They invented TensorFlow, which is a technology for building neural networks. And you know what Gemini is built with is neural networks. 2017 Transformer, Chat GPT, generative pre-trained transformer. Yep, Chat GPT is built on the same transformer that Gemini is built on, that Claude is built on, that Grok is built on. That's like the core enabling technology in that white paper in 2017. BERT was like an early model that Google came out with, right? Gemma, Gemma came out in 2024. Gemma's kind of like Gemini's little sister, and we'll talk about Gemma a little later on. So Google has a history of big data processing problems. And Google has a history of bringing out products that help people deal with different kinds of data and work with it. So if you deal with enough data and you're trying to do advanced things with data, AI makes a lot of sense. So it should surprise none of us that Google does a lot of AI research because it helps Google and it helps Google clients, right? So product name, product name, product name, product name. If I'm looking at individual productivity, I think got things like Google Search. I have Google Workspace. These days in Google Workspace, if I'm working in a document in Google Workspace, I can highlight something in Google Workspace, and you see I get the little sparkly pencil. You see the Gemini. You see up here in the upper right-hand corner, I got the little Gemini logo, right? I asked Gemini to describe her logo, and Gemini told me that looks like a sparkle. In my brain then, ever since then, that Gemini, that's the sparkle logo or the sparkle icon. Okay, so do you see down here, I have like a pencil with a sparkle icon. Well, yes. Here's some text, and I can wake Gemini up and I can say, could you rephrase this for me? Could you shorten this? Could you elaborate it? Could you make it more formal? Or you see modify with a prompt. How about I tell you how I want you to change this? One time I had to deliver bad news to my boss. And so I highlighted what I'd written and I said, this is bad news I'm delivering to my boss. Is there any way you could soften the delivery? Could you reword it to make it sound not as bad? Gemini did. Gemini did a fine job with that. I was impressed. Anyway, so you see Gemini showing up in these different kinds of products. Google Workspace, the Gemini web app, that's over here, the Gemini web app. Gemini for Google Cloud. Yeah. If I'm in Google Cloud, I can wake up, there's the sparkle icon. In Google Cloud, I can wake up the sparkle icon over here. It opens up a chat window. I have to enable a couple of things to make Gemini work, but I have an integrated chat window in Google Cloud. If you want to know what's nice about having the integrated chat window in Google Cloud versus having the integrated chat window in my Google Docs versus this right here, when I'm in the Gemini webpage, it can't see what I'm working on. If I wanted Gemini to soften my delivery of bad news for my boss, I would have had to go to the email where the bad news was, copy that information out, paste it in Gemini, tell Gemini what I want. Gemini gives me the answer, and then I come back over here. So what's nice about Gemini being in my Google Doc, just like what's nice about Gemini being in my Google Cloud environment. What's nice about Gemini chatbot being in my code editor is the context. It's context aware. If I'm talking to Gemini Cloud Assist, I can ask it about things I've done in the cloud, and it can see what I've done in the cloud. If I want to know, hey, do I have a database table over in BigQuery named such and such? It can answer that question because it can see that stuff. If I'm in Gemini in my document, it can see the document I'm working on, right? So that's what's kind of nice about putting Gemini in these different products you see. Google's constantly making Gemini better. You may or may not know that Google relatively recently came out with Gemini 3. That's their latest and greatest version of Gemini. So Google's constantly improving Gemini. They're coming out with new features. Did you see where Google has announced where the Gemini web app is making a deal with Walmart? And you're going to be able to shop Walmart on the Gemini web app kind of thing. There's all kinds of stuff. Responsible AI. Google puts a lot of time, a lot of thought into being ethically responsible with their AI. They have a SAFE framework, acronym you should know, which is kind of a suite of tools and best practices, to help us with our AI work. They have Mandiant, which is kind of a threat intelligence cyber attack tool, detection tool. They have a bunch of AI principles on their website. Go do a search for Google, responsible AI principles. You'll find a whole web page filled with their principles. How would I do that? You can find their AI principles page over here. It's kind of interesting. Let me add that to our links in our page here. So you can go find the AI principles over there. They have a toolkit, which is, again, to help you build AI systems that are fair and unbiased as possible. Enterprise ready. Google Cloud is not new to this. Google is not new to all this AI technology. This is stuff that's been around, and Google does a good job with it. I showed you Vertex, which is that whole part of Google Cloud. Vertex, it's like the center point of all these AI technologies in Google Cloud. Google is built from the ground up with security in mind. Google just came out with a new data center, right, in the last couple of weeks. How does Google build data centers to make them secure? How do they build? They don't buy hardware. They build all their own hardware. They design their own motherboards. I mean, Google has security built in from the ground up, right? They have lots of compliance. You need to be FedRAMP or PCI DSS or HIPAA or some kind of compliance. Google can help you do that kind of stuff. Google contributes to a lot of open source technologies. TensorFlow is the most popular framework for building, neural networks. It was started as a Google project. Kubernetes was started as a Google project. There's lots of open models that Google has, like Gemma, to help you work maybe outside of Google Cloud, to give you models that you can really customize in great detail. And Google's got a lot of support for open standards, right? So you really have to start thinking about how are you going to embrace the potential here? Because that's what this is all. Generative AI is so new right now, right? I was in a meeting the other day and the client asked me, hey, when you teach this class for us, please make sure to discuss where generative AI is going to be 5 years from now. And I just started laughing at him because I'm like, are you serious? Where generative AI is going to be 5 years from now? I can kind of sort of figure out the next couple of major steps I think that generative AI is going to do, but that's probably going to be over the next year, year and a half. I have no idea where it's going to be 5 years from now because it is such it's such a massive set of capabilities and it's evolving so quickly, right? And our goal is we got to start figuring out how do we at least embrace the potential, right? We can't turn a blind eye. We need to figure out how we embrace the potential, right? Okay, good. I think it's about break time. So if you have questions, remember, you got people working the chat window. They're happy to help you out with any kind of questions you might have. What I'm going to do is I'm just going to throw up a timer. Let's take 15 minutes, and then we will pick back up. I thought I was muted until my partner in crime sent me a message, said he was hoped I enjoyed the chips I was eating. It's pecans, but still close enough, you know. Sorry about that. Anyway, so building a successful AI strategy. It's sort of interesting because you have a combination of needs and demands, and so you really have to kind of approach this in sort of a combination way. On one hand, I would say no one really knows how generative AI is going to help a particular organization past generalities. I can tell you things like consume data, understand the data, generate. So I can say, well, summarization it's good at. Certain types of creative tasks it's good at. I can give you general recommendations, but honestly, what's your job? What do you have to do? You know, I have to create slide decks. I have to create labs. I have to come up with, labs that are supposed to be interesting to do. I have to create course proposals for clients and, event proposals for other clients. And, so I have a particular set of things that I have to do. I've been doing these things for decades, so I know how these things should work. But these days, I'm using generative AI to help me do all this stuff. So, I'm kind of the bottom up person in that case. I'm sort of the person at the bottom who is, in the trenches doing a particular job, and I'm kind of trying to figure out how generative AI is going to work for me. But the only thing that allowed me to do that is when I went to my boss and I said, I think this is going to help me be more productive. You know, my boss is the one that ultimately has to pay for this stuff, right? Because I don't want to use the free tools. You can leak intellectual property. You can do all kinds of things in the free tools. We should all know that there's no such thing as free, right? So in a business situation, I don't want my employees using the free version of Gemini or the free version of ChatGPT or anything else, because those tools can leak intellectual property, personal information, all kinds of stuff. So I need commercial products. Since the AI is so hot right now, there are a zillion commercial products that are built around generative AI. I get messages on LinkedIn, I get junk email all the time, trying to sell me some new generative AI based product, right? They're all out there. They all cost money. So I need some leadership in this decision or in this process, because they're going to have to invest in this stuff. But the people who are really going to figure out how are we going to use generative AI in our business to make us more impactful, it's going to be the people. It's going to be your people that are closer to the workers. It's going to be the workers themselves. It's going to be the intermediate managers. They're going to be the ones that are bringing up to the CEO, hey, this is something that we need to invest in, right? So you got to kind of get these two things together. The top-down approach where, you've got people that are thinking about vision. You've got people who are thinking about, the most important use cases. You also have people that are thinking about return on investment. I just had a client come out and say, by the end of 2026, they want all their software developers to be 20% more efficient. Okay, so that's their initiative. They are buying tools, they're signing up, for services, but they're also saying, look, guys, by the end of this year, you need to be 20% more efficient. And who they're talking to, of course, is the bottom up people, the people who are the individual contributors, the people who are the team leads. They're the ones that are saying, hey, guys, the boss says we got to be 20% more efficient by the end of the year. These are the ways we're going to measure that. These are the tools that we have. What tools do you think we need? That's kind of that bottom up piece. So we have to kind of put this together. Your strategy, your high level executives, high level management, they're thinking overall business goals. They're thinking organizational wide services. Your mid level managers, your individual contributors, these are the ones that most likely are going to be using the tools to solve individual work problems, if you will. So it's a multi-directional strategy. From a strategic perspective, I've already kind of said this. The big boss is thinking, is this something that's going to be actionable? is this something that's going to be affordable? What kind of return on investment are we thinking? The mid-level managers and the individual contributors, they're looking for pain points. Okay. Read, understand, generate. What do I do? What do my workers do where that would be helpful? How can we prioritize our needs? How can we prioritize, the tools that we're going to use? Um, yeah. Exploration. This is all new stuff. No one knows the right answer for most of this stuff. So we have to be willing to explore it. The upper level management are going to have to empower us to explore it because most of this is going to cost some sort of money, right? Most generative AI is not free. And like I said, the free stuff isn't really free. So in business situations, we're going to be investing in tools. We're going to be investing in services. The reason I can go over to Google Docs and the reason I can get access to, Gemini in the Google Docs here is because my boss is paying for it, right? My company is paying for it. That's a service they got me. So how are we going to foster collaboration? Things like that. Your mid-level managers, your individual contributors, experiment. What are they going to be doing? What can we try? Can we try this? How do we incentivize this, by the way? Let's have contests. How about every department has a contest for who can come up with the best, generative use case? And then we'll compare them all across the entire organization and give some big prize away. How do you get people interested in this? I get paid to be curious. I get paid to learn new technologies. Most people don't. Most people, it's like, oh, it's different. It's new. I don't want to mess with it. Um, okay. How do we get around that? Right. Responsible AI. How do we think about ethical guidelines? What sort of data governance? I'm talking about handing data over to Gemini to read. What if it's patient data? What if it's personal data? Is that okay? Is that not okay? What kind of policies do we have around that? Your mid-level managers, your individual contributors, are they adhering to customer standards? Do they understand them? Are they thinking proactively about potential pitfalls? Okay. Remember, we're not talking laws here. We're talking being responsible. Now, at some point, do laws catch up to us? And if we're doing things irresponsibly, does it open us up to liability? I would say yes. So I would see another reason that we're thinking about, this responsible AI stuff is because we want to limit our liability as the laws change, right? Resourcing. Yeah. What kind of data strategies do we have so the right people can get access to the right data? This is not a new problem, but this is a problem that's exacerbated by generative AI. Because remember, consume data and understand it. Well, I got to get my hands on the data first, right? How can I leverage existing tools? A lot of tools now have generative features that are built in, but it might be an extra cost, right? So how do we invest in that? How do we leverage our resources that we have? How do we make the case for new resources, right? Do I have a feedback mechanism, right? Where people can come and say, hey, we're really interested in this tool. Maybe what I say to them is that's sure, let's give it a try. Maybe what I say to them is, well, we're a big Google shop here, and here Google has a tool that's similar. Why don't you try this tool out? You may never have heard of it before. Impact. Measuring impact is going to be a critical component because if I'm saying to you that generative AI is a force multiplier, if I'm saying to you things like I've already run across a company that said we want all of our developers to be 20% more um, uh, effective by the end of the year, how do you measure that? What do you mean for a developer to be 20% more effective or 20% more productive? I'm a stats person. I went to school to be an actuary, which is basically a type of statistician. So, you say things to me like, well, this is a tool that's making us, it's a force multiplier. It's making us more productive. It's making us more impactful. Well, okay, how do you measure that? It's one thing to say, well, oh yeah, I can definitely tell I'm more productive these days with generative AI. What's the before and after numbers? Because that's really what I want to see. That's going to be the ROI, right? If we can show what we invested this much in generative AI technologies, but through additional productivity, it made us this much. Obviously, that's worth the money, right? That's the return on investment. But we're gonna have to kind of think about that. How does generative AI contribute to our overall business goals? How do we define and track key performance indicators? Honestly, those KPIs, the big boss all the way through the workers are going to be interested in those KPIs. This stuff is also constantly changing. There are new features coming out all the time. Okay. How do you keep up on that stuff? You know, you also need to know that if you built a big application using generative AI today, I'm talking about an application that has generative AI features in it. Um, the available generative AI features are changing very rapidly. So if you start designing something today and you come out with it in 3 months, is it already out of date? Because there's other generative AI technologies that you're not taking advantage of? The answer is maybe. So you're going to need to think about things like an aggressive feature release plan where you're going to be planning to do continuous improvements. You're going to be testing, you're going to be measuring, you're going to be looking for new features and trying to come out with it, right? They talk, if you watch this video here, they talk about kind of coming up with a creative matrix, right? And you see it's sort of like, what do we want to do? Are sort of up here: enhance customer experience and increase efficiency and drive innovation. And then you see down here, it's sort of like Gen AI tools. What Gen AI tools are we going to be using and how can they help us achieve our goals, right? There's different tools out there that can do different things. Yesterday, I was teaching a room full of software developers. And I'm saying to them, okay, you're a software developer. Well, you got the Gemini website, you've got the Gemini helper in your code editor, you've got a command line, Gemini CLI. Those are your core tools. These are kinds of the things that each one can help you with, right? So that's sort of what you're looking for here. You're looking for some of the core tools that you as an organization have access to, and what kind of things can it help you achieve that meet certain business demands. All right. Most of what Gemini does in my brain is augmentation, right? It augments me. It helps me do certain things. A smaller percentage of what it can do is automation, right? Where it helps me automate certain types of tasks. Augmentation is things like, problem solving. Yes and no. Remember what I've said. Generative AI is not truly a genius at problem solving like a human would be, right? It's not. It can do some critical thinking. It can do some problem solving. But I just read an article not too long ago, and the gist of the article was generative AI is nothing but hype. And here's why. We came up with like 5 really sophisticated programming problems. Okay. And we brought these 5 really unique, really novel, really sophisticated programming problems, and we handed them all to all the generative models. Gemini couldn't do it. ChatGPT couldn't do it. Grok couldn't do it. Claude couldn't do it. None of them could do it. Ergo, generative AI is a waste of time. And I remember reading that article, and I remember thinking, you're doing it wrong. I don't use generative AI because it thinks better than me. It doesn't. It doesn't really think. Right. I don't do generative AI because it has tremendous problem solving abilities. Now, don't get me wrong. A big part of problem solving is doing research, and it can do instantaneous research, which is a very important skill. But it can't always take that research and intuit what the next step should be. Right. Humans are needed to interpret insights. Humans are needed to honestly be the big thinkers. Generative AI is there to be the grunt worker. Generative AI is there to be the research assistant. That's what generative AI is there to do. And it does it really well. So what I'm saying to you is, if you're a software developer and someone comes to you with a programming problem that you've never seen before, if it's something that's very novel, generative AI may have never seen it before. And if it's something generative AI has never seen before, it may be of limited use in actually solving that problem, right? It's really good at things it's seen before, but that's okay. We have a division of work here. I'm the one who's supposed to be the intuitive, creative person, right? I'm the boss. I'm the one who's making the ultimate decision. What is our plan of attack? I'm the one that's going to say, first we're going to do this, then we're going to do that, then we're going to do the other. What generative AI is good at is helping me. It can research for me. If I have a question, it can give me the answer in like 0 time. So it's really good at certain things I'm not good at. It can help the heck out of me with research, but you are the critical thinker, not Gemini, right? Creativity and innovation, same kind of discussion. Human ingenuity is still essential. Yes. You are the true creative genius. You are the true innovative genius. It's the researcher. If you have to do something creative, a lot of it is, I need ideas on this. And Gemini can come along and say, here's 10 ideas. And you can say, well, if we combined your idea number 2 with your idea number 5, that would be a really good idea. That's the kind of stuff that you do. Relationship building and collaboration. Well, I guess generative AI can help you write emails and stuff, but I'm not sure it's a real relationship building tool, right? But it can help with communication. It can. If you are not the strongest communicator, you can tell it what you want to say, and it might be able to polish it up for you and say it in a very nice way, right? Strategic planning. Yeah, again, this is stuff where you're probably going to be better than generative AI, right? So what I'm saying through all of this is I don't want something that can problem solve for me, that can be truly creative, that, can build relationships and do strategic planning. I want to help her to help me do that. These are all things that I can do, but these are all things that I could use help doing. And that's our partnership, right? And that's why I'm saying to you, you need to get into Gemini and you need to start trying to figure out, what is it that Gemini can do for you? And what is it that you're going to be better than Gemini at? Okay. How can it help you with ideas and creativity and et cetera, et cetera? Now, on the automation, again, when someone says to me, we have an automation problem, my first thought is not Gemini. My first thought is, well, am I going to write some code to automate it? If you're doing something over and over and over and over and over again, code does that really well. Do I need a script? But if part of your automation involves reading a bunch of stuff or looking at a bunch of video or listening to audio or something, and then understanding what that is and then drawing conclusions or something from that or building a report from that, if that's your repetitive task, sure. So automation tasks are typically around things like, I just received, reams of feedback on this product that we have. I need something that can read through, 1,000 pages of feedback and create a summary report for me. Oh, okay. If that's your task that you do over and over and over again, you're saying to me, you have a repetitive task that where reading and understanding and generating would be very useful. Great. Gemini can help you with that. Here's 1,000 pages of feedback for this product. I want a report that's actionable. I want you to detail for me, these overall trends and I want you to come up with a list of suggestions. You tell it what you want, and it can process that information, understand it, and generate for you. All right. The fastest way to make generative AI better is human in the loop, right? Human in the loop means human feedback. This is where you have a chat bot, and at the bottom of the chat bot, there's a thumbs up, thumbs down feedback button. And people come to you and they say, this was fantastic, and here's why. Or people come to you and they say, this chat bot gave me bad information, and this is why, and you're basically getting information that you can use to make the model better, right? Humans are also going to be there to do things like pick data. If you are building a model, you're going to need to pick data for the model. If you're using something like generative AI, you may need to pick the facts that generative AI pulls from. If I need a big pile of policy documents because I'm building a policy chatbot, you're going to have to select those policy documents. Because you know what Gemini is not good at? If you have a big pile of policy documents and the old versions and the new versions are mixed up, generative AI may not be smart enough to tell them apart, right? And you might be giving wrong answers because you're basing it on out-of-date information. So when I put together that information that Gemini is going to use, I have to be careful how I select it. You're going to be the one that's going to be refining the prompts, refining the instructions. If you use generative AI over and over and over for some task, then you're going to want to get the instructions down and saved somewhere. So, this is a good set of instructions. Every time I use it, it gives me exactly what I want, kind of thing. Output evaluation and refinement. That's what I was talking about a second ago. Are you looking at what it generates? You should be. If you ever find yourself just rubber stamping all that Gemini is doing, that's a problem. Okay? You don't want to rubber stamp Gemini. What you want to do is you want Gemini to give you the first draft, and then you take that first draft and you tweak it to make it, better. Continuous monitoring and feedback. Yes. Any kind of AI system, are you collecting information on how it's being used and is it being impactful and stuff like that? Your sales team spends a lot of time answering basic questions about product pricing and availability. You decide to implement a generative AI chatbot to handle these initial inquiries. Is that augmentation or is that a form of automation? Right. Well, I think that's probably more automation, right? Because this is kind of like in sales. Can you go to your sales reps? What's the top 50 most asked questions? Could we just automate that? That's kind of what they're implying here to me, right? So to me, this is not really augmenting where I'm making you better or something. This is more automation. I got these 50 questions. We get them all day long, every day. Could I just build something that can answer those 50 questions? That generative AI could do that. That's an automation kind of thing, though. You're a financial analyst who uses generative AI to analyze large data sets and generate reports summarizing market trends. You then use this information to advise clients on investment strategies. Okay, we're looking at the other, right? This is where you are the financial analyst. You are making the final advice that you're passing on to your clients, right? You are using generative AI as a tool to help you get answers faster or to help you get better quality answers. Yeah. This describes most of what I do with generative AI. It's augmenting me, right? I'm doing a job. How can my generative partner here help me with this job? An online retailer uses generative AI to generate product descriptions for its vast catalog of items. They provide the AI with key product attributes like size, material, features, etc., and the AI creates unique and informative descriptions for each item. Okay. Again, that might be a form of automation where I'm kind of, it's creating the description for me. I don't know. Honestly, this one always throws me because is it really automation or is it augmenting something that I could do on my own? I guess it's probably more automation because here's this info, build me a description. Here's more info, build me a description. A software development team uses generative AI to generate code for standard functions and components within their applications. They then review and integrate this code into their larger projects. It's augmenting them with their development. Yes. Okay. What's a key advantage of using Google Cloud's generative AI ecosystem for business? It forces each and every business to become an AI first company. Anytime I see answers with things like it forces or everyone must or this can never be, honestly, whenever you have like an extremes sort of answer like that, it's almost always wrong. Okay. I'm not going to say it's always wrong, but it's almost always wrong. So it's kind of like, did you notice I paused? As soon as I read its forces, I'm thinking to myself, I bet this isn't the answer because just of the wording they used here. It eliminates the need for companies to cultivate internal generative AI knowledge and experimentation across their organization. Again, it gets me uncomfortable when you say and eliminates completely. Yeah. It allows businesses to leverage Google AI's advancements without starting from scratch. That's pretty good. It assures businesses that they will achieve immediate and okay. Do you see? Of course, you're going to be immediately successful in all your generative AI endeavors. No, all three of those are kind of doing some variation of an extreme. Now, on the real test, it's not quite as blatant a lot of times, but you will see cases even on a test where they do the same stuff. It assures that this is always true, or it assures that this is never true. Always and nevers make me really nervous in answers. Which of the following are benefits of using Google Cloud for generative AI development? Select 3. Okay, now on the current exam, I don't think you have multiple select. Okay, so on the current exam, I think it is only multiple choice. So you do not have multiple select. The reason I mention this is because there's a lot of Google certifications where they do have multiple select. Okay, but I'm fairly sure the generative AI. I'm fairly sure that the generative AI exam is just multiple choice. Okay, but be that as it may, they're asking us to do a multiple select. Which of the following are benefits? Select 3. Okay, there's 5 possible answers. We need to pick 3. Benefits of using Google Cloud for generative AI development. Access to pre-trained models like Gemini, I would say yes. Automatic model upgrades and security patches. Ready-made generative AI solutions for all applications and domains. The all applications and domains makes me nervous again. Enterprise-grade security and compliance features. I like that. A guarantee of complete accuracy in all generated content. Yeah. So probably A, B, D, right? That's probably what we're going to look at. I think C is out. I think E is out. So when they talk about automatic model upgrades, they're talking the Google models. If you are using Gemini, it is automatically upgraded. It has security patches that they apply, etc. Yeah. What's the recommended approach for businesses to effectively implement generative AI? Focus on a top-down strategy driven by executives. No. Focus on a bottom-up approach with no overarching plan. Yeah, no. Adopt the latest generative AI trends. Combine a top-down strategic vision with, I think ideally that's what it's going to take. The problem working bottom-up is without any support from the top, who's paying for these models that we're going to use, right? The problem working strictly top-down is the managers have no idea what the generative AI is used for, right? They don't really get it a lot of times. They're excited about it, but they need the lower level managers and individual contributors to kind of fill in the gaps, fill in the details, tell them what's really going to be useful, So it's really that combined approach that we want. Why is it important for mid-level managers and individual contributors to be involved in generative AI adoption? Did I just talk about that? They have a limited understanding of daily operations and user needs. Yeah, it's important because their knowledge is so limited. Their proximity to workflows allows them to identify impactful generative AI solutions. Is that kind of what I just said? I think so. But remember what I said, I never stop with an answer. Keep going. They should avoid any involvement with generative AI experimentation. Yeah, that sounds fun. Their focus should be solely on technical implementation details. No. Yeah. So, their proximity, they're going to help you identify where it's really going to be helpful, right? You got to talk to these individual contributors, these individual workers, and figure out, let's talk about your job. You represent, there's 50 people at our company that do the same job as you. What kind of things, would benefit you that would also benefit these other 50 people? That's what you should do. And by the way, the statistics say kids coming out of college, I think 98% of college grads are using generative AI in their daily work, right? So your college grads, your new hires, sometimes your new hires, they may be showing up thinking, how am I going to use generative AI to do my job? So you might have people my age who maybe are not up on the curve of generative AI. They're not really sure what to do. Maybe these kids that you're just hiring, they are already using generative AI. How can you leverage that? How can you use that to augment what you guys are trying to do, right? Okay. Good. They have extra questions throughout this set of materials. I'm not going to go through, here's an appendix with some questions in it. I'm not going to go through all of the questions they have in this course. I'm going to leave some of those for you guys. Remember what I said. The good thing about these questions is they are asking you important questions. They are testing important knowledge. The bad thing about these questions is they are not written like real questions are. Okay. And as I told you guys, if you come back to my office hours next week, most of what I'm going to be doing in my office hours is I'm going to real quick blow through how do you sign up for the exam. And then the entire rest of the time we're together, I'm going to be basically going through sample questions. And I'm going to talk about, look at the way they ask this question, look at the tricks they're trying to play, look at the way we can find the right answer. So that's mostly what I'm going to be doing for that hour and a half. At least an hour of it is going to be me going through questions that are actual test questions. And my goal there is to just, show you a little bit more about how Google asks questions. So lots of good questions in this course material, but they aren't written by Google exam. They're not written like Google exam questions. They're not written by the same people. I'm moving on over into module 2. Remember, if you haven't already done so, you can go to tinyurl.com/Google-Gale. Generative AI Leader, right? GAIL. And you can download a copy of the course materials. And I'm going into module 2 now. Remember, if you have questions, put them in the chat window. All right. I mentioned briefly in the last chapter that artificial intelligence is basically building machines that can act more human. That's kind of what artificial intelligence is. There's parts of artificial intelligence that might be things like advanced robotics, right? The part of artificial intelligence that we're mostly interested in this discussion is we are probably most interested in machine learning. Machine learning is a subset of AI where you're trying to build machines that learn more like a human, right? That's sort of your goal. You want to build a machine that learns more like a human does. I watched a video the other day, and it was a video where they were talking about how to build a neural network. And here's the link to the video. Let me put this at the bottom of our chat window. I'm sorry, not chat window. I meant my links document over here. Let me put that in there. And the video is from this group called 3 Blue 1 Brown. And 3 Blue 1 Brown, they do geeky math videos. It's kind of what they do. They explain complex topics in a very clear and easy to understand way, right? They don't get into the math. It's more they're explaining it to you, right? It's about a 20-minute video. It's titled, "But What is a Neural Network?" And in this video, they're talking about one of the classic problems in kind of AI. This originally came from the US Census Bureau, right? This originally came from the US Census Bureau. The Census Bureau is doing the census, and they send you a form and they ask you how many people live in your house, right? How many people live in your house? And what they give you is they give you, of course, a little box over here. They give you a box, and you're supposed to write that. You're supposed to write how many people live in your house in that box. And so you come along and you write the number 9. Certain things in programming are easy to do. If you tell me that if you have more than $50 of stuff in your shopping cart, then shipping is free, that's easy. If the value of the shopping cart is greater than or equal to 50, then shipping is free. That's easy code to write because it's so exact. Most code is very exact. It's very mathematical. It's very straightforward. But then you run into problems that are not nearly as exact. How do you write a number 9, right? Different people might write their number 9 differently. Okay. How do I describe that mathematically? There's a circle up top. Really? You think any of those are circles in the truest definition? Well, it's kind of roundish. Okay. First problem. How do you do kind of roundish in an if statement in programming, right? And then it's kind of got this sort of straight line down the right-hand side, and the proportions are kind of like this. But honestly, it's sort of really vague. This is a classic problem. How do I build a computer system that can look at a number 9 and understand what it's seeing? Okay. So the US Census Bureau wanted to do this. And so they put together a bunch of, computer AI geeks to see if they couldn't come up with a solution. And they came up with a model, okay, that can do this. Technically, this is a deep neural network, is what they call this. This is also a nice example for what it's worth because deep neural networks are the brains inside generative AI as well. So generative AI is built in a similar way. Anyway, so they put together a model. If I wanted to define a model, I would say it's a mathematical system. Okay. In one side of the model, you put some sort of input. Inside the model, lots of math occurs. And out the other side of the model comes the answer. Okay. Now, in machine learning, one thing that's unique about machine learning is, and the reason that this is part of kind of this AI world, is machine learning learns a lot like human learns. Okay. Have you ever taught a kid their numbers? At first, you show a kid the number, and the kid's like, I have no idea what that is, right? I don't know what that is. And then time and repetition, they get better and better. And then they're confusing their 6 and their 9s, and but they get better and better. But it's over and over and over and over again. So in machine learning, a lot of that works the same way. The first thing I need in machine learning is I need lots of examples of written numbers, right? That's what I need. This is called the MNIST example for what it's worth. The modified National Institutes of Standard Technology is what they call this example. In the current MNIST data set, I think there's 60,000 writing samples, right? So you have writing samples from like 60,000 different people. The MNIST writing sample we use today is a very clean, very nice, very curated writing sample. When the U.S. first government did this, they didn't do it that way. What they did is they sent these little cards to public schools, and they said, okay, kids, I want you to write your numbers on this form, 0 through 9, right? And they collected all these writing samples from kids, and they brought the writing samples back. Funny thing, though, children write a little differently than adults do. Also, at the time, they were teaching kids certain ways of writing. Like, have you met someone who writes the 7 and they put the little slash on the 7? Or that, like when I was in the Marines, they always had us do, the slash across the 0, so you knew it was a number and not a letter kind of thing. So, there's certain writing things they were teaching kids at the time that were a little different, but also kids just write differently than adults. So what I'm saying to you is their first version of their data set was bias. When they first built this, it worked really well recognizing written numbers as long as they were written by school kids. It didn't really recognize writing from adults. That's right. They didn't include writing samples from adults who might write different ways than kids. That's a form of bias. Okay. They didn't think about that. In the data set these days, that 60,000 curated data set, they literally eventually hired writing experts to help curate. They had hundreds of thousands of examples, and they whittled it down to 60,000 really good examples of every common way people write the numbers, right? And then what you do is you come in here and you build a mathematical system. You build a model. Models work off math. So nothing in a model can be an image truly, or text or something like that. I have to convert it all to numbers. So how do I convert a picture of a number 9 into numbers? What they did is they said this was a 28 by 28 pixel grayscale image, and they took each pixel, which is basically a number, one at a time, and they input them into this input layer, right? Each of these little circles, you can call them neurons, or you can call them parameters, but each of those little circles does math. So it takes that number and it does math, and what it does is it starts handing a calculated value out to all the other little neurons over here. They collect all of the outcoming numbers from the first layer, and they do more math, and they can continue this process. They put the mathematical system together. Every one of these little neurons, though, in the mathematical formula, it has a numeric value that is set. So all these neurons, all these parameters, they are actually configurable. It's like a knob. If you've ever had a ham radio or like a classic radio where you have like one radio knob and you're tuning the radio, and is it getting better or worse? Yeah, kind of like that, except instead of having one knob to tune, there's 1,000 knobs to tune. If there's 1,000 knobs to tune, you have to come up with some sort of plan on how you're going to tune them in like an organized way. And then you start trial and error. I put in the picture of the first number 9. It runs through the math, and maybe it says, I think that's a 5. And the model says, no, that's wrong. You are 4 off that direction. Tune some knobs, right? Tune some knobs. So it tries messing with some of these knobs, maybe 1,000 of them. It tries messing with some of the knobs, and it tries again. Let's try again. This time, I think it's a number 4. No, you're getting colder. You're still wrong. Now you're 5 off. I don't know what knobs you turned, but that's not what you want to do. You want to go the other way. And you do this over and over and over and over and over again. You have 60,000 writing samples, and you run through all 60,000 over and over and over and over. If the model is put together the right way, so it's actually learning from the examples, then through time and repetition, it will get better and better and better. In the end, this solution is an extraordinarily good solution to this problem. It will do a really good job of telling numbers apart. Okay. Now, 20 years ago, this was something that people had never done before, right? These days, if you went and took a computer class in college to learn about building, neural networks or machine learning models, this might be one of your homework assignments. This is considered like hello world scale neural networks these days. So this is a example of machine learning. It's not learning because I say, if this is true, then that. It's learning through repetition. It's a mathematical system that has some sort of learning potential where it can be adjusted. Okay. Not just one big knob, but, in this case, lots of small knobs. And I'm messing with them, lots of small knobs. And if I do it the right way, I can build a system that can accomplish the task. And this neural network idea like this is exactly the way models like Gemini are built. Except Gemini, well, first off, Gemini is not one neural network. It's a bunch of them that work together. They call that mixture of experts. It's kind of like, imagine you have one neural network that can handle math problems, and you have a different neural network that knows how to do physics, and you have a different neural network that knows how to handle history questions. It's closer to that, right? Where you kind of have a mixture of experts is what you do. So it's not one neural network. It's several neural networks, but also how many knobs, how many neurons that I said were here? Maybe 1,000. In Gemini, you might have 3 trillion. I mean, the size difference between this example and Gemini is just staggering. It's so much bigger, so much more complex, doing so many more calculations. Generative AI is a subset of AI, and it's focused on what we've discussed. It's focused on consuming data and understanding in kind of a human sort of way. In any kind of AI, classic AI or generative AI, data is like the problem that just never stops, right? Data is important because when your AI system looks at the world, it looks through the data, right? So the data is the lens through which it sees the world. If it's trying to recognize a pattern, like how do people write their numbers? If it's trying to recognize a pattern, you have to give it a good lens of that. If the lens is flawed or biased or unfair, it will learn things that doesn't really work very well. When they first taught it and it learned to tell writing sample, it learned to identify writing, but only from kids. That's when the people who built the model, they said, we need better data. So in other words, we need to collect data not just from kids, but adults too. So what they did is they collected writing samples from government workers. So they sent that card out again. Dear government worker, we want you to write your numbers 0 through 9. Turns out government workers do write like the most of us. So now they had a data set. They had some kids in it. They had government workers in it. And at some point they thought it was too big, right? More data is generally better, but more data also makes the math and the problems a lot more complex. So what they decided is, could they take these hundreds of thousands of writing samples and could they hand curate? Could we hire people who are writing experts to put together a little bit smaller data set that's got at least a couple of good examples of every writing style you can imagine? And that's what they did. So they whittled it down using writing experts to a really good, really representative, smaller data set. Okay. So data is always important because models, these mathematical systems, they analyze the data they've been given, and what they're really doing is they're learning patterns. They're calculating statistics on what's the likelihood of different outcomes of different patterns. That's all they're doing, right? So as the numbers flow through this system, you see in this example, they actually have those 10 outputs. It's kind of like as the data throws through, I want the biggest numbers landing down there on the number 9. So I have to make sure kind of the math that's happening in here does that the right way. That's sort of what they're really trying to do there. Now, what kind of problems can I run into with my data? Or what kind of considerations if I'm putting data together? Well, is it accurate? Is it got the right answers? In other words, does some joker write the number 5 in the box that's supposed to be the number 2? That's a problem. Do you have an employee who's disgruntled and on their way out? They write a little script that goes through your data set you're using to train a model, and it randomly inserts bad data in it. Okay, they've had cases of that. That's called data set poisoning, right? If you build a really nice data set, it is very important you take steps to protect it, right? Because it can take a lot of time and effort to make sure it's correct, right? Is it complete? Completeness, do I have enough data it's kind of like statistically significant, right? Do I have a statistically significant amount of data that I can learn from, right? So that's part of complete. And part of complete also to me, these two kind of have some overlap between them. Part of complete to me is also, is it representative? Okay. We have writing samples from nothing but kids. A lot of times the people who are doing the AI work, developers like me, we're very left brain logic types and we're focused on solving the problem. And sometimes we don't think about certain things, right? It's kind of like the kids and the college professor who invented facial recognition. You have this group of kids and their college professor at a university, and they invent facial recognition. Okay, if you want to do facial recognition, what do you need? Well, you need pictures of faces. So what did they do? Well, they took pictures of themselves. They took pictures of their friends. They took pictures of their family, and they built a really nice data set of faces, but it was mostly people with light skin, right? So when they started testing facial recognition, they noticed this trend where facial recognition really didn't work very well if you had dark skin. Okay. I don't think the college kids were being racist. I think the college kids weren't thinking about that, right? That's something in responsible AI, by the way. You need people who are actively trying to think about, is our data being representative or is it biased some way, right? Most bias is not purposeful, but bias is still bias, right? So what did they have to do? Well, they had to go back and fix their facial recognition data set, right? They had to get people of all complexions and eye shapes and everything else. So is the data complete and is it representative? And again, do you see how those kind of go hand in hand? Consistency. I already made a joke about, the date. In the US, it's, January 29th, which is 01/29. If I'm dealing with someone in the UK, they wouldn't think it that way. They would try to figure out, what the 29th month is or something, So um, date formats. Date formats is a classic consistency problem. I'm Patrick Haggerty the third. I can't tell you how many times I get, messages from like catalogs or something where I get two catalogs. One's addressed to Patrick Haggerty and one's addressed to Patrick Haggerty the third, but we're really both the same person and they're wasting money sending me two catalogs. Okay, that's sort of a consistency problem. Is this person always referred to the same way, right? Relevance. More data is not always better. There's a point at which, this is true in general. The more data you have, the more compute power you're going to need. The more compute power you're going to need, the more expensive the training process is. And remember, the training process is where we're going through over and over and over. Here's a bunch of pictures, process them. Here's a bunch of pictures, process them. And remember, in this case, every time we process an image, it's, 1,500 mathematical calculations or something, so there's a lot of math that happens every single time we hand one image in, let alone when we hand 60,000 in, let alone when we hand 60,000 in 20 different times, right? So learning by example, you're going through the data over and over and over again. I don't want to go through data that's not important. If I'm trying to build a credit card fraud detector, could I figure out the weather when a credit card transaction was occurring? Sure. I could tell you what the weather outside that building was anytime a credit card transaction occurred. Is there a strong correlation between weather and fraud, credit card fraud? I don't know. We should talk to a fraud expert, right? If the answer is yes, then that data is relevant and it makes sense that we consider that. If the answer is no, then why would you put the weather in there? If there's not some correlation between the weather and fraud, you shouldn't be using that data. So when they talk about relevance, there's this kind of general statement that more data is better. Generally, that's true, but there are points where that's not always true, right? Especially if the data is not super relevant to what you're trying to do, right? There needs to be a reason we're looking at that piece of information. And then, of course, we have to deal with the good classics of, do we have this data? Is the data there? What's it going to take for me to get access to that data? If I showed up in your company, woohoo, consultant here. Yeah, I want to see all your data. Okay. What kind of, security is that going to take? And that's, of course, if we have the data. Past that, is this data we need to collect? Are we going to collect it from our customers? What are we going to tell the customers we're collecting the data for? Because, we should be doing that, right? That's part of responsible AI too. So is it available? What's it going to cost to get it available? And then, of course, there's the kind of the data engineering problem. The data engineering problem to me is How can I take data and make it usable, right? If the data is over there, how can I take that data from over there and move the data over there? And when it gets there, put it in a format that's going to be most easy for me to work with. I can't do math on text. How do I convert text to numbers to make sure I can do math with it, basically? For example, when you're working with generative AI, um, when you're working with generative AI, looks like some new UI stuff here. When you're working with generative AI, and I come in here and I say, what's the high temperature going to be today at my house in Pascagoula, Mississippi? What's the high temperature going to be today in Pascagoula, Mississippi? That's words, 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 words. Yeah, but if I click on this little tokens thing here, that's what Gemini sees. You might be thinking words because to us, words make sense. But to a mathematical system, words don't make sense. So what Gemini does is it takes my question, what's the high temperature going to be today in Pascagoula, Mississippi? And it converts it into words. What? That's a token. Apostrophe is a token. S is a token, right? The is a token. High temp going to be today in Pascagoula, comma, Mississippi, question mark. It converts each of those, each word, each piece of punctuation, it converts all that into numbers. That's what goes into Gemini. And then Gemini does math and comes out with an answer, which is kind of amazing. So convert all the words in your question to numbers and then do math and we get an answer back. And that actually works. Yeah, it's kind of amazing to me. Maybe that's just me. So formatting, there's a lot of formatting that has to go through here. Understanding your company's data, its quality, its availability, form, this is all going to be essential. And this is true really for any kind of data analytics, but it's especially true in the AI world, right? Your data breaks into two major types. About 20% of what most companies store is structured data. About 80% of what most companies store is unstructured data. Structured data historically is the data that we make most use of. Unstructured data historically was completely ignored. And it's really only recently, and a lot of times thanks to AI, that we're starting to make more use out of it. Structured data, it's rows and columns of information. It's a list of customers and their first name and their last name and their email address and their customer ID and it's products, it's transactions. This is the stuff that we live and breathe every day, our core business that we track. Customer ID, customer name, order cost, how many stars on what's our review, how many stars kind of thing. That's all structured information. It's columns of information in some database or Excel spreadsheet or something. Unstructured data is piles of text. Probably about 70% of your unstructured data is just nothing but text. It's PDF files, it's Word documents, it's text files, it's, emails. That's what we're talking about here. It can also be other things, like it could be images, it could be videos, but by far the majority of it is just piles of text. This big 80% pile over here, this 80% pile, our unstructured data is drastically underutilized. There's probably a lot of gold in there if we could only find it. Okay. And I read an article where that's what they talked about, and they use the analogy of gold because in order to find gold, you have to shift a lot of dirt. You have to get a lot of stuff out of the way before you can get to the gold. And that's kind of what they're talking about here. So we have these big, huge piles of text, but we also have video and images and everything else. And obviously that's just standards. If you work for something like a media company, then your unstructured data may be piles of video, whatever. Any way you look at it, it's being underutilized. And that structured and unstructured data are both things that Gemini can understand, right? So suddenly we have a tool that gives us easy access to all that unstructured information like never before. An AI model is trained on data containing numerous factual errors. Incorrect historical dates, mislabeled customer details, garbage data in, garbage data out. Anyway, in this scenario, which data quality factor is primarily compromised, leading to potentially flawed predictions? You remember what I said? Everything on this exam is going to be, do you understand these technical terms? Do you understand this terminology? Do you understand these concepts? Do you understand these product names? Right. And what's funny about completeness, consistency, accuracy, and relevance is as I'm going through them, I bet you're like nodding your head, like, yeah, that makes sense. That makes sense. But can you tell them apart from a technical perspective? Right. Do you know that when they're talking about wrong answers, that's an accuracy problem? Completeness, do they have enough data? Is their data type formats consistent? Okay. Now, when they say incorrect historical dates, they didn't say misformatted dates. That would be a consistent problem. They're saying it's literally the wrong answer. Relevance is why do we care about looking at this? So once again, everything we talk about in here, it's fair game on the exam as far as concepts and technical terms and product names. Relating to data accessibility, what is the key nuance presented regarding large data sets? Larger data sets always guarantee better model performance. I think I just talked about that and said that's not quite true. Data volume is irrelevant. That's not true either. There are times where more data is definitely better, but it needs to be more of the right kind of data, I guess we should say. Acquiring large data sets is always less expensive than acquiring smaller ones. Okay, besides the whole always, why would more data be less expensive than small data? While often beneficial, large volume isn't the only data aspect influencing performance. That's right. It's not only size that matters. Yeah. Now, when you look at different types of AI problems and the way models approach solving these problems, there's three main learning styles. There's three main machine learning approaches. The biggest pile, which is probably 75% of AI problems, is what's called supervised learning. Supervised learning. Supervised learning is the examples I've given mostly, right? So in supervised machine learning, you have data. And in the data, you have features. Which is kind of data points you know. You have the label. The label is the answer you want to learn to predict. Features, when I say data points you know, what I mean by features is data points you know. When a credit card transaction is occurring, what would you know? Well, I would know the name of the person doing the transaction. I might know the, person's financial history. I might know something about their credit score if I wanted to. How about the actual transaction itself? Well, I know the terminal ID where the transaction occurred. I know that terminal belongs to a business. I know the business name. This is all stuff that we know. The label would be in historical data. I'm looking at 10 years of historical data. And for each of these transactions where I know all these things, is this transaction fraud or not fraud? Right? So in the case of my credit card fraud example, the features would be, what do you know about a credit card transaction? What do you know about a credit card transaction? That would be the features. The label would be fraud, not fraud. Right. So when you're talking about supervised data, they will say supervised data is labeled data. In other words, in your historical data, you know what the right answer is at this point, right? I can look at this past credit card transaction from a year ago, and I know whether it was fraudulent or not. And really what I want to do is I want to build something that can learn the patterns, right? So I want to build something that can take the features, and from the features, I want it to be able to pick the pattern of what the label is going to be. Have you noticed how, credit card companies, you can like go to their website and they'll tell you, you spent this percentage of your charges on entertainment, and this percentage of charges on food, and this percentage of charges on gas, and this percentage of charges on this, that, and the other. And you're like, oh, that's kind of cool. I can get a breakdown of, what kind of things I'm buying and how much. And holy cow, I spent a lot at restaurants this month. But they don't actually do that for you. You might like that feature, but the reason credit card companies do that is because it helps with fraud detection, right? If a credit card transaction is occurring at Bob's, okay, what kind of business is Bob's? If you don't know what kind of business Bob's is, that doesn't really help your fraud detection. There are certain things that are more fraudulent purchases than others. In the United States, the things that are probably the most common fraudulent purchases are electronics, jewelry, and guns. Electronics, jewelry, and guns. God bless America. Because in the US, if I buy electronics or jewelry or guns, I can turn around and sell those purchases for almost the same thing, right? So they're very popular fraudulent purchases. So if I see that charge is occurring at Bob's Barbecue, it's probably less likely to be fraudulent than if it's occurring at Bob's pawn shop, okay, or at Bob's electronics store or something like that. So the reason your credit card company classifies business types is because that's a feature they can add that makes fraud detection better. So labels, that's the answer that you're trying to learn to predict. So in supervised, it's all kind of retrospective analysis. You're looking at historical data and you're trying to pick up with trends. And the goal is to identify the pattern between the features in the label. So when a credit card transaction is occurring right now, does this look like it might be a fraudulent transaction? I remember when credit card companies first started really doing this, I traveled all the time. Okay. Before COVID, from 1996 until COVID, I traveled on average 40 weeks a year. So I remember, I'd be charging gas at 6 o'clock in the morning at home. And by lunch, I'd be in Atlanta. And by, dinner, I'd be in San Francisco or something. And the credit card company would be like, no, this looks like fraud. This is fraud. And I kept having to call the company and say, no, I travel for a living. And finally, they figured it out. Well, yes. So the idea of credit card charges occurring in different parts of the country in the same day, I can see why, especially for the typical person, that might not be a pattern that works, right? Or makes sense. I'm not sure it's probably as common now as it used to be, but still, that's the kind of stuff that you pick up with this kind of training. Unsupervised, unsupervised learning, honestly, you don't know what the answer is. Okay. You don't know what the answer is. Unsupervised learning, a lot of times you're working with the data and you're trying to do things like customer segmentation, customer segmentation, DNA analysis, forecasting, seasonal forecasting, and or anomaly detection. Did I actually spell that right? I can't believe I spelled anomaly right. Anyway, oh no, I didn't think of it. Okay, yeah. Sorry. My spelling ability is pitiful. So I'm looking at that and I'm like, that doesn't look right to me. But seasonal forecasting, fraud detection. So customer segmentation. I want to break my customers up into 5 logical groups. I'm not really sure what those groups are, but I want to break it into 5 logical groups because if I can find relationships between customers, if this group of customers has similar patterns, then maybe I can advertise them to them a particular way. DNA analysis. If you fully sequence a person's DNA, it's 200 gigs of data. That's one person's DNA. Now you've got 10,000 DNA samples. Each one's 200 gigs each. And this 5,000 over here there's no history of skin cancer in their family. Skin cancer has a strong family tie. Skin cancer runs very strong in my family. My dad says it's because people genetically designed to live in Ireland should not live in Texas. That's what my dad says, right? I grew up in Texas, and yeah, they don't quite get as much sun in Ireland as they get in Texas. Anyway, so now maybe I have 5,000 samples over here. These DNA samples come from people who have a strong family DNA, strong family tie to skin cancer. Okay, 200 gigs a sample. It's too much data for a human to look at. Is there a pattern of clusters or something? Is there a pattern that shows up in the skin cancer DNA that doesn't show up in the non-skin cancer DNA? And honestly, I don't know what the answer is, right? But I'm looking for, like, they call that cluster analysis, right? Sometimes in the DNA analysis, it's really cluster analysis. Cluster analysis is like where you're looking for clusters of DNA, settings, shall we say, that are different over here than over here. Seasonal forecasting is where we're an e-commerce retailer, and we want to try to figure out, based on seasonal shopping habits, what are our sales going to look like on Black Friday, right? What are our sales going to look like on Black Friday? Is there a day where our sales are way lower or higher than they should be? Is it an anomaly, right? So seasonal forecasting, it's kind of like you're looking at patterns, but you don't really know what the answer is. You're more trying to, predict it based on kind of these seasonal trends and whatnot. So a lot of unsupervised learning is more like exploratory analysis. I don't know what the DNA pattern is, but can we find it? The human can't, because there's just too much data to see. Reinforcement learning is probably the newest and smallest of these three families right now. Reinforcement learning is mostly when you are trying to maximize more than one thing at a time. Reinforcement learning is always going to be some sort of, you get points for doing this and you get points taken away for doing that. If you ever read a question and it's something about, carrot stick kind of learning. I think on my exam, the question was, you want to teach a AI system to learn to play a game, right? Or, that's kind of reinforcement learning. Reinforcement learning is, okay, robot, I want you to be able to balance on two legs. If you balance on two legs, robot, good robot, I give you points. If you fall down, robot, bad robot, I take points away, right? But I don't want you to just learn to balance. I also want you to be able to navigate from this point on this side of the room to that point on that side of the room. If you can figure out how to navigate from here to there, robot, good robot. If you get lost, bad robot, right? Oh, by the way, I'm now going to put some obstacles in the room. If you can navigate from here to there and avoid obstacles, good robot. But if you're bumping into tables, bad robot, right? So you're trying to achieve kind of more than one thing at a time. What's the best combination we can get of you balance and you navigate and you avoid obstacles? And I want to maximize all those. So it's got to be some sort of, you get points for this and points taken away for that. Predictive maintenance. I have historical maintenance records. I have all this sensor data from, oil status and everything else. And I'm trying to learn to predict when's the perfect time to bring these vehicles in for service, right? That's looking at historical data. It's trying to derive, predictions using historical trends and stuff. That's definitely supervised learning. Anomaly detection. Anomaly detection is something that BigQuery machine learning can do. We haven't talked about BigQuery machine learning yet, but BigQuery machine learning BigQuery is a data warehouse technology, and BigQuery machine learning is a kind of SQL way of building models. Anomaly detection is looking for patterns to flag unusual things, right? Something that deviates from the norm. So part of credit card fraud detection might be anomaly detection, right? Does someone who never buys a gun suddenly go to 3 gun stores and buys guns in 3 gun stores in 1 day? Is that an anomaly, right? That's an anomaly detection. It's something that kind of stands out. It's an unusual pattern or transaction or cost or something. Recommendation system. Yeah. If you're trying to do product recommendations, a lot of product recommendations is, I'm trying to maximize more than one thing at a time, right? Maybe I'm trying to maximize user engagement and sales, by refining recommendations. Maybe that's a type of reinforcement learning. Good. Here's a scenario. Does this sound like supervised, unsupervised, or reinforcement? A developer is adding an AI component to a complex video game. The AI interacts with the game environment, taking actions and receiving rewards or penalties. Ding, ding, ding. The taking actions and receiving rewards and penalties, carrot stick, right? Based on the outcome of those actions. Through trial and error, the AI learns which actions lead to the highest cumulative reward, effectively learning to play the game. Okay, if it's any kind of carrot stick, you get points for this and points are taken away. That's reinforcement. That's what reinforcement does. You're getting positive and negative reinforcement and learning through that. An email provider uses this learning technique to classify incoming emails as either spam or not spam. The model is trained on a data set of emails that have been manually labeled. So they have a data set of historical emails, and each one is labeled spam or not spam. And we're learning from that historical data. Supervised. Supervised. Discovering the underlying topics in a collection of documents. For example, analyzing a set of news articles to identify the main topics being discussed. So coming in, I don't know what the topics are, right? And I want to try to identify the topics. So that's sort of like my customer segmentation. I don't really know what the segments of our customers are. Just like here, I don't really know what the topics are. And I want to kind of figure them out as I look for the patterns, right? That's unsupervised learning, right? You don't know what the topics are that are going to bubble to the top. So what are the major topics? Can we look at all the data and, let's break it down into 5 major topics. Okay. And you tell me what those 5 major topics are, just like break my customers down into 5 major segments. Okay. If I am building a model from scratch, and that's a big if, less and less common do I feel the need to build a model from scratch, right? Because lots of models exist. But be that as it may, if I'm building a model from scratch, there's several major phases your development process would go through. One thing you would have to do is you would have to get data together. And you would need to figure out how are you going to gather that data and where you're going to store it. Okay. Now, Google is throwing in some product names here. And I've already said this, but once again, if it's a product name that shows up on a slide somewhere, you should be able to glance at that product name and tell me a little something about it. Okay. That's not the page I want. Okay. When it comes to product names, one place you might start research. Well, actually, I would probably just go to Gemini and say, Gemini, can you tell me what this product is? But this page right here is kind of all the products in Google Cloud, right? This page here is all the products in Google Cloud, and that might be a place to start. So, for example, they just told me on this slide, I saw PubSub, right? If I come in here and I go find PubSub, global real-time messaging. Yeah, I actually like that better than real-time streaming. The streaming to me is not as clear. So PubSub is a messaging technology. Instead of me sending you an email or a text message, imagine I have an application that needs to send your application a message, right? So it's more like one application sending a message to another application. Or maybe I submit my order and it goes into some order queue for processing. PubSub would be that order queue. Cloud storage, when they say it's unstructured data, it's really files. Cloud storage is where you would store, if you had a big pile of PDFs, that was your policy documents, and you wanted me to build an AI chatbot that could talk to people about policy, I would ask you to put all your policy PDFs in a cloud storage bucket that I could work with. If any of you use the Spotify music service, where do you think all those music files are sitting? They're all sitting in cloud storage. Spotify runs out of Google Cloud. All the music files are sitting in cloud storage. Cloud SQL, Cloud Spanner, they are databases. They are relational databases. They work with tables of information, right? So again, if it's a product name mentioned in this class, I'm not saying you got to be any kind of expert on it. I'm saying you should at least know what it is. Because if there was a question on an exam that said something about files sitting in cloud storage, it's going to stress you out if you don't know what cloud storage is. It would stress me out, right? When Google likes to drop product names, and you'll see them in questions, you'll see them in answers. And sometimes knowing is it this answer or that answer is being able to tell what those product names are they're mentioning. Okay, preparing your data. Preparing your data means getting your data useful. Okay, feature engineering. What data are you going to leave in? What data are you going to leave out? How are you going to convert data into usable file formats, kind of stuff. If I'm doing supervised machine learning, remember I have big tables of information. And in Google Cloud has a data warehouse product. Google Cloud has a data warehouse product called BigQuery. It's big tables of information, and it's designed to help you query those big tables of information. Yeah, that's what it's for. So if I need to prepare my data, getting it into BigQuery might be one of the steps. But then if I want to start doing things like converting data types or, getting rid of certain columns or maybe combining columns, that's all stuff I could do with BigQuery with SQL. Yeah. Train your model. Okay. They left out that little step where we have to code the model. But training the model would be, I'm in Google Cloud, assuming we're training in Google Cloud. I'm in Google Cloud. Maybe I have my data in Google Cloud. You see feature store and data sets. That's like for wrapping up data. And then you see the training right there. Yeah, training. And right below it where it says experiments, that's all about training. These are all products in Vertex AI. So Vertex AI, Google does lots of AI. Google knows where the pain points are. Anyone doing AI, there's certain things you do that are just a pain, right? Google knows where those pain points are. And what Google is basically saying to you is, come to Google Cloud. We will take away some of your pain because we have tools to help you, right? You're never going to get rid of all the pain. It is a pain training models, but Google knows what it takes. And so they have a lot of things to try to streamline that as much as possible. At some point, you're going to want to deploy and predict. Well, yeah. If I scroll down here, do you see model registry? If you built a model, that's where it would live. Do you see endpoints and batch inference? That's where your models would run. I've built this fraud detector. I need to run it somewhere. I'm assuming you're going to want to do real-time fraud detection, not like batch fraud detection. Yes, I want to do real-time. Okay, then you want to deploy an endpoint, right? And Google would help you take that model and basically help you build a server or a group of servers and get your model installed and set up a point on the internet where people could come in with the right credential and access your model from applications. You familiar with the term microservice or web service, something like that? That's what those endpoints are. They're just services. So I want to deploy and predict. Vertex. Vertex can help with training. Vertex can help with deploying and prediction. And yes, Vertex can also help managing your model. A model is an artifact you have to think about. You're going to have to store it somewhere, model registry. You're going to have to create maybe multiple versions and store those somewhere, model registry. So yes. Google also has a whole monitoring section here in Vertex, which is the model doing what it's supposed to do? Drift monitoring. When we deployed the model 6 months ago, what was the quality metrics we were seeing? 6 months later, are we still seeing the same quality metrics? Or are we starting to see a drift where there's some trend occurring that's making our model not as useful or not as accurate? No. Okay. Now, the biggest risk of exposure you have through Google Cloud is misconfiguration of permissions, right? If you put data in Google Cloud, no one's going to hack the data out of Google Cloud. It's just not going to happen. The security Google Cloud has is too solid. The way someone's going to get your data out of Google Cloud is somebody's going to accidentally flip the switch from this position to that position, and it shouldn't have happened that way. And you've now inadvertently exposed the data to someone that's not supposed to get it. Identity and access management is most of those switches, like in my story. Basically, this is where I can decide who can see this and who's going to get blocked. If I set the permissions wrong and I expose things to people who shouldn't be able to see it, that's a problem we have, right? So identity and access management, if you ever saw a IAM in a question, anything about permissions management and role management and stuff like that, that typically goes back to IAM. Who can do what in Google Cloud? How does consistency impact model training? Okay. It increases the speed of data retrieval. Yeah, no, I'm not sure it has anything. Is your data consistent? Does that have anything to do with, if all the dates are in the right format, does that help you retrieve dates faster? Probably not. Inconsistent formats and labeling can confuse the model and hinder learning. Okay, I think that's probably true. Consistency reduces the need for data storage. No, just because the dates are in the right format doesn't mean I have less to store. It ensures data is relevant to the task. It's not necessarily relevant, right? I think it's more that if I don't have the dates in a consistent format, then I have an issue with that. Have you noticed that more and more websites now, when you go to type an address, you're buying something, you're shipping it to yourself, and you start typing the address, and it pops up a list of choices, right? So you can pick the address from the list. They're trying to get consistent formats, right? Because do I spell road out? Do I say RD? Do I say RD period? Do I have a US zip code? How about that 4-digit extension that I don't even know what the 4-digit extension is for my house? How about that 4-digit extension? So the reason that more and more websites are prompting you to type your address and they are then asking you to pick it from a list is because that is like the official right address for this person, right? And that helps them with consistency. What is a model in the context of machine learning? It's a type of hardware. No, it's not hardware. It's a set of predefined rules for decision making. I'm thinking probably not. It's more than just rules. It's a visual representation of data. There's nothing visual necessarily about a model. It's a complex mathematical. That's what I was looking for, right? You remember that's the way I defined it. I said it's a mathematical system. It's a complex mathematical structure that processes inputs to generate outputs. Do you remember in school when you were in grade school or something and you had the function machine and there was a funnel and you put a number in the top and the function did something and an answer came out? That's it. Only it's a lot fancier than that function machine you talked about in whatever grade that was, right? It's a mathematical system. We put inputs in and it does something math to get an answer out. It's almost all statistics. What is the primary way that agents learn in reinforcement learning? Okay, we haven't talked about what an agent is yet, but what is the primary way that blah, blah learns, in reinforcement learning? By being explicitly programmed with correct actions. That describes nothing in AI, right? That's more traditional programming. By observing and imitating expert demonstrations. I'm not sure about that. Reinforcement learning, what did we say, right? By interacting with their environment and receiving feedback, by analyzing large data sets of labeled. Okay, I think it's probably going to be receiving feedback, right? So expert demonstrations, that's almost like supervised learning. You're learning from historical data. By analyzing large data sets of labeled examples, again, that's much more supervised data to me, right? So the only thing that they're saying that's remotely like reinforcement learning is the whole receiving feedback. And what really would have cinched it for me is if they had said something like by receiving positive and negative feedback. I would have been like, oh, there it is for sure, right? They were a little vague here with the receiving feedback. Is it lunchtime? I think it's coming up on lunchtime. Okay, so we're about to break for lunch. Before we break for lunch, once again, if you did not already get it, tinyurl.com/Google-Gale is the PDFs I'm running through. That's a zip file. So you can go to that link. It'll should immediately download a zip file, open up the zip file, and you will see the lecture notes that I'm going through today and tomorrow, right? The QR code and tinyurl.com/Gale0129 is this page I'm showing you. Right? It's this page I'm showing you here with the extra information in it. Remember, we have office hours next Friday. I'm mostly going to be talking about test taking strategy and looking at sample questions, right? We have a LinkedIn group. You're welcome to join us on LinkedIn group. They'll be adding the replay links If you want to go back and watch this video again after class, it is being recorded. And for the next couple of weeks, you'll be able to do that. They're going to put the links there at the end of today. After the event, if you have general questions, Gale Cert Workshop. If you send me an email and say, I didn't get my voucher, I'm going to forward your email to Gale Cert Workshop, because that's where you should send it. They're good with those kinds of questions. Course evaluation, we'd love feedback, but maybe wait till tomorrow. Little information on the email coming from Google after class with your voucher comes from that address. So when you're searching through your spam, that's the from address if you're interested. Remember, the free voucher that they're giving out is only going to be good through February 21st. So, you guys have from now until February 21st to get that cert done, which is basically a month. So you guys have something like a month to get the certification done. That's perfect. 2 weeks, 3 weeks. I think that's ideal after a class like this. My contact details, you want to reach out to me, some general links on the Gale certification, and any links I've been sharing with you in class. All right, good deal. So I'm just going to leave this right here so you guys can grab out the link if you want, or have a moment to see those links if you want. And we are going to go ahead and go to lunch. I will see you guys back at 1 p.m. Pacific time.
chanter.
All right. About that time. Hope you guys had a good lunch or whatever it is, wherever you are. A late afternoon lunch for me. I'm Central Time, so that was 2 to 3 my time. I'm in this part of the country. I'm down here on the Gulf of America. Yeah, so I'm from Dallas, Texas originally, and I kind of married my way into Mississippi. My wife's the one that's from the area where we live. This is one of the wettest parts of the continental United States. If you pull up a list of the 10 wettest cities in the United States, 3 or 4 of them are within an easy drive from me. So very wet, very humid down here in the summertime. Usually pretty mild in the wintertime. We are getting the cold front everybody else is getting, but generally down here, if it's cold, it's very clear. So if it gets below freezing, it's very clear. Last year, I think we set the historical record with 6 inches of snow. And my wife and I adopted a 7 and an 8-year-old last year. So the kids keep asking us, when's the snow coming this year? And it's kind of hard to tell them. My wife's from the area, and in her life, it's only snowed that one time. So we probably aren't getting lots of snow this year, but you never know. We'll just wait and see. All right. So we were talking in here a little bit about, data and kind of if you're going to build your own model, what are we going to do with the data? What are some of the steps we're going to go through? And we kind of talked about the major learning styles. Most machine learning is supervised machine learning. We know what historical transactions we have. We have identified fraud or not fraud in each of the historical transactions. And so, we are trying to learn to predict patterns that indicate fraud, right? As opposed to trying to pick up patterns that we don't know about at all. And so unsupervised, it's more, we're looking for patterns still, but we don't know what the patterns are. And a lot of times the patterns might be things like clusters that exist here, but don't exist there, right? Is there a cluster of DNA components in the people who have skin cancer that people who don't have skin cancer don't have, right? Yeah, so that's kind of what we were talking about. A lot of data, structured data, the bread and butter of most, systems, e-commerce, customer tracking. Unstructured data, sort of the wild, wild west, where we're trying to figure out what can we do with all this unstructured data to make it more useful. And of course, generative AI is going to be a big component of that, as we've said. Okay. We've already introduced the idea of foundation models. Foundation models are neural networks. Neural networks is part of a broad field of machine learning called deep learning. So you have the machine learning, which is I'm trying to learn by example. I'm trying to learn to see patterns in a kind of trial and error sort of way, right? And they got a little typo here. Deep learning really should be a circle like this. Deep learning should be a circle closer to that. Deep learning is a subset of machine learning, and inside of it is generative AI, right? Generative AI is a technology that is built on neural networks. And you remember I gave you guys the MNIST example where I said, I showed you a toy neural network. I showed you a very small neural network when I did that example earlier in the course, So when we were talking about this, this is an example of one of these deep learning neural networks that we're talking about here. Okay. Generative AI uses the power of deep learning. In other words, it's using neural networks to create new content spanning text, images, audio, and beyond. But remember, just like us, it learns from past information. If you want to learn to write, what do you have to do? Well, most people say, if you want to learn to write, you should read a lot. Most authors read a lot. Not all of them. There's a couple of notable exceptions, like Irving, who doesn't like to read at all. most authors read a lot, and then there's, and then they say, if you want to learn to write, what do you have to do? Is you have to practice. They say you need to, maybe write about 1,000,000 words before you've really figured out how you know how to write, right? So generative AI has kind of done that, right? It's learned from examples. It's been fed, imagine a bookcase that's maybe 500 miles long, and that is not an over exaggeration. It's been fed massive amounts of information. It understands that information, and it can take that information and sort of combine it in different ways, right? The reason a writer reads is to see how people do things, and then you kind of have your own style, and you kind of combine elements of these other things. Well, generative AI kind of does the same thing. Generative AI has read Stephen King. Generative AI has read John Irving. Generative AI has read, all these different books and everything else. And it's trying to kind of pull that together to have information, but also to know how to write, to know how to create. So foundational models, they use deep learning. They use massive data sets. And as we said before, massive data sets. And a lot of times they get pretty good at like a category of things. They're not just good at one thing. They're sort of good at a category of things. Gemini is a great example. Gemini can do all kinds of stuff. Gemini can do translation. Google Translate can do translation. But, Gemini can do translation, because if you're going to feed a model a bunch of text, why just feed it English? Why not feed it content from a good collection of your major languages in the world? So in general, models like Gemini are considered language models, right? They are conversational, and the goal is I set a task using words, maybe pictures and other stuff, and the language model, takes care of the task and gives me an answer using words. That's mostly what your language models are. Okay. Now, it's a little murky with multimodal. If I have a model that can consume more data than just words, most people still call it a language model. Diffusion models are really about high quality images, right? And your diffusion model in Google Cloud, well, we're going to talk about it in a minute. Your true diffusion model in Google Cloud is Imagine, is the way they pronounce that. It's not Imogen, it's Imagine. And Imagine is Google's diffusion model, right? And it's designed, you give it a description, and it goes through and it creates an image from the description. It's a fascinating process. If you want some time, go to YouTube and do a search for, how does a diffusion model work? It's a pretty interesting topic. What's the correct term for a subset of AI that enables machines to learn from data without explicit programming, improving their performance over time? This is the circles, right? Is that AI? Is that deep learning? Is that prompting? Is that machine learning? Machine learning is what they're really described. First off, they said a subset of AI. So the minute they say a subset AI should be out. Enables machines to learn from data without explicit programming. That's kind of the classic machine learning example. And when they say without explicit programming, what they're saying is you don't say, if there's a circle and a line down the right-hand side, then it's a number 9, right? That's what they mean by explicit programming. You're not like creating an if statement that does this. All right. What is the correct term for a broad field of computer science focused on creating machines capable of performing tasks that typically require human intelligence? In other words, trying to make computers more like humans, right? Or machines more like humans. That's AI, right? That's the broader field. That's the big circle. What is the correct term for a specialized subset of machine learning? AI is out, machine learning is out. That utilizes artificial neural networks with multiple layers to analyze complex data patterns. That's our deep learning, right? And when they're saying the whole multiple layers thing here, do you see this is a layer of neurons, and this is a layer of neurons, and a layer of neuron, and a layer of neurons? Yeah, so when they talk about multiple layers, that's also called deep neural networks. Deep neural networks implies you have more than one layer. All right. In the world of generative AI, most of what we do is not going to be we build a model. In generative AI, it's too expensive to build models, right? For the most part. Building a more basic model, that's doable. But in generative AI, these big do everything, deep understanding, massive data set built models, they are expensive to create. We're talking hundreds of thousands to millions of bucks. Google is spending probably billions of dollars on Gemini, but to do one training job, it's just a massive amount of, imagine you've got 70,000 servers working on one job for 2 or 3 months. That's kind of what you're talking about when you're talking about building these big neural networks, these big generative models. So a lot of times the question is not going to be, when do I start building my model? In generative AI, a lot of times the question is going to be, which model do I want to use? Right? Which model do I want to use? If I'm drinking the Kool-Aid, if I'm drinking the Google Kool-Aid, then of course the answer is, of course we're going to use Gemini, right? Well, maybe. I think Gemini is an excellent model. It does a great job. I think the benchmarks on Gemini 3, the new version of Gemini, show it to be, certainly one of the top models out there. But ChatGPT is out there. Claude is out there. Grok is out there. Those are probably the big four, right? That's probably your big four out there. ChatGPT, Gemini, Claude, Grok, those are probably the big four, probably in that order too. ChatGPT still, since they were first to market, they still have a little bit more market share than Google, but Google is rapidly closing that gap, right? It's certainly conceivable that sometime in the next couple of years that Gemini will become the most popular model. But be that as it may, you have maybe 4 major models out there in the world. And that's before you get to some of the smaller models, like Llama or Gemma or ChatGPT open source or something like that. Okay, so if I'm trying to build an application using generative AI, we are going to be talking about agents in a little bit. If I want to build a multi-agent application, I want to build it in Google Cloud because I think Google Cloud has the best tool set for that, right? One of the things, when ChatGPT came out and beat Google to market, Google was ticked off. Can you imagine being Google? You invented this technology, and this company you've never heard of, OpenAI, is suddenly using your technology to make big bucks. Google was irritated. What should we do? Google approached the problem 2 major ways. One way Google approached the problem was, we need a better model. Because I'll tell you right now, in April of 2023, when Google called me up and said, we want you to help us write a class, Google's model was nowhere near as good as ChatGPT, right? That's no longer true. Google, again, at this point, if my boss came to me and said, I had to use Gemini and no other model, or I had to use Claude and no other model, or I had to use ChatGPT or no other model, I could make any of those models work. Because honestly, your 4 big models at this point, they are so close to each other in terms of quality and performance and everything else that I would not be disappointed. But I will tell you, I do have an account at Gemini. I do have an account at Claude. I do have an account at ChatGPT. And when I try things out, sometimes I will take one question and I will drop that one question into all 3 of the models because I'm curious to see how they respond differently. Is there a particular model that handles this question better than other models, right? Is this a central question to an application I'm building? If that's true, then could that be a reason why I pick one model over another one? If I'm building an agent, an application designed to handle some generative task, right? If I'm building an agent, no question in my brain, put it in Google Cloud. But there is a question in my brain, which model am I going to use? Because not every agent I've written has used Gemini, right? So if you're thinking about different models, what are some of the considerations between this model and that model? What are some of the things you should think about? Well, you should do some research. You should go out there and look at benchmarks. Gemini 2.5, and now we have Gemini 3.0. You can do a lot of searching online to find websites where they will compare different benchmarks. Of course, the minute you say, Gemini 3 benchmark information, if I come out and I go look at, Gemini benchmarks and our most intelligent model. Okay. And I start seeing benchmarks. And how is it doing in humanities last exam? How is it doing in the math arena apex? How is it doing in Omni Doc Bench 1.5? How is it doing in Vending Bench 2? How is it doing in, this is a good one, MMMLU? Okay. Did I tell you I went to school to be an actuary? I remember having this college professor, and the college professor walks into class the first day. My first class in my actuarial program was probability and statistics. The college professor walks into class and he pulls out a roll of $100 bills, and he peels a $100 bill off the roll and he drops it on the front desk and he says, "I bet two of you have the same birthday." Luckily, none of us were were stupid enough to take that bet. Okay. Then this guy was one of these people that could do like pretty big number math in their head. So then he turns around and he does all the probable math to show that I think it's like upper 20s. If you have at least 20 something people together, the chances, you're at like 50-50 that two people have the same birthday, right? Anyway, so that same college professor, at one time he told us, he says, "I teach college because it looks good on my resume." He says, "I make most of my money testifying in court cases and gambling," which I guess I should have clued into the first day. So he says, "I make most of my money testifying in court cases." He says, "I'm a PhD actuary who teaches college classes in it." So they hire him to come in and testify in cases. And he said something one day that was really interesting. He said, if I get hired to prove something statistically, if I can do it, I get paid and I get hired again. If I can't do it, then I get paid, but I might not get hired again. And he went on to talk about making statistics say what you want, right? So I told all that story, besides the fact that it's just interesting or funny. I told that story because what the heck is humanities last exam? And does humanities last exam mean anything to what you're trying to do, right? So you will find all these models. They all have all these cool benchmarks. And you see they're saying, hey, do you notice that on humanities last exam, Google Gemini 3 Pro does better than ChatGPT and better than Gemini 2.5 Pro, and poor Claude is the worst one, right? And so do you see, they're kind of showing you all these benchmarks. It's interesting and it's impressive, but do these benchmarks have any correlation to what you want to do? If you don't dig into the stats, right? This is like my college professor's point. If you're skillful with the way you present statistics, you can make them say pretty much anything you want. It is impressive that Google does so well on all these benchmarks. Are there benchmarks, though, they're not mentioning because they didn't well? And why should I care about these particular benchmarks? MMMU Pro, what the heck is that? And does that impact what I'm trying to do? So research your models, yes. I absolutely say you should do that. But if you want to use benchmarks, figure out what benchmarks are going to be proving something that's close to what you want. Some of these benchmarks are like, here's 1,000 questions from history. How well are you, how good does the model do at answering history questions? Do I care if I'm building a model that's supposed to do, technical support chatbot? Do I care that the model is good at history? I don't need that, right? So do a little research, but also don't just say, wow, that's a lot of benchmarks and Google won all of them. Pay attention to some of the benchmarks and do a little research to figure out why is this an important benchmark? Some of those benchmarks are very industry standard. Every model will say, look at how well we do on this MMU thing, but look at what that benchmark really does. Also, there is some subjective stuff in here. The reason I have an account at Gemini and ChatGPT and Claude is because I do a lot of personal research. When I have a complex problem, I will take it to all three models and I'll give it to them and see how they do, right? And sometimes I'll tell you, there's a clear winner that this model, wow, it totally got how to do this problem, right? Now, that's to me kind of a subjective measure, but still, objectively, besides researching on benchmarks and doing our due diligence so we actually understand what the heck that benchmark means, what other things should we look at? Well, does the model accept data in the formats that we have, right? There's a lot of models out there that are text only, right? They can't take images. They can't take video. How about file types? What if I have an Excel document? Can the model actually consume an Excel document, or do I have to convert it to some other format first, right? Context window. The context window is basically the size of information it can consider at one time. I like Claude, the model. There's a lot of things I like about Claude, but I have been using Claude on a project where I had thought to myself, I think Claude's going to be the best model. And I have a day-long conversation with Claude. I mean, the whole day long. I'm asking Claude questions. It's giving me answers. I'm asking Claude to create things for me. It's creating it. I'm asking Claude to update it. And I'm doing this. And I'm having this conversation back and forth all day long. And it's getting late in the day. And suddenly Claude says, I'm sorry, this conversation is too long. We can't continue. And I'm like, what did you say? And you're like, excuse me? And it's like, error. What did you say? Error. Claude has relatively a small context window, right? If you're asking it a few questions and you're getting a few answers, no big deal. But if you have a really long conversation with, you're passing documents back and forth and everything else, you can run Claude out of context window. And I can't express to you how depressing it is to know that you had this conversation and you got to the point in the afternoon where this generative AI technology is giving you exactly what you want, because you've spent all morning refining your refinements and refining what you're doing, and Claude understands. And it's kind of like all of a sudden that person that you just trained up to be an expert at this leaves and is never going to come back again, and you have to go to somebody new. You have to open a new conversation and start from scratch. It is beyond annoying. So Claude's a good model, but the context window is tiny. It is much smaller than, say, Gemini. Gemini has the biggest context window in the market, right? So when you're talking about a conversation, remember, a conversation, the model is not really processing one piece at a time. The model is really, the context window contains the entire conversation. So when you're having a conversation with a model, it's not that somehow it has memorized the conversation. It's more like when you ask the next question, it speed reads the entire conversation up to this moment, and then it knows how to answer the next question, right? So as the conversation gets longer, the context window is getting more and more filled up. Okay. And I mentioned in the big three, if you get into some of the smaller language models like Gemma or Llama or something like that, they have much smaller context windows than any of the big three do. So can it handle enough information to process what you want? What do you know about the security, right? If you hand this model super secret intellectual property that belongs to your company, is it going to protect that? Is it going to keep that secure, right? Is the model locked down to prevent other people from doing things, right? I talked about free versus not free. This is the pay version of Google Gemini. How do I know it's the pay version of Google Gemini? Well, if you look up here in the upper right-hand corner, do you see where it says Pro? That's the pay version. I'm at work. I'm on the Pro version. This version of Gemini comes from my business through my Google Workspace, right? ROI Training, where I work, has Google Workspace set up, and they have the feature enabled so that I'm getting Gemini Advanced from Google Workspace. Now, if I go to one of my personal profiles and I go to Gemini in my personal profile, do you see up here what it says instead? Wouldn't you like to upgrade to Google AI Plus? I'm now in free Gemini. Okay, we all should know there's no such thing as free, right? If you pull up the privacy center, right? If you pull up the privacy center and you go in here and you read about how your data is used in the free version, basically your data, Google is capturing your entire conversation, right? Google is going to capture your entire conversation and they're going to use it to make Gemini better. If I come in here and I say, tell me about William Faulkner. If I ask the model to tell me about William Faulkner, and it comes in here and it gives me a, that's a heck of a name, isn't it? It gives me he's from Oxford, Mississippi. Oh my gosh, the sound and the fury. Don't make me read it again. Anyway, so he gives me all this information about William Faulkner. And you see down here, maybe I'm a Faulkner expert. And I'm going to say, wow, you did a great job. Or maybe I'm a Faulkner expert and I'm going to say, you just gave me something that's not factually correct. If I say you just gave me something that's not factually correct, I just created a to-do task for somebody at Google. Because some human is going to look at this and they're going to look at my question and they're going to look at the answer and they're going to do some research to figure if that's factually correct or not. In other words, when you are in the free version of Gemini, your entire conversation is saved by Google. Any opinion you have about this is good or bad is saved by Google, because that's the reason it's free is Google's using that to make Gemini better. We got all these people that are playing with Gemini and, they're offering opinions and all that's being used. Statistics say the fastest way to improve the quality of a generative model is human feedback. And that's what Google is doing with the free model. The pay model, no. The pay model, Google guarantees you in the privacy statement that nothing you say to the pay model will go beyond that conversation, right? You can leak intellectual property through the free model, but you can't leak intellectual property through the pay model. So that's part of this security. I would not be comfortable saying to my employees, we've decided we're just going to let everybody use the free model. Oh, but by the way, everybody, I don't want anybody to put anything that's sensitive or intellectual property sensitive into do you trust your employees really not to do that? I don't, right? I'd rather have the pay model where I know my data is not, my conversations aren't going anywhere. Availability and reliability. Okay. Unfortunately, I got another Claude story here. The model that I have gone to the most where it was temporarily down, and usually just down for 20 seconds, 30 seconds, a minute, is Claude. So, availability and reliability, it's a good model, but if it's mission critical and it's down 30 seconds here or 30 seconds there, can I depend on that? So that's something that I have to think about as well. Cost. How much is it going to cost you to run this model? I've already said, not a big fan of the free models. So if I'm paying for this model, how much am I paying? How is it billing me? Right? If you're talking small volume stuff, you may be paying a couple of bucks a month and who cares? But, if you are running a model and you're going to put it on the UPS homepage and people are going to be you're going to have tens or hundreds of thousands of people having simultaneous conversations with this model all day long, 24 hours a day. At some point, somebody's going to look at this line item and say, you spent how much on Gemini, right? Could we save money? Well, for example, do you know Gemini 3, the new version of the Gemini model, is more expensive than Gemini 2.5? Also, Gemini 3 is not really out of beta yet. It's in preview still. So do you want to use a preview version model that's more expensive than the GA model? Maybe use the GA model because it's GA, but because it's also cheaper and it gets the job done. Okay, what about 2 generations ago? Gemini 2.0 is still available. Could you get by with Gemini 2.0? Because it's going to be a fraction of the cost of Gemini 3. So, and that's just within the Gemini world. How about we compare the cost of the latest Gemini to the cost of the latest ChatGPT to the latest cost of, they're all going to be fairly expensive, comparatively speaking. But a lot of times Gemini undercuts them. One of the ways Google is trying to compete with Gemini is they're trying to price Gemini so it's a little bit cheaper than the other guys, right? Performance. How fast are you getting an answer? If someone comes in and asks a question, and then they get their answer, is that fast enough? How about other performance things? The other day, I had a problem. I had 10,000 records in a database, and I wanted Gemini to look at every record and generate a summary for me. Is what I wanted. So I needed to use Gemini, but I needed to use Gemini 10,000 times in a row. So I wrote my first generation of the script, and it's like, okay, record 1 processed, record 2 processed, record 3 processed. And I'm like, stop. I'm going to be here all day at this. It's going to take hours to do that. And so I looked at the documentation and it said, do you know that Gemini has a batch mode? When you write code, you can do multiple simultaneous things. And I'm like, I didn't know that. So what I did is I rewrote my script and I said, let's do 500 records at a time. Here's the first 500 records. Okay, they're done. Here's the second 500 records. And instead of hours and hours, I was done in minutes, right, with my 10,000 calls. So that's a performance feature. The fact that I can take Gemini and put it in this like batch processing mode and do multiple simultaneous things. Yeah. How about customizability? Honestly, none of your big models are very customizable. Gemini, ChatGPT, Claude, Grok, none of them are very customizable. They're really good, really powerful, but they're not super customizable. When you get into things like fine tuning and customization, there are some smaller open source models that are actually way more customizable, right? So if you're trying to build a super specialized model to do one thing, it's not going to be Gemini. It's going to be one of the open models. Google's going to hope you use Gemini's little sister, who's named Gemma. Gemma is a model from Google that is much smaller, but also importantly, it doesn't require Google Cloud to run. You can download Gemma out of Google Cloud and run it like on a server somewhere. How easy is it to integrate this into your application? You know, that when I was talking about performance and I was saying I could do, like batches of 500 at a time, that was really easy for me to code up. So that was a nice feature that the model had that I could use that helped me with a complex task right there, really quick. So how easy is the API? How easy is it to write? Do you have a prototyper that can help you do it? When I was showing you the token count a little while ago, and I was over here, and I was in Vertex AI Studio, and I was like in here showing you the token count. This is actually a code prototyper, right? So if you want to prototype writing code for Gemini, this tool helps you prototype it. So it's literally a visual tool that can help you write the code, which is nice. Product name. Gemini is the flagship model from Google that does so much cool stuff. And it's the brains inside the Gemini website, right? It's the brains inside the Gemini website. It's the brains inside a lot of your Google tools. Gemma is that little sister that Gemini has, and it's a open model. It is much more customizable than Gemini is. So the argument for Gemma might be, okay, I need a model and I don't want it to be cloud-based. I want to be able to download it onto a server in my data center and run it there. Or could I get a model small enough to run on something like a phone? There's an argument for models that are very small. Sometimes they call them small language models. There's an argument for language models that are fairly small. Gemma is still pretty big in the biggest version, but it's got some fairly small versions. And there are other models out there like Llama that you might even be able to get smaller. And again, the thing with Gemma is not nearly as capable as Gemini. Gemma is a relative, but it's a much smaller, less capable relative. Okay, what if I don't need Gemma to be super capable in a general sense? What if I want to get a model that's generative, but it can do one thing and only one thing, and that's answer questions on emergency medicine? Could I take a model and basically give it specialized training? So instead of memorizing historical facts and information about William Faulkner, could I get it to remember a bunch of facts about emergency medicine? Because my goal is I'm going to put this on a laptop. And when you go to Antarctica and you don't have a doctor with you and you're going to be out of reach of a doctor, maybe you have this server that can offer advice on what to do with that person that has appendicitis, right? So if I wanted to do that, Gemma is a model I could do that with. It's a small, relatively model, and it's very flexible, very customizable. So you could train it to handle specific subtasks. Imagine is Google's mainline image generator. Imagine is a diffusion model, and it's really good at creating high quality images from textual descriptions, right? I want to generate an image, and I'm going to use, Imagine. Can I not get to Imagine now? Huh. Okay, well, never mind. Now, one thing that Google has done is Google has brought up, I don't think this is on the exam yet. The real deciding factor is look at the exam guide. If you run across a technology that's not on the exam guide, then it's pretty safe to assume it's not on the exam. But I did want to, just for your own edification, Google does have a model called Nano Banana now, right? Nano Banana. And Nano Banana is basically a combination of a diffusion model like Imagine and a language model like Gemini. So straight diffusion models like Imagine, the challenge with them was always they were really bad at text. If you wanted a painting, they did a good painting, but they didn't really understand the whole text thing. So if you wanted a painting and you wanted a sign in the painting that said something, it didn't understand that. It didn't do a good job with that, right? What they've done with Nano Banana is they've taken kind of the best of Imagine and they've combined it with some of the functionality of Gemini, and they have a new model and it can do paintings. But if you want a infographic or you want text in there, it's now really good at that. So I don't think you would see Nano Banana on the exam yet. I don't think they've updated that, but at some point they probably will. VO is the video creator. If you want something that can actually help you take a text description and create short videos, it's something else. It's pretty amazing, the videos. And lately I've seen kind of a proliferation. Sometimes when I'm bored and like doom scrolling somewhere, I'll be on YouTube and I'll be watching videos. And lately I've seen a proliferation of videos that you can kind of sort of tell are AI. And I always wonder when I see that, how many of them are being created with VO? But VO is a pretty good video creator. It does a really good job. Okay, so nothing but product names. If you see the product name on a test question, do you know what it is? Do you know what it would do for you? Yeah. Now, foundation models always have some limits. If I go back over here, and I say, I want to do a chat conversation. I want to do a chat conversation. And I'm going to come into my chat conversation and I'm going to say, well, let's use Gemini. And I'm going to go ahead and use Gemini 2.5 Flash. Gemini 3 is in preview right now. Gemini 3 is in preview. But I'm going to go back to the generally available 2.5 Flash. Okay. Now, while I'm in the generally available 2.5 Flash, do you see right there in the little pop-up, do you see where it says knowledge cutoff is January of 2025? Yeah. If I pick a model and I disconnect it from something like Google search, that model is now in a blind box. That model cannot see the world around it, right? And now I come in and ask a question. Hey, who won the last World Series? Who won the last World Series? And Gemini says the Texas Rangers won the last World Series in 2023. What? Gemini might say that it was updated in January of 2025. But remember, you can't train a generative model over changing data. You have to collect a big, huge pile of data together, and then you train over that, and it can't change during the training process, right? If data is changing during the training process, the model doesn't know how to do that. Let's try again. It doesn't know how to do that if the data is changing, right? So it says that the knowledge cutoff is January 2025, but obviously not all of the knowledge was cut up to date in January 2025. All models inherently, they're behind the times, right? They do not know what has recently happened, not unless you give them a way to figure that out, right? In other words, if I turn on access to Google search, Gemini would know how to answer this because it would just do a quick Google search and Google would tell them, who won the 2025 World Series, right? So that's a data dependency knowledge cutoff. Google picked the data that Gemini learned from, and Google doesn't really tell us what that data is, right? And Google also decides when do they update the model, but that's not everything in the model. Obviously, they didn't update their sports trivia to January 2025, right? So all models, you are at the mercy of the model owner as far as what they learned during training and when was the last update they saw. The only way to update Gemini so it has more recent data is to retrain Gemini with new data, right? Bias and fairness. Bias and fairness, we've talked a little bit about. I gave you my example of bias with the facial recognition and with the writing story. Bias is when the builders of this model pick their data, does the data illustrate some sort of bias that the model picks up? Is the model as fair as it can possibly be in doing things, right? Um, I think Google does a pretty good job. I think Google has a whole building full of people who are thinking about nothing but how can we hunt down any sort of bias or any sort of unfairness inherent in our model and get rid of it. So one thing I trust is that Google is at least trying to make their model as bias free and as fair as possible. And I think Google puts a lot of time and effort in that. If for nothing else, if somebody can prove the model is biased, you don't think Google's going to get sued. I think they're going to get sued. Google's got a lot of money, right? So Google, if for no other reason, is very self-interested in making sure their model is as bias-free and as fair as possible. But what if you find a model from someone else? You can go places like Hugging Face. You can go places like Hugging Face. On Hugging Face, they have available 2.5 million with an M models. Now, not all these are big language models, but there's 2.5 million models out here. There are some pretty big models, and there's plenty of language models out there. Yeah, but if you go find a language model built by somebody you've never heard of, because these are all open source, do you trust them? Do you trust that model knows how to, do you trust whoever picked the data for that model that they picked data that's going to be as, fair as possible? That's something you got to think about. Hallucinations. You want to see hallucination? What's the high temperature going to be in Pascagoula today? In Pascagoula, Mississippi. What's the high temperature going to be today? And it says it's going to be 79 degrees. Yeah, that's not true. It's not going to be 79 degrees. Where did you get that data? And the hallucination is going to continue because it's going to say, well, I have access real-time information from various data providers and weather services via their APIs. Lies, deception. It did not. That's a total hallucination. Models are not really self-aware. Gemini is not smart enough to realize that it's locked in a little box and it has no access to any data whatsoever, right? It doesn't understand that. It can't understand that. And watch this. You want to really see that. What's today's date? What's today's date? And Gemini says, why? It's May 8th, of course, of 2024. Yes, in May, it will be 80 degrees at my house. I can see that. And probably raining, right? And probably 90% humidity. So, but do you see what I'm saying? These are all hallucinations. The model is not self-aware in a way that a human would be, right? If I lock it in a box, it's not smart enough to really know that it doesn't actually have access to real-time systems. It's read a lot of books, it's read a lot of information, but if you were locked in a box, you wouldn't know what the date was either. So these are hallucinations. The model gets confused about stuff. The easiest way for me to fix this, by the way, is I turn on access to Google search. And now I come in here and I say, hey, who won the last World Series? And it runs a quick Google search. It runs a quick Google search, and it tells me the Dodgers ran the last World Series in 2025. And that's according to Wikipedia and Baseball Reference and Wikipedia and YouTube. Okay. LA City. Okay. What's the high going to be? Do I need to type Mississippi? Are there any other Pascagoulas in the United States? I doubt it. Okay. Pinpointing today's, do you see? The high temperature today in Pascagoula, Mississippi, January 29th, 2026 is going to be 56. How do I know? Well, I know because I literally Googled high temperature Pascagoula, Mississippi, and it told me what the high temperature is going to be. That's all it did. So when you talk about hallucinations, models are like people. They get confused. Have you ever been absolutely convinced of a right answer only to later on you find out that it's the wrong answer, right? Models are the same way. They will be absolutely convinced, and they are very convincing. They will talk you, oh, this is absolutely positively the answer. Sometimes they're wrong. And the number one way you improve the likelihood of them giving you the right answer, by the way, is you control the data they use. Did you read the article about the Chevy dealer? And the Chevy dealer decided they were going to build a chatbot to answer questions on vehicles. So they built a chatbot and they put it on the Chevy dealer homepage. And somebody took a picture where they went to the Chevy dealership chatbot and they said, I want to buy the best selling truck. And the Chevy dealership chatbot said, then you should buy a Ford. not what you want your chatbot to say. Chevy should not be saying go buy a Ford, right? Why did it do that? Well, because they didn't control the data it used. If you're just using Google search, if we go right now and say, what's the best selling truck in America? Ford, there's a good chance it's going to be Ford or Toyota. Those are Ford typically is every year in at least one category, the best selling truck in the US, right? So if you're just grounding in Google search, then you can't really control the answer. You know what the Chevy dealer should have done is the Chevy dealership should have said to Gemini, hey, Gemini, I'm going to build a chat bot, and here's the data I want you to use in answering questions. And maybe the data is a big pile of PDFs about every Chevy that we have, right? So you ask a question, it shouldn't know, it might know what a Ford is, but it shouldn't ever use Ford in the answer because you should control where the data comes from. So hallucinations, mostly it's a piece of confusion around data. If you control the data the model reads and understands and generates from, then you can lessen the likelihood of hallucination. Notice I did not say eliminate hallucination. If you don't, at the bottom of your chatbot say, this is an automated chatbot, sometimes it's going to give you the wrong answer, right? Then you're asking for it. you need that disclaimer because sometimes chatbots can still hallucinate. But if you control the data that they are using to answer questions, you can eliminate a lot of hallucinations. Edge cases. Models tend to be good at stuff that they've read a lot about, just like a person would be. Edge cases is where you've gotten out into some esoteric technology or something, and Gemini doesn't know much about it. You want a good example that's very near and dear to my heart? One of the things I do a lot is I do a lot of agent development with Agent Development Kit. Agent Development Kit is a technology for building agents from Google. It's open source, but it was started by Google. You want to see an edge case with hallucinations all over the place. If I go to Gemini and I ask it to help me write ADK code, it does an absolutely garbage job. Why? ADK came out in April of 2025. Gemini, when it was born, didn't know about ADK. Remember, the Gemini knowledge cutoff was January of 2025. So it knew nothing about it read nothing about Agent Development Kit during its training process. This is also true with ChatGPT and Claude for what it's worth. So it knew nothing about Agent Development Kit. Next, Agent Development Kit, Google is putting a lot of time and effort in. And from last April until now, so in the last 8-9 months, there have been 23 versions of ADK. I swear, 23 versions. So if Gemini wants to find out something about ADK code, what's it going to do? It's going to do a quick Google search. But the chances of it actually finding code that is currently accurate is fairly small, I think. Also, there's just not that many people writing ADK code. It's not as well known as some of these other libraries out here because it's so new. So if I go to Gemini and I start asking it questions on ADK, what I get a lot of hallucinations. In other words, code that's not so good. The reason is because it's an edge case. It's a technology that didn't exist when Gemini was born, and it's difficult for it in a quick Google search to learn everything it needs to know. Now, if I wanted to take Gemini and make it really expert at writing ADK, could I collect a set of documentation and examples and feed it into Gemini? Hey, Gemini, I'm about to ask you some questions on ADK. Here's a bunch of data you should read first. Then I could get Gemini answering questions well, right? Because I have given it a data set that it can learn from. But I would have to do that, right? Because a quick Google search is not going to be good enough. So the real question now, Google, uh, I didn't write this course. If I wrote this class, I think there would be 400 fewer slides. No, I'm just kidding. Um, if I wrote this course, I wouldn't have titled this Techniques to Overcome Limitations. I think what I would have just said is, how do I get a generative model to do what I want? That's it. How do I get a generative model to do what I want? If I'm not going to build my own model, too expensive, probably. If I'm not going to build my own model, then how do I get a generative model to do what I want? And then I would have put 4 things on this slide. 1, prompt engineering. 2, tools. Grounding and RAG, which is a type of grounding, is a type of tools. 3, fine tuning. 4, custom model. That's what I would have put. So how do I get a generative model to do what I want? Prompt engineering. Didn't we talk about prompt engineering a little while ago? And we said it's kind of like how you ask the question sort of thing. Well, yes, part of prompt engineering, the layperson's view of prompt engineering, or to put it another way, when you are going to sit down and have a conversation with Gemini here, yes, prompt engineering is how you have that conversation. How do you ask questions? But in the generative AI application world, prompt engineering is really more about the instructions you give the model before it attempts the task, right? They say here, crafting precise prompts to guide the model towards desired outputs. I would say it's the instructions you give the model before it handles the first question, right? It's the instructions you give the model. I was in Cambridge, Mass, a few months ago, and I was asked to teach a class on generative AI and generative agents to a room full of drug researchers, right? They were all drug researchers. I have never received so many LinkedIn requests from Dr. Somebody, because I swear everybody in the room, there were so many doctors in that room, it wasn't even funny. And I was talking to them, and a lot of them were like medical doctors, but most of them were, they described themselves as wet lab research doctors. And I'm like, what the heck does wet lab mean? And they explained to me, if you're actually in a laboratory, like in the movies, with like beakers and test tube, and you're doing research all day, they call that wet lab research. I'm like, okay, there you go. I learned something new. Anyway, so I wanted an example that was pseudo medical in nature. So I wanted to build an agent that could answer questions on diabetes. I know it doesn't really have anything to drug research, but I thought it was an interesting thing to build. So Gemini and I got together between day 1 and day 2 of my event. I was in a hotel room. The book I was reading was really bad, and I was frustrated with my book. I didn't want to read that stupid book anymore. And I'm like, I'll write it. I'll build an example for my class. Okay, so in my agent, I build a set of instructions for an agent. When I use the word agent, what you have to imagine is, thank you for calling Company X. How may I help you? Oh, you have a question on your bill. Please stand by while we transfer you to a billing agent. I worked as a receptionist one time when I was in high school, and they said, make sure to smile. People can hear the smile through the phone. Anyway, so yeah, there's my receptionist voice. Okay. If I'm going to build an agent that, I transfer you to a billing support agent because they know how to answer billing questions. And a tech support agent would know how to answer tech support questions. And a sales agent would know how to answer sales questions because they've kind of been given extra instructions on doing that. The idea of an agent in generative AI is the same. It knows how to handle some subtask. I can build a generative agent to answer questions on tech support or do sales or billing support or something else. But when you build an agent like that, you give agents instructions that kind of tell them how do they do their job. If a generative model is like a new hire, then if I just hired a new hire and I wanted to give them an employee manual that explained to them how to do their job, what would I put in the employee manual? That's what I'm looking at right here, right? This is like my agent's employee manual where I'm sort of telling it, this is what you can do. Always include this disclaimer. This is an educational tool only. It is not medical advice. Please consult. One of the things this agent can do is it can evaluate your risk for diabetes. It asks you some questions, and it runs a machine learning model to calculate the chances that you have diabetes. But, I don't want people to look at my example and think this is actual medical advice. So I have an instruction in here that says, hey, anytime you're answering a question like that, could you please put a medical disclaimer in there? Yes. So this is all instructions. Just like if I had an employee, how would I give them instructions? And you see, I even start with, general stuff like, here's your personality. This is the way you should sound, right? These are your capabilities. Now, come on, if you get hired into the support department to answer the phone or do chat support, they tell you things to do personality wise. You should sound professional. You should never be combative. It may not be quite as blatant as this, but this is a normal thing I would do with a human too. I would tell them things they should and shouldn't do when handling questions. Well, that's exactly what we're doing here, right? We're doing the same kind of stuff. Anyway, so this is instructions. So when they say prompt engineering, it's to me not just crafting the perfect question. To me, in a lot of more advanced use cases, it's more the instructions I give the model. I'm hiring you to answer billing questions. Here's an instruction manual. I figure if I hired you, you're not an idiot. I figure if I don't show you the instructions and I say, what would you do if someone had a question about their bill last month? You would say things like, well, I would ask them to explain to me more. And then I would pull up their bill from last month and I'd see if I could figure out what the problem was. In other words, you could figure it out. A model can do the same thing. So the instructions are not telling the model everything to do. They're just telling the model specific information, right? Do you want to sound a particular way? Do you want your people in support telling jokes all the time? Or do you want your people in support to sound very professional? Are they casual kind of professional or are they real straight-laced professional? What do you sound like? Are you working for a tech company or are you working for a bank? Your support people at a bank tend to sound different than your support people at a tech company, right? So that's all prompt engineering. It's instructions. Now, in my number 2, I say tools. In the generative AI world, a tool allows a model to interact with the outside world. So when I say a tool, it allows a model to interact with the outside world. In my billing support agent example, if someone says, I got this $25 charge on my bill last month and I don't know what it is, what the tech support rep would need to do is use some tool that allows the rep to pull up the bill from last month. So you can go back and see what they're talking about, right? Well, if I had an agent, that's exactly what I would give my agent. I would give my agent a tool that allowed it to interact with the outside world. In that case, look up billing. Grounding is a general concept where you look the answer up somewhere, right? That's it. Grounding says you have a source of truth, right? You have a source of truth where it looks up answers. You come into me and I'm building a chatbot for Ford or a Chevy. There's not going to be any Ford information in that chatbot because I'm going to ground it in a bunch of information about Chevy. So you come in and you ask me a question about what's the best-selling truck. I'm going to assume that you mean Chevy. And I bet you one of those brochures over there says, new for the 2026 model year, best-selling truck, blah, blah, from Chevy. That's what they would have. And that's the answer I would give. So grounding means you have some source of truth. You have a question on vacation policy. Let me go over here. Over there, I have stored all the all the policy documents. And what I'm going to do is I'm going to go look at your answer up in that policy document over there. Okay, that's grounding. Grounding is a type of tool. RAG is a type of grounding. When you were in 6th grade and your teacher said to you, write me a 5-paragraph paper on the polar bear, and you must have 3 sources. You in that case were the model. You were the reasoning engine. What did you do? Well, you found 3 sources, 2 websites and a book where they talked about the polar bear, and you retrieved from your sources facts about the polar bear. You augmented the paper that you wrote or the paper that you generated using facts about the polar bear from those sources. That's all RAG is. Probably the prime difference between general grounding and RAG is when people talk about RAG, most RAG examples, the way they search is they use a generative AI search rather than a keyword search. The majority of grounding in the world is not generative AI. The majority of the grounding in the world is you have a tech support system or a billing system, and you ask it a question and it does some sort of keyword search and it finds you the answer or something like that. So in grounding, the whole idea of finding a document where the answer is, there's not necessarily anything generative about that. In RAG, however, pretty much every RAG example, the way they search for documents is they use generative AI. And when I say they use generative AI, I mean they search by meaning rather than by keyword. I tell you where I wish I had RAG search right now is in my email. I get a ton of email, and I'll see an email and I'll know what's there. And like a week later, I'm like, I want to go find that email. And I'll go to the search engine. And of course, in a week, I've received, 5,000 emails. So I go to the search engine and I'm trying to find that email. And I know it's there. I remember seeing it. And I can't find it for anything. The reason I can't find it for anything is your email search is a keyword search. You may know the contents of the email and what did it mean and what did it kind of talk about, but you may not be able to remember the exact words in the email, right? If you can't remember enough exact words, you can't find that document because it's a keyword search. In RAG, you could describe the meaning of the content of the email. And instead of searching by words, it'll search by the meaning, right? If you could express sort of what they talked about, RAG could find it. So in other words, you might have a higher fidelity search in RAG than you do grounding. But the reality is RAG is just a type of grounding, and both of them are a type of tool. When I came over here and I turned on access to Google search because I wasn't getting an accurate high temperature today, my model didn't even know what day it was. It was thought it was last spring. You know, I turned on grounding in Google search. And that means anytime I ask a question, it's going to go Google search that. And it's going to use facts it finds in Google search to answer. Okay, grounding in Google search is nice for an example. But in most business applications, I am not grounding in Google search because once again, I can't control that. In most business applications, I want to ground in data that I control, that I can control. I want to collect and curate my policies and put them in a folder and now say, okay, Gemini, anytime someone asks you a question, use these policy documents to answer the question. You come in and you say, tell me about William Faulkner. It's going to say, I'm sorry. In my policy documents I have access to, there's no information on William Faulkner. Okay. So I restrict it to answering questions coming from that grounded source, and I control the grounding source. Yeah. That's what you do with most grounding. Fine tuning, you can't really fine tune Gemini in the truest sense, right? Fine tuning is mostly open models. And fine tuning is sort of you take a general purpose model and you train it on new data. It's a lot like taking your liberal arts degree model and sending it to graduate school. That's kind of what fine tuning is. In fine tuning, you take a general purpose model, something like Gemma, right? It was usually one of the open models like Gemma or Llama or GPT open source. Those are probably the most popular of your big open models. Gemma is the one from Google. You take that model and you can continue the training. And so if I want to take a model and teach emergency medicine, I get my hands on every emergency medicine resource I can find, every textbook on emergency medicine, every article on emergency medicine, and I collect all that data, which is going to take me a while and cost a bit. And then I set up a training job with a bunch of servers, and I say, okay, model, I know you're this general purpose liberal arts grad, but I want you to memorize emergency medicine. It's going to forget some of its liberal arts general purpose training because it's going to learn to be an expert at emergency medicine. It is basically going to memorize a lot of aspects in emergency medicine. And then when I have that model fine-tuned, I could download it out of the cloud and I could try to sell it to some hospital or something. I was at the VA the other day. I go to the VA for a checkup every few months or something. And so I'm at the VA for a checkup, and my doctor is this kind of, he's just, I don't know. If you imagine a VA doctor, he's very good, he's very polite, but he's kind of just this, not excited, he's just kind of monotone. And we're sitting there and I'm sitting, and he's asking me, "So what do you do?" And I'm like, "Oh, I teach classes on Google." "Oh, what about?" "Well, most of it these days is about generative AI." And just straight faced, no emotion. He says, "Oh, I'm currently working on building a generative AI application to try to sell to hospitals to offer medical advice." And I'm like, "No way!" My emotionless VA doc is working on generative AI. Hey, yeah. Anyway, so yes, this is what you do. Why is emergency medicine a good example for fine tuning? Well, hospitals are really worried about, what if the internet goes down? Imagine, I just read an article in China. They're putting cameras in classrooms with school kids, and the cameras are watching the students. So the camera's like over the board, over the teacher's head, watching the students. And what the camera does is it's evaluating, do the students look confused or not? And just before the class ends, the generative AI system prints out a report that says, "Hey, by the way, when you were talking about polynomials, Lee was confused." Right? So it watches the faces of the kids while the teacher is teaching, and then generating a report. What topics confused what children? Which children were really getting which topics? Which is kind of, if you think about it, really creepy and really interesting all at the same time, right? Okay, now imagine you have a surgeon doing surgery, and imagine with that big light over their head, there's a camera watching the surgery. And imagine you've got a chatbot over here or some computer system over here, and it's offering the surgeon advice as they're in the middle of surgery. Now imagine the internet goes down. Okay, you gonna call off surgery because the internet's down? Sorry, we had to stitch you up and call off surgery because my AI assistant was down because the internet was down. Yeah, I don't think that would go over so well. So fine tuning, if I had a model I could download out of the cloud, then I could download it into a server in the hospital, maybe even into a computer right there in the operating suite, right? So as long as we keep the power up on the operating suite, which we will because it's on generator backup, the AI assistant is going to keep working. So there's a lot of interest in fine-tuned models to do very specific tasks in the medical industry, for example. All right, human in the loop. I've mentioned this already. Human in the loop means if you want to make generative AI better, you need people, right? You need people to look at the content that you're working with. If you're building if you're building a grounded source, how are you building that grounded source? I like the word curated. How are you curating that grounded source? Have you ever been to a museum and you're walking around and you're thinking, this is cool looking old stuff, but I have no idea what I'm looking at because the curation is so bad, right? And then you go to, like, I don't know, the British Museum or something. You go to one of these big fancy museums and everything is organized perfectly. And everything has these plaques that clearly, describes exactly what you're seeing. And you're like, I understand now. Well, in generative AI, like grounding, it's the same thing. If you pick a source of truth, is that source of truth actually true? Is it accurate? How about the way it's written? I had a client that I taught them a class on this stuff, and they decided they were going to build a tech support chatbot. And they have this tech support system that's designed for tech support reps. And a lot of it is a tech support rep troubleshot a problem, and they wrote up after the event. They wrote up, what the problem was and how they solved it and everything else. Have you ever read tech support, uh, case files written by tech support reps? I was talking to this crazy guy on the phone and, I don't know what he was looking at. Some of it is not written in, shall we say, the way I want to show other clients, right? So if I ground in that, is this something that the model might quote something out of an article and it would be insulting? I think that's possible. As a matter of fact, that's what this guy had. He said that they had people complain because it was a little insensitive in the way it answered some things. Okay, another problem with that is inside tech support documentation, it'll say things like, at this point, I pulled out tool X and I looked these things up. If I tell the user, yeah, you should check tool X now, What if Tool X is a tech support tool that doesn't exist outside of tech support, right? So just because I have some useful data doesn't mean I can immediately ground. I need people who can look at that content and curate it, right? Um, Pre-generation review, sensitive applications, post-generation review, high-risk decision making. I have to evaluate the heck out of all this stuff. So people are going to need to help with that. You're going to absolutely need that. Which types of foundation models would be most suitable for generating photorealistic images from textual descriptions? Okay, so the one that generated images was the diffusion model, right? Remember, multimodal means it can handle different file types, different image to text. About large language model, generic term for one of these general purpose autonomous reasoning engines that I have a conversation with. Diffusion model, general term for your image creators. Classification model, we haven't even talked about that. But a classification model would be like fraud, not fraud. Are you a small spender, medium spender, large spender, extra large spender? Because if you're an extra large spender, I'm going to advertise to you differently than the small spender. That's a classification model. That's a classic non-generative, non-foundational model. What is the primary role of humans in the loop in machine learning? To replace AI algorithms entirely. Yeah, that's the answer. To integrate human expertise into the ML process, especially for tasks requiring judgment or context, I think we have a winner. Have you ever looked at a picture generated by generative AI and you're like, there's something not quite right about this picture? Look at the hands. Generative AI continues to have problems with hands. Sometimes you'll look at a hand or like the angle of the wrist, and it's something that no human could have, and you're just looking at it and you're like, eh. In the programming world, they'll say something just doesn't pass the sniff test. And that's kind of what you have, right? There's something that's not passing the sniff test with that because the human can tell, right? To automate all decision making, no. To eliminate the need for data collection and model training, no. All right. Humans can help with judgment. Which answer is better? Which techniques can be used to overcome the limitations of foundation model performance? Okay. Increase processing power and faster hardware. I don't think that's the kind of performance they meant. Preventing hallucinations by restricting the AI's models access to external knowledge sources. Okay. First off, I'm suspicious anytime you say preventing hallucinations, like, are you guaranteeing to get rid of them? If someone guarantees you they're going to get rid of hallucinations, they're lying to you, right? You can lessen them, but preventing is a little hard. But also remember, I said one of the ways you lessen the likelihood of hallucination is you give an external data source. This is kind of saying the opposite. So no. How can I overcome limitations? Grounding, prompt engineering, fine-tuning, human in the loop. I think we have a winner. All these are techniques that can get over some of the limitations. So when they're saying performance, I don't think they mean make it faster. I think they mean make it better. Advanced algorithms and data structures, yeah, no. Okay. Good. We are coming into a new section, but also we're coming up on our break time. So I tell you what, why don't we go ahead and let's pause right there. We're going to take another 15-minute break, and then we will pick back up. Once again, you have any questions, comments, please feel free to drop them in the chat window and let me throw up a clock, and I'll see you guys back in 15. That's about it. Okay. So, when you're working with all this data in the AI world, we talked about you gather your data, you prep your data, you train your model, you deploy and predict, you manage your model, gather the data is how am I get it data together and how am I going to do it in a secure kind of way? I got to move data around. I have to access data securely. I have to store data security. So, security becomes a big aspect to this. Access control, security access control. Prep the data. Okay. Do I need to anonymize the data? There's all kinds of interesting AI applications coming out in the medical field, but how do I anonymize data safely? Do I need to pseudonymize it? How do I validate that it's correct? Training the model. Training the model might be a time-consuming process. I don't want it interrupted in between. I want people to monitor it, but I want to make sure the right people have kind of the right level of control, right? Who's going to have access to the model once it's deployed? The model is kind of an artifact that I have to maintain. So who's going to have access to that artifact? How do I manage the model over time? All of these things, there are security components to all of these different steps. How do I guard against like adversarial attacks? How do I guard against people using my model and making me pay for it? Google has a secure AI framework that is a set of standards to help you basically with building AI systems. Safe, security AI framework, technical term, or I guess it's a product name really that you should know. And then, of course, we're building on top of Google Cloud. Google Cloud has huge, massive data centers that they put together. And, these data centers are all over the world and they're kind of built from the ground up to be secure. And we get to take advantage of some of that security. Google has buildings full of people that are working on nothing but generative AI, trying to make sure that nothing but Google Cloud to make sure that it's as secure as possible. Now, responsible AI, like a year and a half ago, my boss calls me up and says, "Hey, we got this new class from Google on responsible AI. Would you like to teach it?" And I thought about that long and I said, "No." Sounds like something I might not agree with everything Google says. And, it might be, controversial. And okay. So my boss says, "Okay, no problem," and leaves. But my boss knows I'm a sucker. So like 2 weeks later, my boss comes back to me and he says, "Nobody wants to teach this responsible AI class. Would you please teach it for us?" And I'm like, "Fine." And I started prepping for this responsible AI class. And it is controversial at parts. I don't agree with every aspect of Google's belief system around what does it mean to be responsible with your AI, right? I don't see completely eye to eye. But the main thing teaching that class did for me is it opened my eyes to a whole category of possible challenges that I just never thought of before, right? Like I said, developer, I see where I am. I see where I want to go over there. I figure out the logically most efficient way to get there, right? And one thing that I didn't necessarily think so much about was what are some of the ethical, responsible, fairness kinds of considerations when you're trying to get from here to there. I just didn't think about a lot of that stuff. There's a lot of core elements to kind of Google's belief system. Transparency is key. Transparency is important in kind of both ends. You see, they have transparency at top, and at the bottom, they have accountability. Accountability and explainability to me is really just a type of transparency. Transparency on one end is if I'm going to collect data from a user, do I tell them what I'm going to use that data for, and do I actually stick to that? Do you understand that there are different requirements around collecting data for adults versus collecting data for teenagers? There's different so transparency is where I'm kind of thinking about, I need this information, but I have to be clear with my user. What am I collecting and how am I going to use it? Right. For example, I told you that the free version of Gemini captures your conversations. That's true. But do you know they redact your PII data? Right. So it is anonymizing the conversation, because Google doesn't want to collect that data. They don't want to have to mess with your personal information. Privacy in the age of AI. Well, yeah, anonymizing or pseudonymizing, your data in a lot of applications. That's what I have to do. I have to use this data, but I don't want the names. I don't want to identify the person who's doing this. Right. Um, I'm working on the lab right now. I'm building a lab right now for Google where we're using Team USA Olympic data. And when Team USA gave me the data at first, they said, here's this data. By the way, you can't use any names. And I started looking at the data, and it's kind of like, if I don't use a name, but I say this person won the Olympic gold for figure skating in the 96 Olympics, how hard is it going to be to figure out? And they're finally like, oh, well, we guess you're right. Maybe using the name is okay, just not like their picture and stuff. It's like, okay. So when you get into things like protecting privacy, you have to kind of think about, what does that really mean? If I have one person who did this thing, it's really tough to anonymize that, right? Unless I stop looking at individual people and I start looking at things like overall trends. So we got to kind of think about, what does this privacy really mean? And is there a chance that our model could inadvertently leak private data? Did any of you read about some of the early models, some of the early generative models where you could trick them into leaking like people's names and addresses and stuff? Yeah, a lot has changed since those days. Data quality, bias, fairness. Yeah, a big part of Google's responsible AI belief system is around this. Am I looking at collecting data? Am I collecting data in an ethical way? Am I ethical in my use of the data? When you look at such massive amounts of data, you can find interesting trends. You can find a lot of facts about people just by looking at things like data around them, right? So are we using this in ways that make us ethically responsible, right? And I didn't say legal compliance, because the laws are behind. The laws are it's going to take a while for the laws to catch up. And then we're going to have good laws and we're going to have bad laws. Have you ever met a politician? My wife loves politics. She does. I'd rather be sitting in the corner reading a book, but my wife loves politics. When we lived in Atlanta, she worked for a politician. I've met lots of politicians. How can I say this politely? Most of the politicians I've interacted with were not very technical. That's a good way of saying it. They were not very technical. So you have these lawyer types who, a lot of them are not technical at all. And they're going to be helping shape laws around generative AI. It's going to be really interesting to see what happens. Do you know, for example, Google's already come out and said, if you generate something with generative AI and someone sues you and says you are violating copyright, Google will take that court case over and fight it for you, because they don't see a way that that's going to be legally possible, that you somehow so directly quote a person, or a paper. So data quality, fairness, bias, this is stuff we have to think about. It's also stuff that Google is thinking a lot about. Accountability and explainability, to me, is another form of transparency. Part of transparency is, am I transparent with you on how I'm going to use the information I'm collecting to you? To me, though, another big part of transparency, am I transparent with you on where this answer came from, right? So if you ask me a question on policy and I say, this is the answer on the question on policy, I honestly don't want to just say, this is the answer. I want to say, this is the answer and this is how I know, right? It's sort of the difference if I turn off grounding. If I turn off grounding and I say, tell me about William Faulkner. If I turn off grounding and I say, tell me about William Faulkner, by turning off grounding, I put the bottle back in its little box. And so anything it's going to tell me about William Faulkner is going to be because during the training process, Gemini read a bunch of stuff about William Faulkner, right? It read, books on him. It read websites on him. It read a bunch of stuff. It read all the Wikipedia website. And so, I have a William Faulkner answer, but Gemini can't tell me where any of this data came from. Just like you couldn't tell me. If I asked you, why do you know that fact? Where did you remember that fact? You probably don't remember exactly why you know the fact. Gemini is the same way. I don't have I don't have a way of saying, yeah, but where did this fact come from? If I ground, when you turn on grounding, one of the whole parts of grounding is I'm not asking the model to make up an answer using its own knowledge. I'm asking a model to go over there and get the answer from over there, right? And if I control what's over there, if I control the pile of policy documents or whatever it's looking at, then I can control where the answer comes from. And so now when it's telling me stuff like The Sound and the Fury is a major work that came out in 1939, and holy cow, I know it because Britannica says it, Wikipedia says it some more, Encyclopedia Virginia says it, PRH says it, so I'm seeing where this answer came from. That is accountability. That is explainability. If you have a model that's deciding whether or not to give someone a loan, could the model tell you, I'm denying this loan application and here's why, right? Just like, where did you get that fact of information? Well, I looked it up in this document over here or this website over there. It's another form of transparency. And yeah, there are already a lot of laws out there around things like non-discrimination, about things like data privacy. There's product liability, but there's also an entire landscape of, the entire landscape around the laws related to generative AI is in flux right now because laws are slow to come about, right? So eventually you're going to see more laws in place than we see now. And some of them are not going to be good laws, and somebody's going to fight that. Anyway, you're developing an AI-powered loan application assessment system. Did I just mention this? Which steps would you take to ensure your system is ethically sound? Select 2. Okay. I guess my brain must remember teaching this or something. Prioritize speed and efficiency over fairness and transparency. I can already tell this is going to be a right answer, right? These factors are more important for business. Okay. Use a complex black box model that makes highly accurate predictions, even if its decision-making process is difficult to understand. In other words, no explainability, no accountability. Regularly audit the model's performance to identify and mitigate any biases that may emerge over time. Oh, okay. What was the question again? Which steps would you take to ensure your system with ethically sound? The reason I did that, by the way, is a lot of times I get into reading and I forget what the question was really asking. Google loves you to do this in the actual exam. Google will make the question. One thing that's unrealistic about all these questions is they're all like 1 or 2 sentences. In the Google exam, a lot of questions are like paragraph length, right? So there's a lot of blah, blah, blah in the paragraph. And then sometimes you have long answers. And it's very easy along the way somewhere to forget what they're actually asking you, right? So every now and then, if you're not at the back of your mind absolutely sure what they're asking you, take a moment to just glance back up. It's usually at the end of the question, what are they really asking you? I want it to be ethically sound. Okay, this sounds pretty good to me, but I'm not going to commit until I read the other answers quite yet. Deploy the model without any human oversight. Trust its ability to make fair and unbiased decisions. What did I say about human oversight? Human oversight frequently is the best way you find certain types of problems. So I think we're down to C&E. Train the model on a data set that includes a diverse range of applicants. Ensure representation across different demographics and socioeconomic backgrounds. Absolutely, right? If you're doing loan applications, yes. Okay. What is the primary goal of the secure AI framework? The name kind of sort of says it. To promote innovation and accelerate AI development without considering security risks. Yeah, I'm sure that's what the secure AI framework does, right? To restrict AI development and deployment due to concerns, it's not really there to restrict either, right? To establish security standards for building and deploying AI responsibly, addressing the unique challenges and threats to the AI landscape. It's vague, but I'm pretty sure that's going to be the right answer. To focus solely on preventing external attacks to the AI system. No, the SAFE is much more about what they're saying here. Security standards. It's about building and deploying AI responsibly. That's exactly what SAFE is about. What is the primary goal? Oh, yeah, we just did that. What is the primary goal of ethical AI development? What is the primary goal of ethical AI development? To comply with all legal and regulatory compliance? No, right? Remember, trying to be ethically responsible does not just mean we're trying to follow the letter of the law. Trying to be ethically responsible, we're trying to do the right thing because it's the right thing. Yes, that's part of it. We're trying to do the right thing because it's the right thing. But it doesn't have to be purely, I don't know, trying to do the right thing. We're also trying to do the right thing because honestly, if we want the broadest audience, if we're trying to reach the most people with whatever we're doing, trying to do the right thing a lot of times allows us to get to the broadest audience, which may make us more money. Also, liability. Laws are going to be shaped over the next decade, and so at some point, is something we do today, could it open us up to liability tomorrow if it's clearly not an ethical thing to do? I say yes, right? So there's a lot of nice thing about being ethically responsible and just being a good moral company. But there's also a lot of nice things around trying to maximize our profits, trying to minimize our liability. Yeah. To maximize AI capabilities regardless of social impact. Yeah, that doesn't sound very ethical. To promote transparency and accountability in AI systems. Okay, I can see that as parts of ethics. Yeah. To ensure AI systems are used responsibly and do not cause harm. Ooh, right. So we have promoting transparency and accountability in AI systems, and we have to ensure AI systems are used responsibly and don't cause harm. Okay, they're being tricky with us. Yeah. What they're saying is, you know, the primary goal of ethical AI development is trying to make sure it's used responsibly and do not cause harm. Do you see that's kind of the broadest definition, I guess? Transparency is kind of a part of that. Accountability may be a part of that, but I think those are kind of details where D is more the big picture, I guess. I don't like that question either. But you know what? I've never taken a Google certification exam where I did not swear. Well, first off, there's always at least one question where I swear none of the answers are the right answer. And there's also always at least one question where I question the author's skill with the English language because I'm pretty sure they don't really know how English works. Okay. So you will see questions that you do not like. You will. I'm not sure if Google does that on purpose or what. Okay. Let's do a couple more questions and then we'll jump to the next chapter. Um, which of the following is a key aspect of securing the model training phase? Okay, so we're securing the training phase. Safeguarding training data and model parameters from unauthorized access, possibly. Optimizing the model for faster processing. Okay, whoa. Which of the following is a key aspect of securing the model, right? So remember back to what I said before. When you're looking at questions, keep it clear in your head what they're really asking you because they'll tell you things that make sense. Well, I want to optimize the model for faster processing. Yeah, I probably do. But does that have anything to do with the question they're asking? And the answer is no. Google will give you lots of times answers that are completely correct and good things to do, but they're not answering the question, right? And Google's hope is you're going to go for that wrong answer, right? Minimizing the amount of training data used. Well, no. We've already said that a lot of times if we're building model, if we're training our own model, typically you have lots of data, right? So there's nothing security wise that says let's minimize the data. It's more about can we protect the model? Ensure the model's output is visually appealing. I would like that in cornflower blue. No. That's nothing to do with what we're doing here. So yeah, the safeguarding training data and model parameters from unauthorized access is the only one that really makes sense. Which of the following is a key aspect of securing the model training phase? Oh, sorry. What is a potential consequence of using inaccurate or incomplete data in training? Um, it screws up the training. Garbage in, garbage out. There's not a problem. I don't really have a problem with you trying to picture in your mind what the answer is, right? When I read a question, I do immediately think, I think this is going to be the right answer. But don't be surprised if that's not one of the answers they give you, right? A lot of times Google gives you answers and you're like, well, that's not what I was thinking. But yeah, sometimes Google is not looking for the obvious answer. Anyway, what is a potential consequence of using inaccurate or incomplete data in AI training? It eliminates the need for fine tuning and further model training. Yeah, no. It results in data storage inefficiency. what does inaccurate data have to do with data storage efficiency or not? It introduces biased outcomes and unfair results. It could. It results in an inefficient user interface. Nothing about the UI. So do you see, just because you have inaccurate data doesn't mean necessarily you're introducing bias, right? Bias is where you have preference over a particular group of people in some way. Bias is my writing example where, as long as it's a kid writing sample, we can do that. Oh, but you're an adult. I don't know how to handle adults. That's a type of bias, right? That's a type of bias. But again, inaccurate or incomplete data, you could just get wrong answers. It might not be bias against a particular person or a type of person or a group of people. It might just be wrong answers, right? So if I used inaccurate data in my writing example, it wouldn't be biased at all. It just might give me garbage answers, right? So just remember that. You see, what I'm thinking is the right answer. Well, if it's inaccurate, incomplete data, then it's going to give me bad answers. That's my thought. I wasn't thinking bias at all. I wasn't thinking fairness at all. But in the answers, the only answer that sort of would be viable, as far as I'm concerned, is answer C. You'll see a lot of that, right? Where, like I said, you picture the answer in your brain. It's not there. Okay. It's not there at all. And even in this case, I'm not sure that bias is what you get, but it's possible. Incomplete data is the exact problem they had with the facial recognition story. It's the exact problem they had with the writing recognition story, right? They didn't have a complete picture of a complete and diverse picture of the people's faces that they wanted to recognize and of the writing samples. So that was bias. But again, that's not my first thought. Last one, we'll go to the next chapter. When is fine-tuning a particularly useful technique for enhancing a foundation model's performance? When the model needs to be connected to a verifiable real-time data sources to prevent hallucinations in its responses. Okay, they're trying to trick you, because what they just described there, that's grounding. Right? That's grounding. But grounding is a different technique than fine-tuning. You remember my page 4, there were 4 possibilities. Prompt engineering, tool usage, fine-tuning, custom model, which I never went and talked about, by the way. So those were kind of my 4 choices. What they're describing is a grounding choice, but that's not necessarily when is fine-tuning useful. Because we need to ground? No. When the primary goal is to quickly guide the model towards desired outputs by crafting precise prompts without altering the model's existing knowledge base. Prompt engineering. That was option 1. No. When prompt engineering alone doesn't achieve the desired output and the model needs to be specialized for specific tasks or output formats using new task-specific data sets, I think that's it. When the model frequently encounters edge cases and needs to be restricted from accessing any external information to avoid errors. Yeah, that's not so much, right? I don't think that's as good an answer as that. When prompt engineering alone doesn't achieve the desired result and the model needs to be specialized for specific tasks or output formats using new task-specific data sets, you want to send the model to graduate school, right? That's fine-tuning. Now, I would have put in the answer somewhere, especially if you want a model that you can then download out of the cloud to run at the edge somewhere. I would think that is a lot of times a component used in fine-tuning, but not strictly. You can fine-tune models for cloud use as well. All right. Good deal. Moving on to module 3. We have just over we have almost 2 hours left, don't we? Okay. Yeah. I'll probably give you guys a break, but let me go a little farther before we take a break. Okay. What we're going to talk a little bit about next is we're going to cover a little bit of the agent stuff that I mentioned before, right? And I kind of gave you the nutshell of an agent. that an agent is designed to handle some task. The tech support agent versus the sales agent kind of idea. Okay. An agent is the most popular type of application to build in the AI world or in the generative AI world today, right? Everybody is interested in creating agents. That's what I was teaching yesterday, teaching a class on agent development kit. Everybody is interested in creating agents these days. Okay. If you're going to build an agentic application, what are some of the biggest moving pieces in an agentic application? That's kind of what this section's about. What are those big moving pieces? Well, first off, you have some sort of user interface, right? If you're going to have an agentic application that you're communicating with, you want to see an agentic application? Agentic application, right? That's an agent. If you want to have an agentic application that you're communicating with, what does the interface look like? Is there a user interface? I was working for a bank not too long ago, and they wanted an agent to help route emails. The bank has one central email address, info@bank.com, let's say. And all the emails come in through info@bank.com, thousands a day. They have 5 major bank departments. Inside each of their 5 major departments, they have people that are trained to answer emails. So the first thing they wanted an agent that could route emails. It reads the incoming email and it figures out what department to send it to. Oh, that's a great generative AI agent use case. It would be really easy to build a model, to build an app and say, here's a brief description of our 5 departments. Could you please read all these emails and tell me which department the email should be routed to? That's an example of an agent, but the agent doesn't necessarily have a user interface, right? You're not interacting with it. A user interface, the application is the front end. It's facing the user, right? What is the user looking at when they do this? If I go to my diabetes demo that I mentioned a little while ago, if I go to my diabetes demo and I go to my Google Cloud demo environment that I set up this morning, and I open up Cloud Shell in Google Cloud. This is a little virtual machine in Google Cloud. So let me open up this little virtual machine in Google Cloud. And I'm going to open this on its own tab in my browser. And then I'm going to say, holy cow, that's small. And I'm going to make that a little bit bigger. There's certain nice things about getting older. There's certain things that are not so nice about getting older, like the fact that I'm wearing glasses right now. Yeah. Anyway, so let me clone this down. And my diabetes demo, I've got some instructions on that Git repo page on how to set it up. So I'm going to set up this diabetes demo. It'll take a few moments here. Let me set up some environmental variables. Let me grab some sample data. This is going to run over to a sample data set of diabetes research data. And it contains 100,000 records. And the 100,000 records are basically some health facts. And then, did this person have diabetes or not? Then I'm going to use BigQuery machine learning to train a diabetes model. If I ask you to supply me with some data, could I tell if you have diabetes or not? Could I predict that? Right? Yeah, I could build a predictor. And that's exactly what it's doing right now. It's using some BigQuery machine learning. BigQuery machine learning is beyond the scope of this class. And it's sort of a pseudo SQL. If you have ever seen or worked with SQL, BigQuery and machine learning is sort of in the SQL family. But this is not standard SQL. Create or replace is standard SQL, right? Select star from is standard SQL. But this create or replace a model named diabetes model, that's a logistic regression model, nothing standard SQL about that. So it trains a machine learning model out here, which will take it a few more seconds probably. And once it's done with that, what I'm going to do is I'm going to ask it to install Agent Development Kit, basically. You can build agents using several technologies. our class is not going to really explore the details of how you build agents, right? Like I said, that's a much more technical content, technical topic. And we're much more concerned in this class with leadership topics. So you're going to know the names of stuff, but some of the details. So this will go ahead and set up agent development kit. That's very strange. He keeps asking me that. So I'm going to let it go out there and set up agent development kit. So it's going to go do its thing. Okay. Now, behind the UI, you know, if you were kind of architecting this or you were diagramming this, your user, your user is sort of looking at this user interface here. That's the user interface. And that's sort of one layer of the application. Behind that layer of the application would be the agent, right? And the agent is it's a service. And the service's job is to communicate with you. In this case, let's say our agent is going to be a chatbot, right? So we're building an application that's a chatbot. Our agent is going to be a chatbot. So you come to the UI and you get this text box. Maybe the UI looks like this. Maybe the UI looks like this. And you're looking at this chatbot here, and you're going to type your question here. You hit enter, and that sends it from the UI to the agent. It sends a message. Agents are services. When I go to the Mexican restaurant, which sounds pretty good, maybe after class is over today, I'll go down to the Mexican restaurant. When I go to the Mexican restaurant and I order fajitas, the waiter at my local Mexican restaurant, he or she writes on a piece of paper a number. Everything on the menu has a number associated with it. Oh, you want fajitas? That's number 42. My kids get number 16, So they write it on a piece of paper. They take the paper into the kitchen. Magic occurs. Another high school job I had was working in a commercial kitchen. Trust me, just be happy eating your food. You don't want to know what happens in the kitchen. So magic occurs, the food comes out, right? Okay, well, in this case, the message isn't numbers written on a piece of paper. In this case, the message would be, what did the user ask? Maybe wrapped up in something like JSON. And the message goes to the agent, and the agent reads it. The agent answers by sending a message back, right? So when I say an agent is a service, or if you're familiar with the term microservice, if the agent's a service or a microservice, that's all it does. The app and the agent are communicating with messages, right? They're sending messages back and forth. The goal of the agent is to handle whatever this question is. If it's a chatbot, at least. The question just came in. What's the policy around vacation days? Okay, well, let me go do a lookup in some grounding source and let me find out the policy around vacation. The platform is kind of where all this is running. I think I said earlier, I might use other models than Gemini. I think Gemini is an outstanding model, but there's other models out there. And sometimes I build agents that are using other models. Okay, so whether my agent uses Gemini or not, I love Google's platform. I think Google has a great platform. Look, I'm not a member of the Google religion. I know Google's a tool. There's certain things I like about Google. There's certain things that I could complain about Google. But one thing I think they get right is I think they have a good platform for running agents, right? So whatever brains you're using, and that's kind of the next piece, right? Whatever the model is in the agent, I like the platform Google has because it's got stuff that helps me build agents fast. The model, of course, is sort of the brains of this operation. It's the autonomous reasoning engine. Back when I was talking in the last chapter, about this, and I said, prompt engineering, that's the instructions you give the agent before you have a task. Tools allows the agent to interact with the outside world. For example, grounding and RAG tools are data lookup tools. You could have tools, though, that allow you to create calendar appointments or send emails or anything else. Fine tuning, we said, was kind of like sending a model to graduate school. Let me take an open model like Gemma and let me set up a tuning job in Google Cloud where I'm going to feed Gemma every medical textbook I could find that talks about emergency medicine. Because I want to build a model that is like the Gemma emergency model. And what I can do with it is I could load it into a server and send it out into Antarctica or some other place that's disconnected from the rest of the world. And I would have a fine-tuned model that wasn't good at anything but emergency medicine. Fine tuning, like I've described it, would cost you thousands to maybe tens of thousands of dollars, right? Depending on what you're doing and the scope and everything else. So fine tuning is typically in kind of the thousands. What I forgot to mention over here on this was, could I build my own custom model from scratch? First off, does the technology exist in kind of an open way? In other words, I know Google is doing this stuff and I know Anthropic is doing this stuff, but could I find out how as a developer to build my own custom model? Absolutely. The knowledge is readily available. You can find lots of examples, you could find starter code, you could absolutely find what it would take to build a custom model. Okay, if we're talking about a good sized generative model, why are more people not building good sized generative models? Because now you're probably in the hundreds of thousands of dollars or maybe the millions of dollars to build a custom model. So when we talk about models in generative applications, mostly we are not talking about building our own model because it's just too cost prohibitive. You would have to have an outstanding need where millions of bucks to build a custom model would make sense. You remember my drug research group I told you I taught? When I taught my drug researchers, I learned a lot about drug research and AI. And one of the things they told me was, um, for every drug that gets past the FDA in the US into, sales, a drug research company spends on average $1.2 billion on failed drugs. Research that never went anywhere, drugs that couldn't pass FDA approval, 1.2 billion. At the same time, the big brains are saying that by 2030, by the end of this decade, at least 50% of all new drugs are going to come from generative AI. Okay. So the entire drug industry right now, where they have lots of money to spend, the entire drug industry right now is trying to figure out how can we get to new drugs faster. And one big area they're looking right now is generative AI. But there's not a lot of generative AI for drug research. So you know what they're really looking at is they're looking at building custom models. Look, if I spent $5 million to build a custom model and it saved me that $1.2 billion on the back end, is it worth it? I think so. So in certain industries, you may see organizations spending big on trying to come up with custom models to do things, right? But while that's an interesting story and all, it doesn't have anything to do with most of us, right? Most of us are not going to ever build our own custom model. It's just too expensive. What we're going to do is we're going to try to get a model to do what we want. We said prompt engineering, we said tools, we said, maybe some fine tuning, probably not custom models. And in this discussion over here, the same thing is true. Because when people ask me to define what an agent is, right? Well, I've kind of told you what an agent is. I guess I don't have a good simple definition of what an agent is. I like the example. An agent is like that customer service agent versus the sales agent. It's a generative AI application that's designed to handle some task. Maybe instead of saying task, how about some subtask? So if I'm looking at handling all the customer service for my organization, I might have different agents that are specialists at different things, right? But if you want to talk about what's inside of an agent, in my brain, an agent is a model. That's the reasoning engine. It's some instructions, which is really prompt engineering. That's really prompt engineering, the instructions on how to do your job, if you will. And then last but not least, we have the model, which is sort of the reasoning engine, right? Sort of the reasoning engine. Okay, so I have the instructions, I have the prompt engineering, I have, I'm sorry, I have the model, and sorry, the tools, access to the outside world. So an agent is really a mix of a model plus some prompt engineering instructions plus some tools, right? That's really what an agent is. So when we're going back to this discussion, the prompt engineering is in the agent. The tools are in the agent. And then instead of probably a fine-tuned model or a custom model, what we have is we have one of the existing models that we use. So I got the front end, that's the user interface. I have the agent, which is sort of the brains of the outfit, or the brains of the outfit. I have the platform, which is kind of where I run it, and then the model is sort of that autonomous reasoning engine. Okay, maybe the model is like the new hire employee, and the agent is actually after they've been through training and they know how to handle a job. Now they're kind of specialized. So that's what we're going to do. We're going to take this general purpose model, just like a general purpose person we've hired, and we're going to give them a set of tools. We're going to give them some instructions that help them do a job. The infrastructure is where the rubber meets the road, right? The infrastructure is those big data centers that Google Cloud has. I don't have to run all this in Google Cloud. There's no reason, and there's going to be agents in your car. There's going to be agents on your television set. That your AI helpers, like I've got this Google appliance on my desktop. They're going to be at some point, they're going to have agentic capabilities. So there's lots of different places I might run my system. Ultimately, though, it's servers, it's CPU, it's memory, it's networking, it's classic IT stuff. And if we're running in Google Cloud, that's where our classic IT stuff is sitting, right? It's Google Cloud IT. Okay. So read the statement below and identify which layer it describes. So remember, our layers are the generative AI app, which is the UI, the agent, which is sort of the AI app that's handling a particular task. It's a service, but it's focused on you give me a question, I can answer it. I got a platform, which is sort of where all this stuff is running and where all of our support services are. We have the model, which is sort of that general purpose reasoning engine we have. And then we have the infrastructure where it all runs. A team of data scientists needs a set of tools to label their training data, experiment with different neural network architectures, and deploy their finalized AI model into production environment. Okay, so wait a minute. A team of data scientists needs a set of tools to label their training data, experiment with different neural network architectures, deploy their finalized AI models into production. Okay, is that the UI app? Is that the agent? Is that something in the platform? Is that the reasoning engine model? Is that part of the infrastructure? I think there's two possible answers. And I think the right one is probably platform, right? So if I need something that can help me with all those things, you remember I said the platform is kind of all the support services that runs all this. Yeah, but I guess we could expand that out and say it can also help us do related tasks. If I need tools to help label training data, if I need something that can help me do different experimentations, and I want to deploy this into production environment, to me, that's all kinds of pieces in the platform. To put it another way, this is all services in Google Cloud that I'm working with. The platform is mostly services in Google Cloud. There's a lot of services in Google Cloud that behind the scenes, obviously, they're all using Google Cloud servers, but we're kind of operating at a higher, more abstract layer, right? Platform. A customer is using a website where they can type in a description of an image they want. The website instantly generates that image for them. All right. So what are they dealing with there? Is that the UI? Is that the agent? What are they dealing with? I think that's the UI they're describing. A website would be a UI versus is it a app that's on a phone? Is it something that doesn't have a UI at all because it does behind the scenes processing? What is it? I think they're describing website. I can imagine I'm coming in here and I'm saying to Gemini, create for me a painting in the style of Monet of containing President Trump driving an old car down a country road with a wire fox terrier in the backseat. So that's what I want. I want a painting in the style of Monet of President Trump driving an old car down a country road with a wire fox terrier. Do you see it suggesting this is my Grammarly, you know, depicting, it says. Okay, whatever. So I hand that in to Gemini. What Gemini pulls out is Nano Banana, because again, Nano Banana is kind of their newer image creator, newer than Imagine that they're talking about in this class. Oh, there we go. Okay. So there's our, do you see a style of Monet? Do you see it looks like an oil painting? It looks like an oil painting. Yeah. So I can see that kind of Monet, except for the whole fact that President Trump's in the middle of it. I love it. January 29th, 2026. Okay. So there we go. Yes, that's an image creator. The thing that's building the image might be the model behind the scenes. But what they're describing is what I just did. I'm interacting with a user interface, right? I'm interacting with this UI right here. And so this is a website where I can type a description. Yeah. So it's really the UI. A company needs to significantly increase the processing power available to train a very large language model. This requires more specialized processors, high-speed data connectors. Where does that junk live at? Well, all that stuff lives way down in the infrastructure. This is part of the server stuff. Google has specialized chips that are designed to help you streamline AI training jobs, right? And they're kind of talking about stuff that lives down there, right? After being trained on millions of lines of code, a system can automatically suggest the next line of code a programmer is likely to write. They're talking about training. It looks like it's specialized for code, so it can auto-suggest like what the programmer. Okay, the minute they say training and stuff like that, it makes me think of model, right? That's stuff you do in the model. I think the next best guess would be agent. But when they're talking about, again, an agent can do this, but when they're talking about the whole, it's after being trained on millions of lines of code, a system can automatically suggest the next, so to me, that's a little more basic than the agent. Okay. That's really the model they're talking about. A software program can monitor a company's social media feeds, identify negative customer sentiment, and automatically draft a response to address the issues. Okay, so now that's a little more than just a model to me, right? Now I think they've moved up to the agent because, remember, the model is kind of the reasoning engine. When I give it instructions, which kind of tell it how to do its task, how to do its job, and I give it tools, which in this case maybe allows it to access those social media feeds. And then I give it a model, which is kind of the reasoning engine behind all this. Those three pieces all work together. To me, that's the agent, right? So it's kind of operating at a higher level. Models can do a lot of stuff basically, but the agent it's an app. It's working at a higher level. Okay, the afternoon's kind of long. So I think what I'd like to do is, why don't we take a 15-minute break? Let's do another break. Take a break. You need some coffee for the last final push through the end here. Go ahead and grab it. So let's do 15 minutes and we will pick back up. Guys, welcome back. I just want you to know that I'm like totally craving fajitas now. It's all your fault. Yep. Okay. So we're going through talking a little bit about generative AI applications and agents, right? And at the top part, we have kind of this user interface. Go to, my demo environment here. I downloaded my diabetes demo, right? So I think it's all set up at this point. So if I go to my diabetes demo and I change into my diabetes demo folder and let me, sorry, I did the wrong thing. Let me do this command right here. And let me activate my environmental variables. And then I start my little app here. And my app comes with a test front end. It comes with a test user interface. Okay. This user interface is not something I would use in production, but it's still a user interface. It's still a application. So it starts the application, and I can go ahead and fire up the application. And this is the application, right? It is a test UI. Nothing super fancy about it, but it allows me to chat. It's based on that same UI I showed you as a demo, where I said, I could come here and type a question and then get an answer out. Yeah. So I can go in and say, I want to test my diabetes agent. And you see, it just sort of gives me a basic chatbot. Hello. And my diabetes agent should say something like, hello, I'm an educational diabetes assistant. How can I help you? Kind of thing. Hello, I'm here to help you understand more about diabetes and assess your risk. Okay, so this is the application. Behind the application, behind the curtain that we don't really see, is the agent. And the agent is a service. And so I'm sending messages back and forth to that agent, right? What can agents do? Well, this agent is designed to help you with diabetes stuff. If I come in here and I say, tell me about William Faulkner. If I say, tell me about William Faulkner, my agent comes back and says, I'm specialized in diabetes education. I can't provide information about William Faulkner. Do you think Gemini knows about William Faulkner? We know Gemini knows about William Faulkner. We already did that, right? Gemini knows about William Faulkner, but I have given my agent some instructions. And my agent instructions are sort of, this is the kind of stuff you can do, and this is the kind of stuff you can't do. So inside my instructions to my agent, I've told it, here's your personality and here's your capabilities, right? You can pull some information out of BigQuery, but you also can, do some research. And the research is all about diabetes. So if I ask a question about William Faulkner, it's not supposed to answer it. If I ask a question about diabetes, I just heard someone talking about type 1.5 diabetes. Is that a real thing? If I come in here and I ask it that, okay, well, that's within its purview. That's something it should be able to handle. Okay. According to my instructions, what it should do is it should use Google search to answer that question, right? It should put together a Google search because in the instructions, I said mandatory usage worlds, always use search for, I've told it, I want it to use Google search to find an answer. So it used Google search and it came back and it says, oh, that's a great question. You're referring to something often called type 1.5 diabetes, which is formerly known as latent autoimmune diabetes in adult. Okay. Type 1.5 diabetes is catchier than that. So I guess I can see why they did that. So I'm looking at my user interface and behind it is the agent, which is sort of who I'm talking to, if you will. Okay. What can agents do? How imaginative are you? Because agents can do all kinds of stuff. An agent is an application that tries to achieve a goal by observing the world and acting upon it using tools it has at its disposal. Once again, in my basic, thought process, I'm thinking about that agent and I'm thinking the agent's a model plus some instructions plus some tools, right? The model being the reasoning engine, the instructions is welcome, new employee. This is the kind of job you should be doing and how I want you to do it. And the tools, well, if I need you to be able to access data, I'm going to give you some tools to let you access data. I have two tools in my agent over here. One tool knows how to do Google searches. The other tool knows how to run SQL queries against BigQuery. One thing generative AI is really good at is writing queries, right? In your diabetes study database or table, how many records are there? So basically I'm saying it's got this diabetes study table in BigQuery and I'm telling it, hey, how many records are in there? And it's going to have to figure that out, which means it really has to go look at that table and figure out from the table how many records are there. Okay. To do that, the easiest way for it to do that is to write SQL. Run a SQL query. Yeah. So do you see? So it called a tool I gave it called get table info. And it did that instead of writing a query. That's another tool. And that return to it how many records it has. Okay. Hey, what's the average BMI for the patients in that table? One of the health factors it tracks is BMI. So what's the average BMI? Well, in order to calculate the average BMI, it needs to put together some select average kind of query. And that's exactly what it does. It puts together a query and it runs, hey, select average BMI. It puts together that query. It gets the results back. And it says, well, the average BMI for the patients in the diabetes raw table is approximately 2732. Do you notice the answer was actually 27.320767? So it's figures that's not really worthwhile to return that. So that's why it's saying approximately, and it's given that. So the tools are what it uses. A tool to get table info, a tool where it can actually write its own SQL and run it, a tool that allows it to do searches in Google search, Yeah. So what can that do? If I have a model that's a reasoning engine, in a lot of ways, like a person's a reasoning engine, and I have instructions where I can kind of tell this new hire person, this is how I want you to do your job. And I can give it some tools that allow it to interact with the outside world like a lot of jobs need. I'm not sure there's a real limit to what we can do with an agent, right? My biggest thing about agents is rubber stamping everything the agent does. I'm not so sure about that. You remember my example of the agent that routes emails? What I didn't tell you behind that is in the various 5 departments, they have an agent that knows how to write email responses. So a message for the bank goes to the bank tech support. Someone has a question about tech support on the banking website. So the routing agent says, this is a question for tech support. And what it really does is it sends it to a tech support agent. And the tech support agent says, let me read the user's question and I'm going to propose an answer back to the user. But the bank doesn't actually send that answer back to the user. Then what happens is the human gets involved. Because remember, human in the loop. A human making the final decision in a lot of this, makes a lot of sense. So what the human gets is the human has a split monitor. And on one side of the monitor, they see the original email from the customer. And on the other side of the monitor, they see the email response that the AI wrote. And now the human reads the AI response and basically says, does this response make sense? Right? Is this a fine response to send them? Should we tweak it in some way? Should we reword it in some way? That's kind of what they're doing. So when you're talking about agents and how they can observe the world and act upon them, yeah, but we still might want to validate some of the stuff that the agent's doing, right? Agents understand and respond to natural language. One of the real strengths of generative AI is I can just freaking talk to it. I was talking to my buddy the other day and he says, yeah, he's got a 30 to 45 minute to work commute each day. And he says sometimes what he does on his commute is he puts Gemini in conversation mode. And he just spends the commute talking to Gemini, having a conversation with Gemini. Like, wow, I don't think I've ever had a conversation along with Gemini, but it's kind of an interesting idea. Um, do remember, Gemini is not really a person, right? Anyway, so understand and respond to natural language. Yes. One of the really cool things is when I'm talking about kind of consuming data and understanding it, I'm talking about a lot of this data is stuff that a human would consume and understand. A lot of this stuff is, can you read this stuff and understand it, right? Yes, that's very novel. That's something that's very new. Chatbots have been around for a long time, right? Chatbots have been around for a long time. I guess I was moving the desk too much. I'm sitting here and something just fell off the desk and I'm kind of fascinated. I don't know what I'm in all these lights. I can't really see outside the lighted area. But anyway, chatbots are not new, but chatbots have never been super good. Thank you for contacting this company. I'm Bob, the automated chatbot. And you're like, oh my gosh, it's the automated chatbot, right? And sometimes they're good for basic stuff. Sometimes generative chatbots are much more capable, right? They're much more natural in the way they talk. They can do a lot more things. Automate complex tasks. I think I already talked about this. If it's a task where the automation is somewhere around read, understand, generate, then yes, routing the emails to the right department is something an agent could do. If you had a folder of applications and you wanted to read the applications looking for fraud, then an agent might be able to help with that, right? Where you're automating that task. Application shows up, let's process the entire application for fraud, right? Personalization. Yeah. Personalization, sometimes they call it hyper personalization. You want to know another thing the bank's doing? They have an agent that sends spam. They don't quite call it the spam agent, but that's what it is to me. You know what the agent does? The agent looks at your bank account. It looks at all the accounts you have at the bank. It looks at how much money you have. It looks at what kind of things you spend money on. It looks at the services you're using at the bank. And its job is to try to figure out some new service that you might be interested in, right? So, based on your spending habits and what you're doing, it might look at you and say, well, based on the amount of money you're playing with, this might not be the most money earning account for you. If you switch your savings account from this account to that account, based on the balance that you tend to keep and all the other things, you would make more money in interest rates on this kind of bank account. You should consider switching. That's personalization. Targeted advertising is going to be a big use case for this personalization. But it's not just going to be that. I imagine we're also going to see things like, can you imagine looking at a website and the menu systems in the website adapt themselves to the way you use them, right? So if you come in and you're always going to this, could the menu like automatically kind of redesign itself because you're more interested in these things rather than those things, right? That's where you're kind of you're sort of personalizing that way. Generative AI is really good at looking for patterns. So if I look at everything I know about you, generative AI can figure out a lot of interesting information about you and about habits you have and things you do. And we can use that for personalization. It also can freak people out. And so this is where privacy becomes a concern in this kind of information as well. If I'm really letting a automated system read everything about a person's financial history, are we really sure that it can't do something untoward with all that information and all that access, right? Travel booking app. Have you ever used a travel agent? If I was thinking about a travel agent, I can imagine, first off, what are major like different tasks at a travel agent? When I'm thinking about a travel agent, I can imagine having a dreamer agent. And the dreamer agent helps you plan your vacation. Oh, you're taking a trip. Is this for personal? Is it you going on vacation or is this for work? Oh, it's vacation. What kind of things do you like to do? Do you like to walk on the beach? All that gritty sand. Do you want to hike in the woods? Do you want to go to museums? Do you want to see foreign cities? What do you want to, oh, you want to go to Disney World. Okay. You want to go to Disney World. Can you imagine having one agent that just kind of helps you plan and think about things? And by the way, my brother's wife is a travel agent. And, travel agents also like are running deals or running specials or running, where they're being incentivized to send you on this kind of trip. So maybe when the dreamer is helping you dream, are they slanting you towards this trip that, there's a special deal on? Maybe so. So I can imagine having one agent that's really good at helping you sort of dream and plan ideas. The moment you say, I want to go to Disney World, now there's a lot of mechanical steps to that, right? Okay, so what are you going to need? Do you need flights? Do you need a rental car? Do you need a hotel? You can stay on property. You can stay out at one of the hotels near Disney World. Are you planning on maybe going to Universal Studios while you're in Orlando? So I can imagine one agent that is kind of like once the dreamer has narrowed down the rough outline of your trip, let's talk details. Let's book flights. Let's figure out the seats you're sitting in. Let's book cars and the kind of car you want. I could see a totally different agent doing that. Now, the user doesn't see this. It's not like the first agent says, oh, please stand by while I transfer you to the agent that's going to help you with the details. No. This is all invisible to the user, right? So, in my story, do I have a dreamer agent and then behind the dreamer agent, or do I have kind of an intro agent? How can I help you today? And then, do I have the dreamer agent back here? And do I have the, booking agent here? And then also another thing people contract travel agencies for is if there's an emergency. If you've decided to go to Disney World in August, okay, first off, it's miserable at Disney World in August because it's so freaking hot and so freaking humid, right? So it's a miserable time to go. But another thing about August at Disney World is you are peak hurricane season, right? The worst hurricanes tend to come in August, right? So if a hurricane is coming and you're at Disney World and you want out of Disney World, do you have like an emergency contact? So maybe do we have an agent that's sort of the emergency agent? Or, you have some sort of problem during the trip. So, I can imagine that. The dreamer agent helping you kind of plan, the booker agent that really helps you with the details. Oh, you need tickets for Disney World, and then maybe have some sort of emergency agent that if there's an interruption of your trip or something like that, is there. So when you're thinking of agents are kind of like microservices. If you've ever worked with someone who is designing something or you yourself have designed something, and you start with kind of this big goal, and then you sort of logically decompose the big goal into this major step, this major step, this major step. That's kind of what we're doing here. We're thinking about this large problem. And I don't want the agent to rule the world. I don't want one agent that does everything. It's too hard to write the instructions. The agent can get confused if it's trying to do too many things at once, right? So if I keep it kind of straight, that's more or less the receptionist agent. And the receptionist, or I think of it as the triage agent, it's trying to figure out what the user really wants and what sub agent can get the job done. And then the sub agents can kind of work together, right? So I can bounce back and forth. When the dreamer is done, maybe I bounce you back to the root agent here, the triage agent, and it's like, oh, the next thing we should do is help you book your travel. And again, it sends you to the booker, and the booker helps you with all those details. So what you do is you have these agents that are kind of working together on a team. It's too hard to get one agent to do everything. So let me subdivide that work into smaller units. How small and exactly how do we subdivide? And could I really get this all done with a single agent? I mean, in a travel office, isn't there like one human that does all this? First off, humans are more capable than AI agents. Secondly, maybe I might be able to get all this done with one agent, but just my cursory thought is I'm kind of seeing some logical subunits of work. And honestly, it's a lot easier sometimes to build an agent that sort of knows how to handle this major subtask than the agent that knows how to handle everything. The customer support app. Okay, well, yeah. Any kind of customer facing support stuff, if you want an automated chatbot, you should be thinking about using generative AI because, as I've said, generative AI does that stuff so well because it's so good at communicating. Gemini is so nice to talk to, because it really does a good job with that communication stuff. And if Gemini annoys you because there's personality traits you don't like you can't be so happy all the time, you can actually tell Gemini to stop that. I have a buddy that, every time he comes into Gemini, he's like, I want you to remove all emotion from your responses. I want answers concise and straightforward with no emotion. Okay, well, if that's what you want, you can do that, right? Personalized learning app. This is my Chinese look over the shoulder at the students app, right? Where literally I'm building an AI system that's going to watch people and watch their facial expressions. Because as an instructor, I can tell you, the one thing I hate about me being here in my house teaching this class to you is if we were all in a big conference center together and I could see all your faces, if I said something and like half the audience doesn't understand what I said, I can tell that as an instructor because I've taught for a long time, so having a learning app that could help me with that. Yeah, maybe someday I'll have cameras watching you all remotely. Of course, then maybe I get a report, by the way, this student was actually trying to answer email the entire time. No, I'm just kidding. To personalized learning app, yeah, learning where maybe assessing student weak points and trying to make suggestions. I could see a lot of interesting use cases around that. How do agents work? Well, you kind of have the workhorse conversational agent, and then you sort of have the workflow agents that sort of put it together, right? Conversational agents is most of what we're talking about. And when you think of an agent, it's really a conversational agent that you're thinking about. These are the agents that can talk to you. These are the agents that can be conversational with you, right? That's your main workout. That's your main workhorse. I'm looking for an example I did the other day. I don't see it. Okay, hang on a second. Let me grab it. So I was teaching a class yesterday where I was working with my students. And teaching them how to build agents using Agent Development Kit. And in one of the labs that they do in that class, they have a multi-agent system that looks like this. They have a multi-agent system that looks like this. God. Okay. So the user comes in, and this multi-agent system is designed to help write screenplay proposals. Okay. So the user comes in, and this first agent here is what we were just talking about. It's a conversational agent. Actually, most of the meat and potatoes agents in these guys are all conversational agents that are accomplishing these tasks. Okay. So a conversational agent pops up and says, welcome to the historical person screenplay writer. What historical person would you like to write a screenplay on? And you come in and you say, I think a movie on Nikola Tesla might be interesting. So I type in Nikola Tesla. Then what happens is I have some workflow agents, right? Workflow agents are designed to basically put other agents together to accomplish some sort of task. And when they say workflow agents, have you ever done like a flow chart or a mind map or something like that? That's kind of what your workflow agents do. So your workflow agents can do stuff like sequential agent. Step 1, do this. Step 2, do that. Step 3, do this. So a sequential agent knows how to put other agents together in a you first, you next, you third. And then you can have workflow agents like loop agents. Research the person, write a screenplay, critique the screenplay. And I have this loop here where I'm in a loop where my screenwriter writes a draft and the critic is evaluating the draft for quality. And the critic says, I like your movie proposal here, but here's some things you could do to make it better. And it passes the critique back to the screenwriter, and the screenwriter says, oh, you think I could make this better by making these changes? Let me make those changes. And it makes those changes and it continues that loop. And as you're looping through, so write, critique, improve, critique, improve, critique. At some point, the critic says, that looks pretty good. And we get out of the loop. Parallel agent. You remember my story earlier where I did things 500 at a time so I could get them done faster? Anytime you do things in sequence, you have to do them in this order, right? What if you can do multiple things in parallel so it takes less time? So the screenplay comes out. So you got the screenplay, this draft. This draft comes out because the critic thinks it's good enough. And then I have two things that happen in parallel. I've got a researcher that researches box office potential. Can we sell this movie? And at the same time, I got a casting agent that decides who should we cast in this movie. Once those two things are done, we finally go to the last step in our 1, 2, 3 sequence, which is generate the output. And the report writer here, it takes the draft, it puts it together with the box office research, and it puts it together with the casting advice, and it writes out a file, which is your finished screenplay proposal. That's what this does. So this is not a chat bot. This is handling a complex task. I say, I want you to write a screenplay on this person, and it goes to town, right? So in reality, when you think about how agents work, the things that are doing most of the work, the researcher, the critic, the screenwriter, the box office researcher, the casting agent, the file writer, they are all conversational agents. They are handling some autonomous task that I'm giving them. The workflow agents are mostly just putting the thing together, right? I have these different patterns that allow me to create and handle a complex task. Okay. Good. Now, what are your use cases? Well, like I said, I think our goal here is to get us all thinking about this because all this is so new. And leaders like you guys are a lot of times going to have to work with geeks like me to help us come up with use cases. Because a lot of times the leaders understand the business needs better than the geeks do, right? That's not always true. Some geeks are very business oriented as well. It's just like some business oriented people are very technical as well. But in general, my business people, my managers, my leaders, they tend to have a clearer picture of what are our business needs, right? So really, the leaders should be trying to come up with these use cases. We have a lot of low-level use cases where, how am I going to make my employees more productive? But the leaders are going to have to think about that bigger picture, right? And another side of this, it's not only going to be what agents do we need, but another side of this is going to be what agents do we need to build ourselves versus what agents can we basically just buy. I'm buying Gemini here, right? So this is an agent that Google sells me, but it's a very general purpose agent and, it can help me in lots of general ways. That's absolutely very useful. But at what point do I need to maybe think about, are there ways we can build our own agents? And before we do that, honestly, we really need to look at what all different ways does Google have to help us build agents? Because there is a proliferation these days of tools that are agent-based to help you do different things. And, Google is obviously a big player in that market, but not the only player in that market. So customer service agents, yeah. Any kind of chat bot, any kind of IVR voice bot, all that kind of stuff. Yes, 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 yes. Agents for some sort of customer service communication thing, it's a strength. We can drastically improve the quality of our support bots using generative AI. And that might help us lighten some of the load on our human support agents out there, right? Speaking of our human support agents, though, employee productivity agents. Um, if I have a person who is, answering questions, or if I have a person who has to do LinkedIn posts, or if I have a person who has to create job posts or whatever else, can I help workers? Can I help them by giving them research partners? Can I help them by giving them creative partners that are going to help them create things? And I think the answer is yes, yes, yes to all this stuff, right? And as I said, though, at some point we're going to have to say, is this what we're talking about? Or is there some other product from Google that we could use? Or are we going to have to build it ourselves? Right. So that's coming up with agent use cases is part of it. And I think it's kind of one of those once the light bulb goes on, where you really kind of get what I mean by read, understand, generate. Once that light bulb goes on, you can start looking around at different jobs and you can clearly see different things, certain types of agents or certain ways that generative AI can help people do their jobs, right? Code agents, that's a big one, right? The sexy term you're hearing these days is vibe coding. That's the class I was teaching yesterday, right? Vibe coding is basically code agents. I worked at a place one time where they did what they called paired programming. And in paired programming, they would have two developers on one machine. So you'd have two people like sitting right here, and you're both sharing the keyboard and sharing the mouse. And it's kind of like, well, one of you is working, the other one is like critiquing and commenting, and then maybe, well, fine, you do it, and now the other one works, and you've switched roles. That's kind of the coding agents. So I'm a developer and I have these software development tools. And as I'm there writing code, I have an agent that's watching me write code and it's making suggestions. And I also have a chat bot over here where I can ask it questions and it can create things for me. That's vibe coding. You, in all of these use cases, by the way, you need to always maintain that kind of boss position. You are the ideas person. You are the intuitive genius person. You are the true creative here. But the generative AI is your grunt worker and it's taking care of these details. Data agents, agents that help you analyze large data sets. Did I say my agent over here can write its own SQL? I can't express to you how possibly useful that is, right? I remember one time I was on a sales call and I'm kind of when I'm on sales calls at ROI training where I work, we're like Google's biggest training partner. And we have these salespeople that are really good at sales, right? But they're not always the most technical people, right? So a lot of times they'll have someone like me or like Paul on the phone with them, and we're there to help answer the kind of technical questions. So I remember being on the sales call, and the client says, "We want a class on writing SQL." I'm like, "Oh, yeah, great." And so, the salesperson hands it over to me and I'm like, "Oh, okay. You want a class on SQL? Where are you going to run your SQL?" "We're running our SQL in BigQuery." I'm like, "Oh, of course, that's a great place to run SQL. And as a matter of fact, we have a class that'll teach you to write SQL for BigQuery." And then I asked, "Can you tell me about the students who are going to be attending this event?" And the guy says, "They're managers." And I'm like, what kind of managers? Like technical managers? And I still remember the guy says, "No, mostly they're just, managers." This is what the guy says to me. And I'm like, you know, I didn't say, "Why me, God," out loud. I thought it, but I didn't say that, right? What I said was, you know, a lot of managers are not going to want to learn to write SQL because it is a scripting language. And there's a reason they are not already developers, right? It's scripting language. I don't think a lot of your managers, why do you want me to teach your managers to write SQL? And he says, "Well, our data analytics team is backed up. They're the people that write the SQL, right? But the managers are frustrated because they have questions. They have important business decisions to make, and they can't get the data they need for the decision. Because if they can't write the SQL themselves, they're at the mercy of waiting on the business analytics department, right?" Okay, hire more business analysts. There's lots of ways you can handle that. Well, these days, another way you could handle it is, could you give them an agent that actually writes the SQL for them? If the agent knows how to write SQL, and if the agent really understands all the data you have access to, if the manager can describe what they need, could the agent write and execute the SQL to get that data for the manager? And not only that, but I can build agents that write code. I can build agents that write their own code to do things like visualization. So I could run a query and get you some data. And if you said, could you visualize that for me as a bar chart or something? I could have my agent write some code to visualize that and show you the bar chart, So data and data analytics agents, you know, Gemini itself may not be the best tool to look at a database and give you answers, right? But what Gemini can do is it can help you with the more traditional data analytics stuff. You don't look at a big table to make decisions a lot of times. You run a query and you look at a sub piece of data and maybe you do some visualizations to make. I can build a data agent that can do that. Absolutely. Right. As a matter of fact, in BigQuery just recently, they've got this button that's shown up. I don't know when it showed up, but I noticed it yesterday. And it says something like start a conversation. Talk to your data is what it says. So Google is literally building a data agent for BigQuery to help you do exactly that. But there's no reason why you couldn't build your own agent if you weren't using BigQuery. And of course, as code gets easier to create with things like vibe coding, you don't think hackers don't know that? You don't think hackers are trying to come up with use cases for using generative AI to be a better hacker? And at the same time, of course, as the hackers build better tools, the security experts build better mousetraps, if you will, right? So your security agents, they there's a lot of security agents already showing up in Google Cloud to do things like, can we analyze the network flow to look for maybe weird things happening on the network that shouldn't be there? Can we analyze all these massive big log files out here looking for things that might illustrate somebody doing something untoward? Yeah. So, lots and lots of agent use cases, right? And as I said throughout all of this, what do we build? What do we buy? Because a lot of this stuff, honestly, here is buy stuff, right? A lot of this stuff may already exist. Maybe not the customer service agents. That may be more build it. But a lot of productivity agents, a lot of creative agents, there's agents built into Photoshop, there's agents built, you're seeing more and more generative AI built into tools that you might use every day. So that's going to be a question as we go. Is this something that's actually just built in a tool that we can get? Or is this something we really need to build ourselves? The reasoning loop is the instructions basically we give our agent, right? So when we have an agent, the agent is that new hire employee, really excited, happy to be here, lots of general knowledge, no idea how to do a real job, right? That's your model. So I need to take that agent and I won't say no idea. Gemini probably has read books on doing different kinds of jobs. So Gemini starts probably at a better position than a typical college grad does. But still, there's things that we need to tell Gemini about doing jobs in our organization. And a lot of times that's the reasoning loop, right? The reasoning loop often utilizes advanced prompt engineering frameworks to guide its decision-making process. So what they're saying is when we write instructions to give our agent, the instructions, sometimes they call this a reasoning loop because it kind of describes what's the logical process that you're going to go through, right? So you'll hear that. That's that new hire manual. Now, when you want to look at instructions, there are some techniques we can use to help with our instructions. Writing really powerful prompts is an art and a science. The science part says, I can teach anybody to write better prompts. The art part says, some people are just going to be more natural. It's going to click for them. If you are doing a lot of prompt work, you should try to identify the people who seem to just nail the prompt every time, because there's going to be an art to it. Some people are just going to be really good at writing prompts, right? And you want to kind of identify those people. But at the same time, you should strive to make yourself better, right? Because everybody can get better at prompting. And a lot of it is just proactive work at it. You try a prompt, you don't quite get the results you want, and you don't throw your hands up. You don't say generative AI is no good. You figure out, is there a way I could have asked a better question? What could I have done different to get better results? What is the primary purpose of a generative AI agent? Okay. To exclusively generate creative content like text and images. I'm uncomfortable with the word exclusively once again. All right. Now, they really do this sometimes on actual test questions, by the way. To achieve a specific goal by observing its environment, reasoning and acting upon it using available tools. I think that's it, because isn't that pretty much the definition we saw in the course? Okay. And again, remember how human like this is. It wasn't long after I was starting to get into generative AI that I was asked to lead an event for a group of writers on using generative AI. Um, one of my hobbies is writing fiction. Um, I don't do it so much. I haven't done it so much lately. I've been too busy. But in the days when I used to travel all the time, sometimes I'd be stuck in my hotel. I'd write a story or something like that. So I belong to some writers groups. And let me tell you something about writers. Writers are generally not left brain logic types. They're generally right brain creative types. Okay. So they know I'm a rare occurrence, that I'm more a left brain person. So they know I deal with technology well. They also know I do training, right? So every now and then they'll come to me and they'll say, could you make up a class on some technical topic, right? Well, sure enough, they approached me. They said, could you help us create a class on, generative AI for writers? And I'm like, oh my gosh, how am I gonna explain the generative AI to writers? Honestly, at the time, I kind of barely understood it myself. And now I'm gonna have to explain this to writers. And it was really at that time where I started thinking of that kind of person analogy, where, what I told my writers is, imagine you have a writer assistant who is there on the other side of the chat window. They're there 24 hours a day, 7 days a week. Anytime you want to go to them, they are happy to help you write. You know, what kind of things would you get a writer's assistant to help you do? Do you want to bounce story ideas off them and see what they think of your story ideas? Are you an outliner? In the writing world, they talk about people who plan and people who write by the seat of their pants. They call them planners and pantsters, is what they call them. Planners are the people who write an outline and then they write an outline. And then you have people like Stephen King who think that's insane, and they are pantsters. They just start writing a story and they write until they're done, kind of thing, with no starter plan. Okay, if you're a planner, would you like help outlining? So again, when you're looking at generative AI and you're asking what an agent can do, it can achieve a goal. It can achieve a goal, right? But instead of just achieving a goal like predicting fraud, it can achieve a goal in a more human kind of way, right? The human can kind of look around at what's happening. They can sort of reason through what are the steps it's going to take to accomplish this task. And then they can kind of act upon that. And throughout all of this, they can use tools to collect data from the outside world, right? We do this all the time. We need to make a business decision, business intelligence, right? I need data that helps me make an intelligent business decision. Well, generative AI can access data through tools to help it out as well. Yeah. But again, when they talk about agents, again, remember it's much more autonomous in nature than traditional computer programming, right? It's much more autonomous in nature than a lot of things we're used to. It's much more like I've hired this person and given them this task to accomplish. To function only as a platform for building other AI models, no, it's not just about building other AI models. To passively provide information without any ability to take actions or use tools. Most agents have tools. They might be lookup only tools, but most agents have tools. Yeah, B. What is the relationship between generative AI agents and generative AI powered applications? Agents are intelligent components that function within a larger generative AI powered application, which provides the user interface and overall goals. Yeah, I think that's right. Right. So back to remember our multiple layers, if we go back to our multiple layers, at the very beginning of this discussion, you know, they're talking about this stuff. And so when they're saying the generative AI application, that's kind of the big picture. Is the application as a whole. And most applications, or a lot of applications, are going to have a UI versus the agent that's kind of like the person behind the UI. You're on one end of the chat bot, and on the other end of your chat bot, you have an agent that's maybe helping you answer certain kinds of questions, right? Okay. Oops. Looks like I went a little too far. Okay. So I think that first answer is probably right. Gen AI agents are standalone entities that operate independently of any application. No. Because again, remember the agent a lot of times is a faceless service. You send it messages and it does something for you, right? But without some way of accessing the outside world, the agent's off locked in a box and it's not very useful. Generative AI powered applications are simply another name for agents. The terms are interchangeable. Not in this course, they're not. And I think it makes sense. Having an application is bigger than just an agent, right? The application may not have a UI. The application might be my route the email and compose a possible answer. That might be the application, right? Where there's not really a UI until you get to the very end and the humans picking, is this a right answer or not? But still, the application's bigger. The agent is a part of the app. The generative AI agents define the user interface and overall goals. Definitely not, right? The agent is not the UI. The agent is more the person on the other side of the UI chatting with you. A company is looking to implement a system where AI guides new customers through the account setup process, provides interactive tutorials, and answers their initial frequently asked questions. Which category of generative AI agent is best suited for this customer onboarding task? A conversational agent strictly limiting to providing factual answers like the capital of a country. Um, I'm not thinking. Um, a creative agent specializing in generated novel content like marketing slogans. That doesn't sound like what they need. A security agent focused on parsing logs and identifying abnormalities. I don't think so. I think it's probably going to be workflow agent, right? Because what they're kind of saying is there's sort of a workflow. Thank you for signing up with so and so. Here's the first thing we're going to do. Let me have an agent that helps you with that. And here's the next thing we're going to do. Let me have an agent that helps you with that. That's kind of workflow, right? Where I'm assembling kind of a workflow with logical steps in the workflow. What two key elements distinguish AI agents from standalone large language models and empower them to tackle complex problems and manage multi step tasks? So, again, we're basically saying we got the model in one hand and we have the agent in the other. If you had to tell someone what's the difference between a model and an agent, can you answer the question? Right. And again, to me, the model is that new hire human that is generally capable but doesn't know how to do this job. And when I hand the new hire human the employee manual, welcome to the sales department. This is how we think Ford. This is how we like to sell vehicles at Ford. So I hand you the employee manual. I figure if I hired you, you know how to sell cars. If I go to a generative agent and say, could you tell me the steps of selling a car? Do you think it could tell me? Yeah, I think it could tell me. That's the model, right? But when I hand it the employee manual, this is how we sell cars at Ford. And I handed the tools. And by the way, here's tools that allow you to look up any fact you want about any Ford vehicle. This is a tool you can use for ordering Ford vehicles. And this is a tool you can use for helping you with car loans. Again, that's what we've done. So the model is kind of that. I don't know if shapeless, formless human is quite right, but the model is kind of that general reasoning capability with some basic knowledge. And well, actually a lot of the core knowledge that I want to get to do a job for me. So what two key elements distinguish agents from standalone large language models and empower them to tackle complex tasks? The ability to understand natural language and generate personalized response, maybe. The reasoning loop and the ability to use tools. Oh, okay. I think that's probably better because remember, understanding natural language and generating responses, that's a model, right? A model can do that. The reasoning loop and the ability to use tools, that's something a model by itself doesn't have. But okay. The option to be pre-built or custom created and the capacity to operate within a user-facing layer. Lots of words, but I'm not sure that that's really helping us. The use of advanced prompt engineering frameworks and the ability to process information. I think back to my three pieces. An agent has a model, it has the instructions, which are also called the reasoning loop, and it has the tools that allows it to interact with the outside world. The ability to understand natural language and generate personalized responses, that's just a model. right? That's not a difference. The option to be pre-built or custom created, what? I'm not really sure what they're saying there. The use of advanced prompt engineering frameworks and the ability to process information. Okay. Advanced prompt engineering frameworks, that might be part of the instructions and the ability to process. But again, I can use advanced frameworks and processing information with any model, right? It's not really differentiating the two. Okay. You take a model, you add in a reasoning loop, you add in the ability to use tools, and now you have an agent. Okay. Platform models infrastructure. Um, when I first came across this course, I was one of the first instructors to teach this class. And I remember Google had just written this class and they signed me up to teach it. And I was teaching it on like Thursday, Friday, like this. And I swear on Monday, I went and took the exam, right? I went to the exam just before I taught it the first time. And I remember when I went through this course materials and I got to this part, the thing that confused me most in this stack here was platform. Right. I totally got the UI application. I know the agent. I know the model in the agent. Infrastructure is infrastructure. But I wasn't really sure what Google meant by platform. Right. And that kind of confused me a little bit. The platform layer provides the foundation for building and scaling your AI initiatives. Okay. So, in other words, what I finally figured out that they were saying is what services could you use in Google Cloud to help with the above? Right. So when they say building and scaling your AI initiatives, that's what I mean by the above. What kind of stuff would help you do that? The infrastructure is servers. Would a server help me do this? Well, server is just raw power. A server is raw power. I got raw data storage. So yeah, I need raw power. I need CPU memory, networking. I need servers, but I can put servers over in the corner of my room and have servers, right? That's different than using Google Cloud, however, because when I go to Google Cloud and I pull up, the product list in Google Cloud, well, Google has database tools. Might you need to store data related to a generative application? I think so. They have all kinds of AI tools to help me do all kinds of stuff in AI. They have tools to help me with application development. They have tools to help me with observability and monitoring. They have stuff to help me with security. They have stuff to help me with hosting applications. So data analytics and pipelines. So when they talk about the platform, especially as they're differentiating the platform from uh, when they're differentiating the platform from the infrastructure, it's all the services that Google Cloud has to help you do this stuff. Do you need help storing data? Do you need help analyzing the data? Do you need help manipulating the data? How about your agent? Would you like a nice place to run your agent? Does your agent need services to keep track of conversations and run code? And that's kind of what Google is doing. Google, when they're saying platform here, it's sort of all the support stuff in Google Cloud. Anything kind of above and fancier than, "Ugh, I have a server," that's sort of the platform to me. Vertex AI, the deal with this class is they only want to get into the weeds with you guys only so deep, right? So they're sort of simplifying the platform and they're saying, well, you got all this stuff in Vertex, is kind of what they're saying. You have all this stuff in Vertex. And really, if it's anything AI related, like you want to find a model to do something, or you want to build your own model, or you want help. Well, Vertex is open and flexible and it's powerful and it's got pre-trained models in there and it's got all kinds of tooling to help you out with anything that's related to AI. And you can do customization and you can easily integrate it into kind of your AI workflow. And it helps a lot specifically with ML ops. ML ops is a child of DevOps. If you've worked with any developers, you know, and you're familiar with the concept of DevOps, you know, ML ops is kind of a child of DevOps. What is DevOps? Well, part of DevOps is make your developers and your operation people work together, because developers want to change stuff and operations people never want to change anything. So let's make them work together so we can get stuff done. Another big part of DevOps is automation to help you do certain things. I want to automate, like if I want to change code, I want to automate the way the code change is implemented in production, right? Because automation avoids mistakes. Okay, so can we take what we know from DevOps? And in DevOps, you might have heard of things like continuous integration, continuous delivery. Can we take all the stuff we know about DevOps and could we continuous integration, continuous training, continuous delivery, could we come up with some automation around what would it take to keep models up to date? If you build a model today, at some point that model is not going to be giving you as good quality as it originally did. Why? Stuff changes, right? Come on, credit card fraud. 5 years ago, I wasn't charging my charges using my watch. Today I'm charging with my watch or my phone, or I'm tapping my credit card. There's different fraud around things like tap than there is around things like you have a credit card in your pocket, right? So if credit card fraud is changing and I have a model that does credit card fraud prediction, at some point, does that mean I need to retrain the model? Continuous integration, continuous training. Continuous is sort of a misnomer. I'm not doing this continuously, but what I'm doing is anytime I need to make a change, I have automation that helps me automate this, right? So ML ops is sort of like, if I have the end-to-end workflow, I need to get some data. I need to put the data in the right format. I need to train a model. I need to evaluate the model. I need to push the model into production. And oh, wait a minute, I need to do all that again. That's sort of what ML ops is, right? So when I want to add automation around getting the data in the right format for features, running experimentation, because sometimes different settings will yield different quality results. Managing models over time and being able to iterate and come out with a new version of a model when I need to. Track what's happening in all of my ML system. Monitor and evaluate model quality. Automation. This is sort of ML ops. And this is stuff that Vertex AI helps with. But honestly, Vertex AI is a drop in the platform bucket. Okay, because there's so many other products out there like Agent Engine or something that helps us do different things that are related to building agentic applications in Google Cloud. In Vertex AI, if I'm in Vertex AI and I'm looking kind of down the left-hand side of Vertex AI at all the stuff they have, and they're right here, they're mentioning things like feature store. Feature store and data sets are places I can store data to use for training. Feature store helps with, like, I have a table of data and I want to do some feature engineering. How am I going to convert these columns into data types that make sense? You remember my diabetes example? In my diabetes example, one of the columns is smoking history. And the smoking history column is like categories. Never smoked, no information on smoking history, used to smoke but doesn't smoke anymore, currently smokes. So there's like these different categories as words, those words I just said. So feature store would help you with things like, how are you going to convert those categories into something we could do math on, right? So that's sort of feature store. Share, serve, and reuse features, the columns of data, the inputs that we need. If I do a bunch of feature engineering and I work for a particular company, if we work for the same company, you and I, well, it might be that you want to do some AI work with the same data, right? So if I've done all this time and work and effort to feature engineer, shouldn't you be able to just pick that up and benefit from it? Because we all work for the same company. Feature store. Model registry is a little farther down. Once I train a model, the model registry is basically where models go to live. So if I've trained a model, I store it in the model registry, and it can also do things like model versions. So, as I evolve my model, maybe I want to keep the old versions around because I got some code still using it, and then I'm slowly transitioning people over the new version. Can I keep that all in one place? And model evaluation, a lot of that goes back to stuff in monitoring, but also stuff in model registry, where I can basically evaluate the quality of the model. Earlier, I built a model in BigQuery when I was doing my diabetes demo example. One of the steps when I was going through those setup scripts is it went over to BigQuery and it took that record of diabetes data that I have: gender, age, hypertension, heart disease, smoking history. There's that smoking history column. BMI, HbA1c, glucose. Does this person have diabetes or not? So, I got a table with 100,000 historical records of these different people. And, it's giving me information about the person and do they have diabetes or not. And I asked BigQuery to build a model for me. And the model, it has information in here that is used to help me evaluate how good is that model, right? So what's the model performance? We might say words like accurate, but accuracy is actually a specific type of metric, right? It's a specific type of evaluation. And you look right here, accuracy is one of the ways it evaluates this model. Okay. But do you see this metric down here? That's a fancy name metric. That is the area under the receiver operating characteristic curve. Yeah, that's a mouthful, right? Receiver operator characteristic area under the curve metric. And this, for like a category testing thing like I'm doing here, is probably one of the best metrics I can use. And what this is saying is, on a scale of percentages, so 0 to 100%, the quality of this model is somewhere around 96% quality. That's a pretty good quality model. In other words, if you give me that data that I just mentioned, those columns of information with, pretty good accuracy or pretty good, I'm pretty sure, how's that the answer I'm going to give you is going to be correct. All right. Workflow orchestration. You remember we talked about this kind of stuff? And I said, maybe step one is I gather the data. Maybe step two is I reformat the data and do some feature engineering. Maybe step three is I do some different training jobs to try different options. Maybe step four is I train the final model. Maybe step five is I deploy the model into production as long as the model quality is at least this much better than the old model. All those steps I'm describing, what I'm really describing to you is a workflow, right? I'm describing a workflow. And inside of Vertex AI, they have this whole subsection in here given over to pipelines. And pipelines are basically where you put together kind of a logical process. First, we're going to do this, then we're going to do that, then we're going to do the other. And every time you run the pipeline, it goes through those steps. So my get the data, massage the data in the right format, do some experimentations, that would be the steps I put in my pipeline. And then model monitoring, model monitoring is where I'm literally going to monitor the models out there. How many people are using this model per day, or per minute or per second or whatever else, that's kind of monitoring stuff. What kind of server load is the model giving me, monitoring of what's happening. Okay. You need to track experiments, manage different versions of your model, and keep a record of changes. Choose the Vertex AI tool that best suits your needs. Is that monitoring? Is that orchestration? Is that the model registry? Track experiments, manage different versions of your model, keep a record of changes. Yeah, mostly I think they're probably talking about the registry. What throws me a little bit is when they start talking about, track experiments. Doing experiments might be more like a orchestration thing. But I think when they're saying, we have experiments that are creating like different versions of the model or something. And so we're really focused more on the model itself and different versions and the quality of different versions. That's more registry stuff. Your deployed model's performance is declining, and you need to identify the cause and retrain it. What tool would best help you figure that out? I think that's probably monitoring, right? Because how do I know the quality is declining? How can I identify the cause? Is there a shift in the data patterns? Do I see shifting in the data itself? And the shifting in the data itself might be illustrating, like a new kind of fraud. And is that why? Since the data patterns are changing, the model is not so good with the new data patterns. Monitoring would help me figure that stuff out. You want to automate your entire pipeline from data processing to model deployment. That's your orchestration. That's your Vertex AI pipelines, right? And do you see here, the question says pipeline and the answer says orchestration? Couldn't you imagine a question where they say you want to automate your workflow, your entire ML workflow? What would help you do that? And the answer would be Vertex AI pipeline. Yeah. That's actually what they call these guys, by the way. They don't call it workflow. They call it Vertex AI pipelines. That's the technical name. Workflow is like a description of what that is. So when you're looking at these questions, sometimes imagine, how might they ask this same question different? What would the negative of the question be? Or, something like that. Or is there terminology that we could exchange here? Yeah. The models layer, the model is that reasoning engine, right? Said this morning, it can read or consume content. It understands it in a very human kind of way. And when it responds, it can respond in a very human kind of way, right? So it's not a true analog, but I keep using this analogy of, I imagine I've hired this person to do this job. And that's kind of what I'm thinking here, right? Because there's a lot of things I could ask a person to do that I can't ask a typical computer system to do, right? Because a person comes in with certain skills. A person knows certain facts. If I mention Frankenstein in the middle of a conversation, I would expect most people to at least kind of sort of know what I'm talking about, right? Whether they're an old movie buff or not, or a book buff, right? So it's the same thing with a model. I would expect a model to know kind of who Frankenstein is. If I say, wow, your design kind of reminds me of Frankenstein, I'm probably not flattering your design, right? And the model would understand that. So it's trained on massive amounts of data. And it is a sophisticated mathematical structure. But the fact that it's kind of an autonomous reasoning engine, that's something that it can do that, other things can't. Now, I'll also say what I was describing is a generative system. This course is a generative AI leader certification course, but in generative AI leadership, they expect you to at least be conversant in general AI terms. When we were talking about machine learning training types, supervised, unsupervised, reinforcement learning, that's not really a generative AI discussion. That's more a general purpose AI discussion, right? Yeah, because there's a lot of problems that you can solve with regular AI that's not necessarily generative AI. So if you're talking models in general, yes, it's a mathematical system. You put inputs in one side, it does something for you. It gives you an answer out the other, right? Okay, where are you going to find your model? Where are you going to find your model? Well, if you came to me and you said to me, um, if you came to me and you said to me, I have a problem and I think AI and Google Cloud can help. Where should I start? If you came in and you said that to me, I have a problem and I think AI and Google Cloud can help. Where should I start? My checklist in my brain would kind of look like this. 1A, is this a well-known problem that Google has already solved? Then why don't we use the Google pre-trained model? So the first thing I would say is that, hey, is this a problem that's well known that Google has already solved? Then why don't we use Google's pre-trained model? This is things like Google Translate. This is speech to text. And stuff like that. So these are well-known problems. Google has a solution. I don't want to build my own translation model. Google Translate does a good job, right? Gemini does a good job. Oh, yeah. And by the way, Gemini is up here in this list. Gemini is there's a well-known problem, generative AI. Google has built a solution to it. Let's use it. A variation on this theme for me would be, is this a well-known problem with a open source solution we could leverage? We might want to check the model garden and or Hugging Face. The mall garden. I'm using dictation here, and my Apple dictation is pretty good with general stuff, but it's always funny when it's hits a technical term and it's not really sure what I'm talking about. So is this a well-known problem with an open source solution we could leverage? We might want to check the model garden and or Hugging Face. Hugging Face is an AI community, right? That's sort of what Hugging Face is. I showed you guys a little earlier. Hugging Face has, 2.5 million models out here. Now, I'm not saying that I trust 2.5 million models. These are all open source models. Some of them are built by some person I've never heard of before, and it's their pet model, and they built it and they uploaded it. Hugging Face makes sure there's no malware in it. But is that model actually any good quality-wise? Yeah, but even if you say you only trust 10% of these models because they're from really well-known organization, you're still talking about like 250,000 models. There's an awful lot of models. Yeah, look at this. Grok, there's an awful lot of models up here that are well-known models that are coming from well-known organizations, and can we use one of those models? The model garden in Google Cloud is kind of a page where Google sort of says to you, these are really important models in the AI world. Okay. Don't get me wrong, 124 of them are from Google, but there's also 146 of them. They're just simple open source models, right? And I'm looking through these models and I see Google model, Google model, Google model, Llama. Llama is one of your most popular fine-tunable language models out there. It's from the Meta organization. Google invented Gemma as a competitor to Llama, right? You see Hugging Face. Yes, I can load any of those 2.5 million models from Hugging Face directly into Google Cloud to run it. Remember, a model needs to run somewhere. Well, I could run any of those models over here. Do you see Anthropic Claude? I could run here. So there's lots of models in here. Some of them are from Google. There's DeepSeek. That's that Chinese model you may have read about before. There's a lot of models out here that didn't come from Google that might help us out. So that would be kind of my second one. Use models within Model Garden because they've got hundreds of models. Some of them are directly from Google. Some of them are from, are open models from Google and other organizations. And there's lots of third-party models out there as well. What if you can't get the model you want by finding it from someone else? Well, then, yeah. If 1 and 1A, which are both kind of find somebody else's model and use it, don't work for you, then sure. My answer 2 might be, is it a problem that AutoML could solve for you without you writing any code yourself? Yeah, it had it right, and then it totally screwed it up. Is it a problem that AutoML could solve for you without you writing any code yourself? That's kind of what AutoML is. AutoML is like a no-code AI ML creator. So AutoML, when I said, is it a problem that AutoML could solve? These are problems AutoML could solve. Image classification, object detection problem. A image classification problem is, here's a picture of a cloud. Can you figure out, is this a cumulonimbus cloud or is this a cirrus cloud? If you go to Google has a image processor, and they call it Vision AI. If you go to Vision AI, Vision AI can say things like, that's a cloud, that's a bird, that's a tree, but it doesn't know what kind of cloud you have. In AutoML, I could say, Here's 50 pictures I've collected of cumulonimbus clouds. Here's 50 pictures I've collected of cirrus clouds and all the other cloud types. Can you figure out how to tell the difference between clouds if I show you a picture of the sky? And it could do it, right? So AutoML is an automated system that builds AI models for you. Object detection is like when you want to put a box around it in the picture. Tabular data, classification problems. Is it this or that? Small, medium, large, extra large, classification kind of problems. Regression problems are more, I want to predict a numeric value. Monday morning at 9 a.m., what's the Google stock price going to be? That's a regression problem. I'm going to put my house up for sale next week. Hey, Zillow, what should my asking price be for my house? That's a regression problem. Forecasting is typically seasonal forecasting. Can you study our, say, sales trends or our purchasing trends over the last X amount of time? Now, could you predict on this particular day of that particular month, can you predict, some sales figure? That's more forecasting. So when I say, are there problems that, you can solve without you writing any code? AutoML would help. Now, this class doesn't really talk about what my option number 3 would be, which is your data in BigQuery and do you know SQL? Then you might want to try BigQuery machine learning. Yeah. Is your data by? No, that's not quite what I want. Is your data in BigQuery? Is your data in BigQuery? Oops. Sorry. I freaking did it again. Okay, let me try that one. What am I doing wrong? Query. Okay. Is your data in BigQuery and do you know SQL? Wrong spelling. Then you might want to try BigQuery machine learning. Yeah. BigQuery machine learning, as I told you guys earlier, is sort of a pseudo SQL, right? I take people who know SQL, they live and breathe it. They can understand SQL. They know how to query data with it. They're comfortable with that. And I say, guess what? I know you might not be a Python developer, but hey, let me show you a way that you can train your own models right there in BigQuery. You're still in SQL. It's still kind of sort of comfortable to you. It's something else you have to learn, but you can build machine learning models using that. And that's kind of another interesting step. My last step on the list, the step I don't have to go to on the list, is if nothing else works, or if there's something that precludes the other options, then you always could build the model yourself using Vertex AI and some Python framework like TensorFlow. Yeah, I'm not even going to try dictation. TensorFlow or scikit-learn or, so if nothing else works, right? If nothing else works, or if there's something that precludes the other options. I was just at an insurance company and they were building their own model. And I looked at this model and I'm like, why are you guys building your own model? I could find you 100 models on Hugging Face that would do this for you. You'd be done this afternoon. And they said, yeah, but we're an insurance company. And when I didn't apparently register why that made any difference, they said, we are so tightly regulated that we can't use these models because it's virtually impossible to get them past regulatory compliance. So even though it's kind of stupid, we're building the model ourselves because that's the only way we can get past regulatory compliance. Okay, that would be if something else precludes it. So my checklist would look something like this. Is it a problem that Google has already solved or someone else has already solved? 1A, 1B. Then look at the model garden. Google's got a lot of models. Hugging Face has a lot of models. There's lots of good models out there. If you got to build the model yourself, then you might start by looking at AutoML because it can build a model for you basically with a big wizard, which is going to be cheaper than any, I can't say, let's build the model ourselves for what it's going to cost me to do AutoML. So AutoML is pretty darn cheap. If you got to build the model yourself, they don't talk about BigQuery ML, as I said. So if you have to build the model yourself, You're going to have to go through those steps we talked about. You're going to have to gather data. You're going to have to prep data. You're going to have to train a model. And then, of course, if you're building the model yourself, we got that whole little step in the middle there somewhere called code the model, right? We would have to code the model as well if we're building the model ourselves. So Vertex can absolutely help. There's pain points that you face when you build a model yourself, and Google knows them all. So Google can definitely help you build a model, but there's going to be pain somewhere. There's going to be specialized skills, specialized work, software development. Yeah. Okay. You need a model to translate languages for your global e-commerce platform. You want a readily available, high-performing solution. You have a moderate budget. Build your own model, AutoML, Model Garden. Model Garden. We can find translation models. Google's got them. There's other models out there. So this is don't build it, find it, use it. You're an experienced AI researcher developing a cutting-edge model for protein folding prediction. Now that I've taught a class for drug research, protein folding is part of drug research, right? They fold protein to make different kinds of molecules for drugs. And the protein folding prediction is this a stable molecule? And also, do we think it's going to have adverse reactions if we feed it to a human? Right? That's what protein folding is. And Google's got a big fancy model that they've built for drug researching that helps you do that. Anyway, having said all that, if you get to this question and you're like, oh my gosh, what is protein folding? You will see questions where they throw some terminology in there and they honestly don't expect that you have any idea what that is. So when I first read this, I had never heard of protein folding. And I'm thinking, what the heck is protein folding? Take a deep breath, right? Because there's a good chance it's just extraneous information. You are an experienced AI researching, developing a cutting edge model for blah, blah. It doesn't really matter. Prediction. You need complete control over the model architecture and training process. Which is the AI model that best suits your needs? In other words, which is our approach out of my checklist, right? Well, if you say really the question is ignore the first sentence completely. You need complete control over the model architecture and training process. What are you going to do? Well, you're going to build it yourself. That's my insurance company story. You got to have complete control. That's the only way you're going to get it. I hope we don't have to go there. I hope we can find something. But if you got to build it yourself, you got to build it yourself. Okay. Okay, we'll do these last couple of questions and we'll call it a day. Agent versus model. Read the scenario and related tasks. Identify which layer handles the respective task. Is it an agent or is it a model? Put your answer in chat. Well, an AI-powered writing assistant that helps users write different kinds of content, including social media posts, articles, or scripts, right? Tasks. Which layer generates grammatically correct content? Which layer identifies and applies appropriate guidelines? The thing that's doing grammar, is that a model or is that an agent? It's probably the model that does grammar. That's something it can do intuitively. I don't have to teach it to do grammar. It knows how to do that. Which layer identifies and applies appropriate guidelines based on the type of content, right? Well, if there's specific guidelines for our organization, like our branding guide or something, that would be the agent. If you want something general purpose, like MLA guidelines or something, the model could do that. But I think they're implying that these are like guidelines for our company or something that's specific. That's more agent stuff. All right, good. Whew. It's fajita time. Sorry. Thinking out loud. I think that's about as far as we're going to go today. We're just about out of time. Remember, we have a document out here. If you haven't already found your link to the document, tinyurl.com, Gale0129, tinyurl.com, Google-Gale is my PDFs I'm lecturing. Remember, office hours coming up next Friday. There's a LinkedIn group you're welcome to now join. Yes. And if you want to contact me outside of class, you're welcome to. But some of you, I noticed, contacted me this morning while I was teaching. Obviously, I'm not checking email so much while I'm teaching. So if you have technical problems, emailing me might not be as good as emailing Gail Cert Workshop. They're actually going to be there while I'm teaching. So just keep that in mind. All right. Thanks, guys. Hope you enjoyed day one. Learned lots of good stuff. Looking forward to seeing you guys tomorrow morning, 9 a.m. Pacific time. I'll see you then. Have a good evening.